Hello everyone, welcome to today's session on data structures and algorithms from Intellipaat. Do you know that data structures and algorithms are fundamental concepts in computer science and they play a crucial role in solving complex problems efficiently? Data structures are containers that organize and store data, while algorithms are step-by-step procedures used to manipulate and process that data. Data structures provide different ways to store and organize data, each with its own strengths and weaknesses. Common data structures include arrays, linked lists, stacks, queues, trees, and graphs. These structures determine how data is accessed, inserted, and removed and impact the efficiency of all the operations. Algorithms, on the other hand, are a set of instructions designed to solve specific problems. They use data structures to process and transform the input data into desired output. Algorithm can be categorized into various types such as searching, sorting, and dynamic programming. Understanding data structures and algorithms allows programmers to choose the most appropriate structure and algorithm for a given task. Optimizing performance and resource utilization, it also enables them to evaluate and improve existing solutions, leading to more efficient and scalable software. Now, before we move on and learn more about data structures and algorithms, do not forget to subscribe to Intellipaat and hit that bell icon for more updates from us. Let's take a look at the agenda for this session. So we're going to be starting with introduction to data structures and algorithms. We'll also be covering what is coding and different types of programming languages. We'll be covering what is Java and Java operators. Moving further, we'll take a look at different type of loops, conditional statements, and switch statements as well. We'll be covering Java array list. After covering the 2D arrays in Java, we'll be taking a deep dive into different data structures such as stacks, queues, linked lists, searching and sorting algorithms as well. And in the end, we'll be covering a few data structure interview questions as well.
So let's begin by talking about what are data structures. Data structures are significant concepts in computer science that aid in developing efficient programs in any language. In general, a data structure is a way of organizing and storing data in a computer program so that it can be accessed and used efficiently. Python is a high-level, interpreted, interactive, and object-oriented scripting language that allows us to explore data structures basics in a more straightforward manner than other programming languages. Using appropriate data structures can help make your code more efficient, especially when dealing with large amounts of data. Now let's look at what are algorithms. An algorithm is a step-by-step technique that outlines a collection of instructions that must be followed in a specific order to get the desired result. Algorithms are often developed independently of underlying languages, meaning an algorithm can be implemented in multiple programming languages. From the data structure point of view, the following are some important categories of algorithms. Starting with search, an algorithm to search an item in a data structure. Sort is an algorithm to sort items in a certain order. Insert is an algorithm to insert an item in a data structure. Update is an algorithm to update an existing item in a data structure. And finally, delete is an algorithm to delete an existing item from a data structure. Now we'll see why are data structures and algorithms important. Data structures and algorithms are important for several reasons. First, they allow programmers to write efficient and scalable code that can handle large amounts of data. Second, they provide a common language and set of tools for solving problems in computer science and related fields. Finally, understanding data structures and algorithms is essential for working with and contributing to open source software projects and passing technical interviews. Now let's talk about time and space complexity. In computer science, there is always more than one way to solve a problem using multiple algorithms. As a result, it is critical to apply a method to compare the answers in order to determine which one is optimal. The method must be independent of the system and its setup on which the algorithm is running. The number of inputs has a direct correlation and can differentiate between two algorithms without ambiguity. There are two such methods used, that are time complexity and space complexity. Let us talk about time complexity. An algorithm's time complexity estimates the amount of time it takes to run as a function of the length of the input. It should be noted that the time to execute is determined by the length of the input rather than the actual execution time of the machine on which the algorithm is operating. Now let's talk about space complexity. When utilizing a computer to solve a problem, memory is required to store temporary data or the ultimate solution while the program runs. The amount of memory required by the algorithm to solve a particular problem is referred to as the algorithm's space complexity. The space complexity of an algorithm estimates the amount of space required to perform an algorithm as a function of the input length. Now we look at different types of data structures. Data structures are fundamentally divided into two types. An array is a data structure that stores a collection of elements of the same data type in contiguous memory locations. The elements of an array are accessed using an index which represents the position of the element in the array. Arrays are a fundamental data structure in computer science and are used in a wide variety of applications. They are particularly useful for storing and manipulating large amounts of data efficiently, as accessing an element in an array can be done in constant time. In Python, arrays can be implemented using the built-in array module in the standard library or using the more powerful NumPy library. So let's look into implementation of arrays using the array module. The array module in Python provides a simple implementation of arrays that can be used to store homogeneous data. Here is an example of how to create an array of integers using the array module. In this example, we import the array module from the standard library and create an array of integers using the array function. The first argument to array specifies the type of elements in the array, in this case I for integers, and the second argument is a list of the initial values for the array. We can then access the elements of the array using indexing, just like with a list. For example, ARR of index 0 would give us the first element of the array, which is 1. The array module supports several different data types, including signed and unsigned integers, floating point numbers, and characters. Now let's look at implementation of arrays using NumPy. NumPy is a powerful Python library that provides support for multidimensional arrays and a wide range of mathematical operations on them. Here's an example of how to create a NumPy array in Python. Now let's move on to stack. Stack is a linear data structure in computer science that stores a collection of elements and provides two main operations, push and pop. The push operation adds an element to the top of the stack, and the pop operation removes the top element from the stack. Stack follows the last in first out principle, which means that the last element to be added to the stack will be the first one to be removed. Stacks are used in a wide variety of applications such as expression evaluation, backtracking algorithms, and function call management. Now we'll look at the implementation of stack. In Python, stacks can be implemented using an array or a linked list. Here's an example of how to implement a stack using an array. In this implementation, we define a stack class that uses a Python list as the underlying data structure. The push method adds an element to the top of the stack using the append method of the list. The pop method removes the top element from the stack using the pop method of the list. The peek method returns the top element of the stack without removing it, and the empty method checks if the stack is empty. To use the stack, we first create an instance of the stack class. We can then push elements onto the stack using the push method. We can remove elements from the stack using the pop method. We can then check the top element of the stack using the peek method. And we can check if the stack is empty using the isEmpty method. Now let's move on to queues. Queue is a data structure that stores a collection of elements in a specific order. The main characteristic of a queue is that it follows the first in first out principle, where the first element added to the queue is the first one to be removed. A common analogy for a queue is a line of people waiting for a service, such as a ticket counter or a ride at an amusement park. The first person to join the line is the first to be served, and the last person to join the line has to wait for everyone else to be served first. There are two types of queues. A linear queue is a basic queue that follows the first in first out principle, where elements are added to the end of the queue and removed from the front of the queue. Whereas in a circular queue, a queue that uses a circular buffer to implement the queue. This allows for efficient use of memory and faster execution, but requires careful handling of edge cases. So let us now look at the implementation of queue using the queue module. In Python, a queue can be implemented using the queue module, which provides the queue class that implements a synchronized queue. The queue class can be used to implement both FIFO and LIFO queues depending on the argument passed to its constructor. Here is an example of implementing a FIFO queue using the queue class. In this example, we create an instance of the queue class and add 3 elements to it using the put method. Then, we remove the elements from the queue using the get method, which returns the first element that is added to the queue. Alternatively, we can implement a queue using an array in Python. Here's an example of implementing a FIFO queue using an array. In this implementation, we define a queue class that uses an array to store the elements. The enqueue method adds an element to the end of the queue using append method, and the dequeue method removes an element from the beginning of the queue using the pop method. The isEmpty method checks if the queue is empty, and the size method returns the number of elements in the queue. Now let's move on to linked list. A linked list is a data structure that stores a collection of elements in a linear order. Unlike an array, which stores the elements in a contiguous block of memory, a linked list stores each element in a separate object called node. Each node contains both the element and a reference to the next node in the list. The main advantage of a linked list over an array is that it allows for efficient insertion and removal of elements at any position in the list, since we only need to update the references of the nodes before and after the inserted or removed element. However, accessing an element at a specific position in a linked list requires traversing the list from the beginning, which takes big O and time complexity on average, where n is the number of elements in the list. Now let's look at the type of linked lists. Starting with singly linked list, a linked list where each node contains a reference to the next node but not to the previous node. Then there is doubly linked list, a linked list where each node contains a reference to the next node and the previous node. And finally, circular linked list, a list that consists of nodes connected by edges. Each node in the tree represents a value or element, and the edges represent the relationship between the nodes. The topmost node in the tree is called the root, and every other node is a descendant of the root. Nodes that have the same parent are called siblings, and no nodes with children are called leaves. Let us look at the type of trees. Moving on to binary search tree, where a binary tree where the left child of a node contains a value smaller than the parent and the right child contains a value larger than the parent. This allows for efficient searching and sorting of elements. Next is AVL tree, a self-balancing binary search tree where the heights of the left and right subtrees at any node differ by at most 1. This ensures efficient searching and insertion of elements. Finally, red-black tree, another self-balancing binary search tree that maintains a balance between height and node count. This ensures efficient searching and insertion of elements while also providing a guarantee that the height of the tree will not exceed big O of log n complexity. Now let's look at the implementation of trees. In Python, we can implement a tree using a node class that contains the element and references to its children. Here is an example of implementing a binary tree. In this implementation, we define a node class that contains the element and references to its left and right children. We also define a binary tree class that contains a reference to the root node. The isEmpty method checks if the tree is empty, and the insert method inserts a new node containing the element at the first available position in the tree. The search method searches for a node containing the element in the tree using a breadth-first search. Finally, the print tree method traverses the tree in a breadth-first order and prints the elements. Let's move on to the next data structure, that is graphs. A graph is a data structure used to represent a set of objects called vertices or nodes and the connections that are called edges between them. Graphs are a flexible and powerful tool used to model and solve a wide range of problems from network routing to social network analysis. Graphs can be either directed or undirected. In a directed graph, the edges have a direction and represent a one-way relationship between the vertices. In an undirected graph, the edges have no direction and represent a two-way relationship between the vertices. Graphs can also be weighted or unweighted. A weighted graph is one in which the edges have a weight or cost associated with them. An unweighted graph is one in which all edges have the same weight. Graphs can be implemented in several ways. One common way is to use an adjacency matrix in which two-dimensional arrays that represent the connections between the vertices. The value in cell ij of the matrix represents the weight of the edge from the vertex I to vertex j. If there are no edge between the two vertices, the value is often set to infinity or a large number. Another way to implement a graph is to use an adjacency list, which is a list that contains all vertices in the graph and the edges that connect them. Each vertex in the list has a corresponding linked list that contains vertices to which it's connected to, along with the weight of the edge. Now let's move on to implementation of graph using adjacency list. Here is an example of how to implement an undirected, unweighted graph using an adjacency list in Python. In this implementation, the addVertex method adds a vertex to the graph, and the addEdge method adds an edge between the two vertices. The printGraph method simply prints out the graph in a readable format. Here is an example of how to use this implementation to create and print a graph. As you can see, the output is displayed on the screen. Moving on to hash tables. In data structures, a hash table is a data structure that stores key value pairs in an array-like structure where the keys are hashed to unique indices in the array using a hash function. Hash tables are used to implement associative arrays or mappings of key value pairs where lookup, insertion, and deletion operations can be performed efficiently in big O of 1 time complexity on average. In Python, hash tables can be implemented using dictionaries, which are built-in data structures in Python that store key value pairs. Python dictionaries use a hash function to hash the keys to unique indices in the hash table and handle collisions using a technique called open addressing with linear probing. Now let's look at the implementation of hash tables using dictionaries. In this implementation, the hash table class is defined with two methods, insert and get. The insert method takes a key value pair as an input and stores it in the hash table using key as the index. The get method takes a key as input and returns the value associated with that key in the hash table. Now let's move on to types of algorithms. Starting with sorting algorithms. Sorting is a fundamental operation in computer science that involves arranging elements in a collection in a particular order. There are several sorting algorithms that have been developed over the years, each with its own advantages and disadvantages depending on the specific use case. Let us look at bubble sort. It compares adjacent elements in a list and swaps them if they are in the wrong order, repeatedly iterates through the list until no swaps are necessary. Its time complexity is big O of n square and its space complexity is big O of 1. Moving on to selection sort, it finds the smallest elements in a list and swaps it with the first element and repeats this process for the remaining elements in the list. The time complexity of selection sort is big O of n square and the space complexity is big O of 1. Moving on to insertion sort, it builds a sorted list by iterating through an unsorted list and inserting each element into its proper position. The time complexity is big O of n square and the space complexity is 1. Moving on to merge sort divides a list into two halves, recursively sorts each half and then merges the two halves together. The time complexity is big O of n log n and the space complexity is big O of n. Moving on to quicksort picks a pivot element in a list and partitions the list into two halves around the pivot such that all elements to the left of the pivot are smaller and all elements to the right are larger. It recursively sorts the two halves of the list. The time complexity for quicksort is big O of n log n and the space complexity is big O of log n on average and big O of n on worst case. Moving on to heap sort, it builds a heap data structure from the list and repeatedly extracts the minimum element from the heap, which is placed at the end of the list. The time complexity for heap sort is big O of n log n and the space complexity is big O of 1. Next on the list is counting sort. It counts the number of occurrences of each element in a list and uses this information to sort the list. It only works for non-negative integers or values within a certain range. The time complexity for counting sort is big O of n plus k, where k is the range of values in the list, and the space complexity is big O of k. The final algorithm on the list is radix sort. Sorts elements in a list by considering their individual digits or bits from the least significant to the most significant. It requires a stable sorting algorithm as a subroutine. The time complexity of radix sort is big O of d into n plus k, where d is the number of digits or bits in the elements and k is the range of values in the list. And the space complexity is big O of n plus k. Now let's move on to searching algorithms. Searching is a common operation in computer science and is used to find the location or value of a particular item in a collection of data. Searching algorithms are used to perform these operations efficiently and effectively. There are several searching algorithms that are commonly used in computer science, starting with linear search. Linear search is a simple search algorithm that works by sequentially checking each element of the collection until a match is found or the end of the collection is reached. It has a time complexity of big O of n, where n is the number of elements in the collection. Linear search is typically used on small collections or unsorted collections. Next is binary search. Binary search is a more efficient search algorithm that works by dividing the collection in half and comparing the target value to the middle element. If the middle element is equal to the target value, the search is successful. Otherwise, the search continues on the left or right half of the collection depending on where the target value is greater or less than the middle element. Binary search has a time complexity of big O of log n, where n is the number of elements in the collection. Binary search is typically used on sorted collections. Next is interpolation search. Interpolation search is a variant of binary search that works best on collections that are uniformly distributed. Instead of dividing the collection in half, interpolation search uses a linear interpolation to estimate the position of the target value. The estimated position is then used to determine which half of the collection to search next. Interpolation search has an average time complexity of big O of log n, but can have a worst time complexity of big O of n. Moving on to jump search. Jump search is a search algorithm that works by jumping ahead a fixed number of elements and then checking if the target value is less than or equal to the current element. If the target value is less than or equal to the current element, linear search is used to find the target value within the current block. Otherwise, the process is repeated with a new block. Jump search has a time complexity of big O of root n, where n is the number of elements in the collection. Next is exponential search. Exponential search is a search algorithm that works by first finding a range that contains the target value and then performing a binary search within that range. Exponential search begins by checking the first element of the collection and then doubling the position of the search until either the target value is found or the end of the collection is reached. Exponential search has a time complexity of big O of log n, where n is the number of elements in the collection. Last is hashing. Hashing is a technique used to map a large and potentially infinite set of inputs to a smaller set of outputs. In the context of searching, hashing can be used to quickly find the location of a target value within a collection. Hashing works by taking the target value and mapping it to a specific index in a hash table. The value at the mapped index is then checked to see if it matches the target value. Hashing has a time complexity of big O of 1 on average, but can have a worst case time complexity of big O of n. Now let's move on to graph algorithms. Graph algorithms are algorithms used to solve problems on graphs, which are mathematical structures consisting of vertices and nodes and edges connecting them. These algorithms are widely used in applications such as social networks, transportation systems, computer networks, and more. Here are some popular graph algorithms, starting with depth-first search. DFS is a traversal algorithm that starts at a specified vertex and explores as far as possible along each branch before backtracking. It is implemented using a stack and can be used to check if a graph is connected, find strongly connected components, or detect cycles. Second is breadth-first search. BFS is another traversal algorithm that starts at a specified vertex and explores all the neighboring vertices before moving to the next level. It is implemented using a queue and can be used to find the shortest path between two vertices. Third is Dijkstra algorithm. Dijkstra algorithm is used to find the shortest path between two vertices in a weighted graph. It works by maintaining a priority queue of vertices and their distances from the source vertex and repeatedly selecting the vertex with the minimum distance and updating the distances of its neighbors. Next is Bellman-Ford algorithm. Bellman-Ford algorithm is also used to find the shortest path between two vertices in a weighted graph, but it can handle negative edge weights. It works by relaxing the edges in the graph repeatedly until the distances converge. Next on the list is Kruskal's algorithm. Kruskal's algorithm is used to find the minimum spanning tree of a weighted undirected graph. It works by sorting the edges by weight and adding them to the tree one by one, making sure not to create any cycles. Finally, Prim's algorithm. Prim's algorithm is also used to find the minimum spanning tree of a weighted undirected graph. It works by starting with an arbitrary vertex and adding the closest edge to the tree one by one, making sure not to create any cycles. Let's talk about dynamic programming. Dynamic programming is a technique used in computer science to solve problems by breaking them down into smaller, more manageable subproblems. The idea behind dynamic programming is to avoid redundant work by storing the solutions to previously solved subproblems in a table and using those solutions to solve larger problems. Dynamic programming is especially useful for problems where the solution can be recursively defined in terms of smaller subproblems. Some examples of problems that can be solved using dynamic programming includes the knapsack problem, the longest common subsequence problem, and the Fibonacci sequence. To implement dynamic programming, we need to follow a few basic steps. First, define the problem in terms of subproblems. In order to use dynamic programming, we need to be able to break the problem down into smaller subproblems. For example, if we are trying to find the longest common subsequence between two strings, we could break down the problem into finding the largest common subsequence between each prefix of the two strings. Next is defining the base case. The base case is the simplest version of the problem that we can solve directly. For example, the base case for Fibonacci sequence is that f of 0 equals 0 and f of 1 equals 1. Next is defining the recurrence relation. The recurrence relation is the formula we use to calculate the solution to a subproblem in terms of the solutions to a smaller subproblem. For example, the recurrence relation for the Fibonacci sequence is f of n equals f of n minus 1 plus f of n minus 2. Another technique in dynamic programming is memoization. Memoization involves storing the solutions to subproblems in a dictionary or some other data structure. When we need to solve a new subproblem, we first check if we have already solved it. If we have, we return the stored solution. If not, we calculate the solution and store it for future use. The next important topic in dynamic programming is tabulation. Tabulation involves creating a table to store the solutions to subproblems. We start by solving the base case and filling in the table with the solutions to smaller subproblems. We then use the table to solve larger subproblems until we reach the solution to the original problem.
Just a quick info, guys. Intellipaat offers full stack web developer course in collaboration with E&ICT Academy IIT Guwahati. Through this course, you can learn everything from front-end web development to back-end web development from esteemed IIT Guwahati faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of web development.
So the very first thing that we are going to discuss about is what exactly is coding? What exactly is programming? Now, coding has multiple synonyms. Some people call it coding, some people call it programming, some people call it scripting, okay? But anything that you write on a computer and make it do stuff, that is coding, scripting, programming, right? So these all are synonym. So very first thing in a very basic, that's the base of everything. Whatever you'll be doing for the next course, it will be coding itself, right? So what exactly is coding? Now, in a very simple term and in a very simple explanation, if I can talk about what is exactly coding, is just writing instructions, right? Codes or code are instructions. For example, you have a chef, right? Or let's for example, you are a chef and you have an assistant and you want your assistant to prepare a dish and you give your assistant a set of recipes, right? Recipe is a list of instruction following which your assistant can prepare that particular dish, correct? That's exactly our code. While when you code, you become chef, the computer become your assistant. You give instructions to computer around what are the steps or what are the instructions the computer needs to follow. Now, goal could be anything. Goal, if we are not bothered here about the goal of the code when we talk about what is coding. Irrespective of the goal, right? Whatever goal could be, you make the computer to achieve that goal with the help of instructions. And you put the instructions, and when you write it, that's exactly is what coding is. So in simpler terms, code or coding is instructions. Code are instructions. Coding is the process of putting instructions into the computer. All right, that's exactly it is. Now, why it is required? Okay, why do we need to give instructions in a form which is way different than we talk, right? I mean, if you have a human assistant, will you give him the instructions in terms of writing something which is way different, right? Writing something like codes and all that? No, I can just tell him if I'm giving someone a recipe of, let's say, making a tea, right? I would not type on a computer in a gibberish manner and give him that, right? I could just tell him, get milk, get tea leaves, boil the milk, put tea leaves, and all that stuff, right? That's the native language. It's a simple language. I can do that. Why can't we do that with the computers? Now, the reason is computer does not understand our language. It's not meant to be. The way computer has been made, they are not meant to understand the language we speak, right? They understand only one language. What's that language? It's the binary language, okay, the binary code. Only zeros and ones. They understand, they function, they think, or they execute only in binary, zero and ones, right? Computer can understand only the instructions in binary code. So we need to have a middle ground. We, as in the humans and the computers, need to have a middle ground where we both can understand it can act as an interface where we both can communicate. And that's where coding does. You write code that gets executed in the computer, and the computer understands by converting your code into a binary code. How that conversion happens, we'll come to that later. But coding is basically you write code by learning how to code, and then it makes easy for computer to execute that code and convert that particular code into a binary language. And hence computer is able to understand your language, and we are able to, let and make computer do things that we want them to.
Let's have a quick quiz question, guys. And the question is, which data structure follows the first in, first out principle? And your options are stack, queue, linked list, or tree.
Okay, that's it. That's about it. Now, here comes what is programming languages then. Now, we talked about that what is coding, right? That is simple. That it's a way to communicate with computers. Okay, coding is required because computers can't understand our language. They need to have certain aspect of the middle ground where they can understand a language that is binary. We understand that, but again, there are why there are multiple programming languages then? Why can't we stick to one language? Because all the language in the end converts their code and gets executed in a binary language which computer can understand. For example, Python. Python does the same thing. You write something in Python, you execute the Python code, computer understands it by converting it into a binary language, right? When this is already happening and computer is able to understand, why do we need multiple programming languages? Why do we need Java? Why do we need C++? Why do we need Pascal? Right? All are doing the same thing, right? All are making it to change into a binary language.
Let's have a quick quiz question, guys. And the question is, which of the following is a linear data structure? And your options are array, AVL trees, binary trees, or graphs. Please mention your answers in the comment box.
Even though one programming language is enough to convert our native language into binary language, maybe different system use build up with specific language. Maybe different system use build up with specific language. Okay, I did not clearly understand, but I got the gist of it. What you're saying is maybe different system are built up to understand a specific language. Okay, different ways of viewing problem solving, different perspective. We have multiple programming languages. The only reason of having multiple programming languages is we have different use cases. Now, what do I mean by use case? Use case, you can relate it with goals. Okay. For example, you want to build a mobile application, or let's say, what's the most complex mobile application we have nowadays? Instagram, we have, right? Everything is coming on Instagram. We have reels, we have stories, we have post. You can put a number of things. You can, there's a video call feature as well, chat feature as well. So it's a heavy app. You have a lot of things in that, right? That's one thing, right? Other thing that you can think of is a calculator, a physical calculator, not the phone calculator. Imagine a physical calculator. Okay, both have been built by code, right? But compare the complexity of these two. Instagram app has n number of features, has millions of users at the same time interacting with each other, right? On the other hand, there's a physical calculator which works on a battery, which has just small rectangular screen, which is black and white. I mean, it's not even white, it's just black or no black, right? and you can just see numbers, you can just calculate. There is only arithmetic operations possible. That's it. There's a drastic difference between the two. Now, do you think the same programming language can do the same way? I mean, just by sticking to one programming language, you can achieve both the aspect? Maybe true, maybe true. But one programming language, relying on one programming language can create a lot more complexity to achieve someone which is way complex than a calculator. Hence, we have multiple programming languages which are meant for different aspects. For example, HTML, CSS. I mean, I'm just throwing out language names. Okay, if that goes beyond your head, don't worry. These are not very much necessary to remember. I'm just giving you the examples. HTML, CSS, JavaScript. These are the languages meant for website development. You develop website something. React Native. It's very popular nowadays. Is meant for creating complex app, which uses state management, where you can see like Instagram, complex apps, right? Java or C++ are meant for computer applications that works in the backend servers, right? So probably in that physical calculator, C might have been used, or C++ might have been used, because they are very basic. On the other hand, if you want to do data analysis or machine learning, artificial intelligence, like Tesla has been built with artificial intelligence, the self-driving car. Okay, or we all have a phone that can tell you if it is gonna rain tomorrow or not, what is going to be the weather tomorrow, right? It's prediction. For such type of activities, Python are suitable because it has such libraries and it has the tools that can suffice that need, right? So over the time, the languages has grown in their own way, and they all have a niche of use cases. And according to that use case, we generally pick the language, and hence there are multiple programming languages. Okay, so I hope that is clear. And whatever I told, it's exactly written over here. So we have multiple programming languages, and the most popular ones are JavaScript, which is meant for website development. Whatever interactions that you see, animations that you see on websites, it's JavaScript. Python, I mentioned, data analysis, machine learning, artificial intelligence. Java is more on the web applications, Windows applications. The native core exe files are mostly on Java. Ruby, PHP are obsolete now, so don't worry about that. They are gone. Okay, so these were the aspects, and different languages can be used for web development. As I mentioned, JavaScript is meant for such tasks. Software and apps, you have a number of use cases over there, and different languages are used for that. Okay, so this was mostly about, you know, three things we covered, three major things. What exactly is code? What is coding, right? That's the first thing that you should be knowing about, right? Second thing that we covered is, why do we need coding? Because computers can't understand our language, and hence. And then we covered, why do we need multiple programming languages? Okay, now I would just give you a gist of certain terminologies. Okay, certain terminologies that are essential and you need to know them. Okay, this is something I have just written it by myself just before the class, because I don't want you to miss these 5 terminologies and get confused later on. Okay, so just have these in your mind. Okay, cool. So the very first thing is computer program. What is, I mean, you would see very often in your assignments, in your questions, that write a computer program to do XYZ, write a computer program to do set of this, right? Anything. So you should know what exactly is computer program. Computer program is nothing, again, it's basically saying you to write code. It's basically saying you to write the instructions step by step, right? That's exactly is computer program. Okay, so basically a computer program is a group of instructions given to a computer to be processed. The instructions are typically used to solve a problem or make long problems for humans shorter and easier. Okay, so computer program is just a piece of code that you put to the computer, and the computer processes it and gives the output according to what you have written. That's computer program. What is an algorithm? This is another term that you'll hear very often, an algorithm. Now, an algorithm is a procedure. Now, let me just give you a real world example of an algorithm. Okay, There could be, since we took a recipe, chef and recipe example, I'll again use the same example. There could be more than one way to prepare a same dish. Okay. Both the dish might be called same, but there might be certain differences in the two dishes because the way they were prepared were different. For example, I mean, I'm just taking random examples. I'm filing it over here, right? For example, you have been asked to prepare chicken chili, right? I mean, you can take any XYZ example, okay? Or maybe banana pancake, right? Anything, right? One chef followed the way of, if I take the example of banana pancake, he followed the way of first creating the batter by himself.
Just a quick info, guys. Intellipaat provides full stack web development course in collaboration with ENICT IIT Guwahati. The course link of which is given in the description below. Now, let's continue with the session.
Right, putting bananas and then putting the oats, putting some milk and then grinding it and then baking it and all that stuff. Another chef used an approach of getting it from the supermarket. You get the pre-processed dough, right? And then you just need to use it and bake it, right? They both used these two different ways, but what would be the end product called? Both will be banana pancakes, right? There is no difference. I mean, if I give it to someone, you won't be much worried about how it was prepared. You might be worried about how it tastes and how it looks like, but you would not be worried about how it was prepared, right? But both are banana pancakes, right? The procedure was different. The output is same. Okay. In computer world, in programming world, that procedure is called an algorithm. That's the simplest definition I just created over a call. This example just came in my mind itself. So that's the algorithm, the set of instructions done to solve a problem. Okay, that's the algorithm. So basically, one problem or one goal can have multiple algorithms. Just like one dish can have multiple procedures, one problem statement, one goal, if you want to achieve, can have multiple algorithms. Now, remember, I mentioned that you will worry about how it tastes, right? You might not be worried about how it was prepared and stuff, but how it tastes and how it looks, because presentation matters, right? You might be worried about that. In the same way, there are key factors in algorithm that at times you need to consider, right? It's slightly higher topic, but I'm still touching upon that because we have created a good example for you to understand, right? In algorithm, you care about how much time it took to solve that problem and how much space it occupied, right? Again, relating it with the chef example, right? Suppose chef one used, the whole kitchen to prepare that particular dish, and the whole kitchen got haywire. I mean, it's dirt everywhere. The utensils are unclean, right? Used to prepare that banana pancake, right? And the chef one also took more time to prepare the same. On the other hand, the chef two took less time, okay, and also did not, created a mess in the kitchen, but the end product is same. End product is same. Both taste equally good. Both is presentable. Which chef will you hire? Which chef will you hire? One or two? One took a lot of time, created a mess in the kitchen. Obviously two, right? Because he took less time. He did not, created a mess in the kitchen. In the same way, in algorithm, we consider two aspects. Any kind of procedure is if two developers or two programmers have written two procedures to solve a problem, two programmers have written to solve a problem, the problem that takes less time to compile and execute, that is one. And second, it takes less space, is considered to be a better problem. And here we touched upon two important elements of algorithm. One is time complexity and other one is space complexity. What is time complexity? What is space complexity? In the bare understandable words, you can understand time complexity is is basically a representation of how much time an algorithm took to solve a particular problem. That's all time complexity is. Space complexity is basically how much space an algorithm took to solve a particular problem. Time is pretty clear, that more time, less time. But what is space? Space is the memory, the RAM of the computer and all that stuff, which is something we'll touch upon later. But for now, you can just understand in this way. All right. Third thing that I wanted to discuss with you is compiler. What is compiler? Remember, I told you that we have a middle ground, me and a computer. The humans and the computer have a middle ground, which is a code, which is the programming language. I wrote something in the programming language, and computer converted that programming language into a binary language, which it can understand. Now, how it was able to convert from that code to a binary language? Okay, that is something is compiler used for. Okay, so compiler is basically a program that takes the code that you have written and translates into a binary ones and zeros of actual machine code. So that's a compiler. You don't have to worry about how compiler is built, how we can make a compiler, nothing of that sort. Compiler is something it's already there attached with programming language. You don't have to, you just have to know the term. That's it. This slide is just for you to understand the terms. That's it. Okay, so that's compiler. What is execution? Okay, execution is basically means submitting it. You can just understand again the chef example. Once you're done preparing your dish, you serve it on the table. In the same way, once a programmer is done writing the code, he or she executes it. That's it. No need to go via all these ones. I mean, the example is enough to understand. The last one is important, syntax. Now, relate syntax with the grammar in English language, right? Now, suppose I am saying something right now in English and I start using incorrect grammar, right? I start using incorrect grammar till the extent that you're not able to understand what I'm saying, right? So hence, I need to use proper grammar for you to understand and you to comprehend my words. In the same way, computer, when you're writing code, you need to stick to the grammar as accurate as possible. I mean, there is no, even if I do some grammatical mistakes, you'll be able to understand because you are a human, right? But that's not the case when you write code, because in that case, you're talking to a computer. Computer does not takes error for granted. I mean, if you have made an error, it will throw the error. That is something I do not understand. It can't just assume itself that this might be true or this could have been what the human was saying, right? So it's very specific on exactly what grammar you are writing on the code. So when I say grammar is between human and human interaction, same way syntax is something when you are interacting with the computer, right? So grammar is for English, syntax is for Java, or syntax is for Python. Syntax is for programming languages. Grammar is for human languages. Syntax is for programming languages, right? I hope these 5 terminologies are clear to everyone. All right, so we'll move on to the next segment now, which is again slightly around programming, and hold on for a while. This is light of the theoretical topic, but we'll get to the good part pretty soon. Okay, but just have the base strong so that you don't have to worry much on the later part. Okay. Okay, so this is the line I found very much very apt. If I talk in terms of Gen Z language, this 5 lines was very apt there for a programming language. Hence, I dropped it in the first slide of this particular PPT. So computer programming has a reputation of being cryptic and too complex for an average person. Okay, and that is something you all will feel if you are jumping into programming for the first time. Okay, that it's cryptic. What is cryptic? Cryptic is something which you don't understand, which is something that looks like encrypted, right? So it has a reputation of being cryptic and too complex for an average person to understand. However, once you get familiar with the basics programming logic, right? When you are familiar with with the elements of programming, when you're familiar with the different verticals of programming, you will see pattern everywhere. Okay, that cryptic piece of code that you might feel right now, once you are done with the basics part, once couple of weeks after, you'll see patterns everywhere. You'll start understanding, okay, this part, I don't need to understand the whole part. It's just like this part is doing this and this part is doing this, and then I'm able to get understanding of what whole code is doing. So it becomes so habituated, and you become so expertise in that you start seeing patterns everywhere. Why learn to code? I think I don't need to cover this slide, because since you guys have enrolled to the course, I think you might have seen some amazing things code can do. So that's the reason you are here. So I'll skip this slide. And what is computer programming? I think we covered that part. It's more like a recipe for a computer to understand. Computer programs can help cure diseases, drive cars, create video games, make animated video graphics, you name it. Now, especially after coming, the ChatGPT is out, you can pretty much do everything out of it. I mean, there is no limit of you doing wonders with computer programming. Okay. One activity I want to do with you all. Okay, and it's going to be an interesting activity, and we'll touch upon a very essential part of programming. Okay, I want you to describe in natural language how to make a peanut butter jelly sandwich in natural language. Okay, or let's say this example was from Harvard. Okay, so I copied it, and it's a Western dish, right? Peanut butter jelly sandwich, it's a Western dish. We Indians, I have not eaten this peanut butter jelly sandwich. Okay, so I think as an Indian we can stick to tea. Okay, let's change. Describe in natural language how to make tea. Okay, step one. That's the step one. Boil water. Okay, so step two has been, which is put tea leaves into it. What would be step three? Add milk and sugar. Okay, fourth step. Pour. Okay, chalo. Let's keep pour. I mean serve, right? So pour. Okay. Now let me just copy and do things which you guys have written. So first was boil water, which was given by Mursidil, and second was, I think, put tea leaves into it. Put tea leaves. I'm just putting it in the order so that you can understand. Put tea leaves into it. And third was, I think, add milk and sugar. And fourth one was pour. Now, if you give this to a person, to a human, you might end up having tea. You might see that person has prepared tea successfully. Okay. But if you give this instruction to a computer, okay, I mean, just hypothetically, I'm saying, I'm not just asking you to code how to boil water or something, not like that. Hypothetically, I'm just trying to relate what is the difference that you can sense when you give instructions to a human, and what is the difference when you give instructions to a computer. Okay, when you will give the step number one instruction of boiling water to a computer, first of all, the computer will ask, boil water where, right? How? And how can I boil water directly? I mean, computer would expect you to write things like, get a utensil, put water into that utensil, put that utensil on a stove, light up that stove, let that stove run for 5 minutes, 10 minutes, till the time the water is boiled. Just for step one, boil water, it might be very easy to understand. A human can understand that, okay, boil water, obviously, I'll use a utensil to put water and then put it on the stove. How else can I do it, right? That's human. But as a computer, if you are trying to give the same kind of instruction, you'll have to give instruction where there is no sense of ambiguity, when it is absolutely clear that there is no factor of getting distracted or redirected. Get a utensil, put some water into it, put it into the stove. I mean, that should be the steps if you're putting it to a computer, because computers cannot interpret your 2 words of boiling water. Similarly, put tea leaves into it. How many tea leaves, right? That's the question that you would have to put when you are putting into a computer, right? Humans can understand that obviously tea should not, I should not put the whole bunch of tea leaves, right? But computer can't sense that. Add milk and sugar. Where? Right? Add milk, sugar into it, into the boiling water where you have put the tea leaves. How much? That's also you should be adding. 4, pour. Now human can understand that the tea has to be poured in a cup, right? Computers cannot. You have to exactly right, pour the boiled tea into the cup, right? And especially use that, what do you call that in English? I say it channi. I don't know what do we call it in English. So you use that particular thing while you are pouring, else you'll use the tea leaves into the cup, right? So these are the instructions you'll have to give it to the computer step by step in much detail as possible, which is way different than we give to humans, right? So did you get a sense of the exercise? I mean, what my intent was saying is, when you write program, there shouldn't be any sense of ambiguity anywhere. Okay, this was also the first class in the Harvard, and that's where I got this idea to have this exercise, and hence I shared with you all. Okay, did it make sense, guys? Did this exercise made sense to you? What exactly was I was trying to convey? 4 verticals that basically builds the basics of programming, irrespective of any programming language. Okay, once you have an expertise on these 4 verticals, you can be a good programmer. Also, you can excel when it comes to data structures and algorithms, right? So these are the 4 areas that we'll touch upon right now.
Just a quick info, guys. Intellipaat offers full stack web developer course in collaboration with ICT Academy, IIT Guwahati. Through this course, you can learn everything from front-end web development to back-end web development from esteemed IIT Guwahati faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of web development.
Okay, so very first thing is, unlike Python is a language where you can just install Anaconda, open Jupyter Notebook and start coding and start executing stuff. That is slightly different in case of Java. In case of Java, what you see over here is a rough syntax of how you can start a program, writing a program in Java. Each of the program in Java starts with public class main method. Okay, so basically every single code in Java constitutes of a class and a method. Class you can assume as a group of methods stored in a particular box. Okay, so class will store one or multiple methods that can be used to execute any statement. Okay, that is going to be the crux, and that is how Java are built. Okay, so that's how you see public class main followed by public static void main. So over here, public means it is publicly accessible. We'll touch upon more on that once we talk about OOP concepts, object oriented programming. But for now, you can just assume public as something which is not, it's up to the user to, it's publicly available. It's not abstract. It's not hidden. Class defines that it's a class, and main is a class name. Second is public static void, which basically means that it's again a public method. Static means static is something we'll cover in detail in OOPS concept, so you can just ignore that part. Void means the function doesn't return anything. Okay, so in Python, the functions usually return stuff, right? In function, it can either print stuff or it can return stuff, but you do not specify anything that what is the data type of what is being returned. But in Java, once you return something, depending upon what the function is returning, you have to change this particular part. If integer is getting returned, you have to mention over here as int. If something else is being returned, you have to mention here as that data type. And if nothing is being returned, that's where you see void over here. Okay, so what I was saying is, unlike Python, where you just start coding things from scratch, writing and initializing variable, making arithmetic operations, that is something not feasible in Java. In Java, what we do is we start with the main method, which is a class. right? That's a class you have to define, followed by a method. Okay. Don't go into specifics of what each of the words says. Just on a high level, understand that this is a class, and this main what we have written, main with a capital M, is a class name, and then the static void is the method, and the main in terms of small letters are the name of the method. String args is something we'll cover in detail once we go to oops. But the main crux and whatever code that you write has to be written within this. So this is going to be the ideal structure for you if when you write any code in Java. And over here, you will be writing all the code that will get executed and will be printed over here. Okay, so this is going to be the ideal structure of Java. Now, methods can be multiple. Okay, definitely the name of the methods cannot be same, so this has to be changed. But method could be n number of methods within a class. Okay, so this can go into n number, and each of the code could be doing different stuffs. That could be the ideal structure of Java. All right, but this is going to be the way we'll be using it. And for now, we are not going to multiple methods. We'll be using only single method for all our operations and understanding the syntax. Okay, cool. So moving on to the Java syntax part. The very first thing and the most basic thing to know is how to print. Okay, printing any stuff on Java. Now, to print stuff, how you usually print in Python, you just write print statement, you open the parenthesis, and within that, you either put a string or you put an integer and it gets printed. But that is not the case with Java. With Java, there is a system library that you have to call out. Inside that, there is an out sub-library that you need to call. And within that, you have to call println. Okay, once you call this out, after that, it's more like Python. Whatever you put inside the parenthesis will be get printed. So if I run this, it prints whatever you have mentioned inside the println method, which is hello world. Now, what if I remove println? Let's say I only use print. Let's say, what does it return? It still prints, right? So what is the difference between print and println? Now, difference I can show you once I write one more statement for print statement. Okay. On, let's say, over here, I write something first class. Now I try to print. There are two print statements. I'm trying to print both of them. Now, when I print it, what you would see is it appends. Correct? It appends one after the other. And then that's the reason println is used to make sure that the second statement, or println basically says after printing whatever is present in the parenthesis, go to the next line. And once it prints hello world, it goes to the next line and then it prints the first class. So that's where you'll be able to have two things in different classes. That is about print statement. Okay. Coming to the part where printing text and printing numbers. Now, very similar to Python, we have the same way of printing stuff. If you're trying to print a string, you can print with quotes. But if you are trying to print just the integers, you don't need to put them into quote. Also, if you're trying to print a character or a multiple characters, you can also use single quote. So now if I print it, I'll still be able to see 23. Okay, so this has to be functional character. Let us see. So if you're trying to print a single integer, it will still work because 23 can be printed without quotes. Right? So that is about the print statement. Coming to the comments. Now, comments after print, what we can utilize in Java is comment. Now, let's say you have written a large amount of code, which you have, which you have not, which you want to make sure that you can recall it once you use it later on. So what you can do is you can make use of comments. What you can do is below a line prints 23. Okay, and below line prints nothing. So what you can do is, instead of making sure that a person who is not able to understand Java or your code sees your code, they should be able to understand what you are using. Okay, so that's the relevance and that's the importance of printing. Coming to Java variables. Now, I hope variables, the importance of variables, why variables are used is something clear to you, right? So I'll just take, two minutes to introduce you how to initiate variables in Java. Now, what you can do is, for initiating variables in Java, unlike Python, you'll have to use a data type. That what data type you are trying to initiate a variable on. I can't just write a equals to 4. I'll have to make sure that a is an integer, right? And also it should follow with semicolon. Without semicolon, you'll get an error. Okay, and then using string, if you're trying to raise a string, you can use string str equals to random string. Okay, that's how you will be able to write stuff and create variables. Now with variables, you can do multiple operations as well. What you can do is, you can use variables and you can use the variable names to print it. Okay, so for example, I have created these many variables. Okay, now instead of printing directly the integer or anything, what I can do is I can print the variable itself. Let's say I am trying to print 5. What I can do is I can directly use my num and get it printed. Okay, and if I run it, it returns 5. Okay, random string has to be left with semicolon. And once we do that, you would see getting printed as 5. String should be a capital letter. Okay. Why we have the first line as public class main? Because that is the way of implementing code in Java. In Java, whatever you write is a part of a class followed by part of a method. Okay, and all the code that goes inside the method gets executed. So that is how object oriented programming is followed in Java. Hence, everything comes under the class and second comes under the method part. Yes, first and second line remains the same, right? First and second line mostly, for the most cases, remains the same. In this case, both main is the class name as well and main is the method name as well. So don't get confused in that. Main with capital M is a class name. Main with a small m is the method name. Static void is something we'll cover once we talk to about OOPS concept, object oriented programming. Once we go over there, we'll be talking about this part. All right. So coming to the methods, which is important, which is around Java operators. Now, this is exactly as same as the Python operators as well, which is the operations that you can perform using different variables. Okay. All right. So let's do one thing. Let's cover Java operators and then we'll take 15 minutes of practical implementation part. Okay. So arithmetic operation is as same as what you do in Python. Okay. Let's say you're trying to add sum of two numbers. Let's say I already have integer a and my num. Okay, guys. So I hope till this point things are clear in terms of print statement and data types, right? We have close to 5 data types, which is integer, float, character, and boolean. Okay. Okay. For the folks who are not clear, I'll repeat that and I'll go very, very slow. This does nothing apart from printing any values or any variables. You can directly put integer, okay? Or if you want to print a string, you can use double quotes and try to print that particular string as well. Okay, now if I run it, it will print string as the first line. Okay, and 5 is getting printed from the below one, so you can ignore that. But yes, string can be printed. But if you are trying to print a character, what you can do is you can just put a single quote and print a single character using single quote. Okay, that's what you do. Character and string are not same. String is a group of characters. Character is a single character. D is a character, but if I put a double D, it would not be a character. Okay, you need to use double quotes if you're trying to print a string. It will give you error if you quote. I mean, that's not the normal nomenclature to use it, but if you still try to use it, it will show you some compilers gives you the error and some compilers does not. But this compiler, as you see, will give you an error. This is one thing. And second thing is, you can print statements either by using print directly or print ln. If you're using print ln, after printing, that line will go to the next line. And if you're doing only print, that line will stay in the same line. To elaborate on that part, let's say I did system.print.ln and I passed D, and then next line I'm using and I'm printing D again. Now what will happen? 2 times D will be printed, but still since I'm using ln, it will go to the next line. That's why you see 2 Ds getting printed in the 2 different lines. But let's say I remove print ln from the first, and then I try to print it again. Now what will happen? The next line, it would not go to next line after printing. Hence, you would find 2 Ds getting printed in the same line. Okay, that's the way you can use print statements. Usually in the industries, you do not print values directly. What you do is you use num you use variables to send them inside the print method, and then you print it. Okay, so this was about print statement. Coming to variables and declaring variables. So in Java, you have 5 different types of variables that are mostly used. First type is integer. Okay, integer is anything that from -infinity to +infinity and are real numbers. I mean the integers. Okay, float is something you need to define in this way. Okay, 5.99 whatever is followed by f represents that it's a float. That's how you define float in Java. Character is a single character, either capital or either small. Character can also be used via hyphen, slash, different symbols can also be used as a character. Okay. And then the fourth criteria is we have Boolean. Boolean takes 2 values only, either true or false. Okay. And then we have string. String has to be dealt with double quotations, and inside that you can have n number of strings. So moving on, this is the way you can declare variables. Okay. And coming back and incorporating what we discussed for declaring variables and printing stuff, you can print variables using, you can print values using the variables assigned to them. So for example, I want to print 5, but I can directly put 5 over here. Okay, but that is something that is something not the nomenclature, and that's not the way. What you can do is, what you can copy, and you can use the variable name directly over there. So these all part, I hope, is clear to everyone. All right. Now we'll move to a part where we will be discussing about operators. Now let's come to operators. Operators are nothing but it can help you to perform arithmetic operations, logical operations, or comparison operators. Okay, the very first thing is arithmetic operation, which talks about different operations like addition, subtraction, multiplication, division, modulus, increment, and decrement. Okay. Arithmetic operations, addition, everybody knows. Example, x plus y, that is the most basic arithmetic operation. Second is subtraction. 2 numbers you can subtract, and that's another arithmetic operation. Third is multiplication. fourth is division, fifth is modulus. Now modulus is something, if I put A modulus B, it will return me something like what will be the remainder when 5 is divided by 2. Okay, that is called the modulus. It returns the division remainder. So if you put 5 modulus 2, it basically means return the remainder you got after dividing 5 by 2. Okay, that is modulus. Okay, second is increment. Increment is as same as, let's say I am trying to do x plus plus. X is a variable. Let's say I have defined int x equals to 2. Okay, and I'm doing x plus plus. This statement is as same as doing x equals to x plus 1. So basically, increment increments the same value by 1. Similarly, if I do x minus minus, it basically means what I'm doing is x equals to x minus 1. Okay, so I hope all these arithmetic operations is clear to everyone. Okay, next coming to assignment operator. This assignment operator we have already been using. And what is this is, I mean, you don't have to go through all the complex part. You can just understand this operator for now, and rest of the things will come to you over time as well. Okay, assignment operator basically means just the way we are doing it, just the way we are assigning value to a variable. We are using a assignment operator, right? That is all about an assignment operator. You assign values, and it is not just true for variables getting assigned a value. It can be also dealt in a way where you initiated a second integer called b and assign the value of a into it. So assignment can happen between two variables as well. So what I'm saying is, if you initiate an integer xyz anything and assign it to a value, and you want to increment that value by 1, obviously this is one approach, you can take it. Or if you want to decrement the value of that integer by 1, this is the second approach, you can take it. But by using x plus plus and x minus minus, you can achieve the results in a shorter time. Shorter time as in it's a quick way, a shortcut kind of a stuff, which means the same, but it can be implemented in this way as well. That's all it is. So we have covered the assignment operator as well. Let's try to have a practical implementation of just try to have a practical implementation of whatever we have learned so far. Okay, I want each one of you to open a coding IDE, and there will be a bunch of questions I'll be writing over here, which you need to solve in next 15 to 20 minutes. Okay, the first question is, print a statement with your name in the first line and with your first name in the first line and second name in second line. Print a statement with your first name in the first line and second name in the second line. Okay, that is one. Second question is going to be, print your name in the print your first name in the first line and second name in the same line separated by space. Okay, that's the second question. Third question would be you need to create two variables, one as integer and other as string, any values of any value, and print them both in separate lines. Okay. And the fourth question could be create two integers and print the sum of two integers using, okay, create two integers and print the sum of two integers using print method, and print the sum of two integers using print method. And then last one is create two integers and print the incremented value using plus plus using print method. Okay. And the last question could be find the modulus of 5 and 2 and print the same. You don't have to concatenate Web. Without concatenation, try to do it. Okay, cool. So we'll start discussing the problems now, one by one. So first question was print. Let's copy this whole thing over there first, and then we'll discuss that one by one. Okay, so let's copy it over here. And the first question is print a statement with your first name in the first line and second name in the second line. Okay. One thing is for sure that you don't have to worry about the two lines. You have to deal with only this bunch of lines of code. Okay. So it's very simple. I have already discussed about print statements, right? So system.print, and you have to do in the second line. So print a statement with your first name in the first line and second name in the second line. Okay, that's the reason you have to use print ln. And what you can do is, let's suppose your name, let's say first name is MS, okay, and second name, let's say, is Dhoni. So let's use print ln and put Dhoni over here. Okay, what will it do? It will print the first name MS and it will go to the next line and print Dhoni. Okay, it's as simple as that. Let's try to execute this code. And we see over here, first name and second name getting printed in two different lines. Second question is print a statement with your first name in the first line and second name in the same line separated by space. Now you don't have to change the line. So what I can do is I can remove the ln statements from here. Now if I print it, both the ones will be printed in the same line, but I want it to separate by space. What I can do is I can add a space after the first name, or I can add a space before the second name. Anything will work. Now if I run it, it will be printed in the same line separated by space, just like this. Okay. Third question is create two variables, one as integer, other as string of any value, and print them both in separate lines. Okay. So what it is saying, create two variables, one as integer. So integer, let's say a equals to 5. What did we do over here? We created an integer called a and we assigned a value of 5 to it. Okay. And then other string of any value. So we create a string, let's say string b, and we assign the value of, let's say, anything, let's say session 1. Okay. And then print them both in separate lines. What we can do is print ln and then do print ln. And in the first line, we pass a. And in the second line, we pass b. So what did we do over here? We created two integers. We took two variables, integer and string, assigned a random value, and printed them both in separate lines using print ln. Now, if I print it, I'll get 5 and session 1. Okay. Next is create two integers, print sum of two integers using print method. Right. So create two integers. Now let's remove string b, and instead of that, let's say I created integer b and assigned a value of, let's say, 4, and remove the print statement as well. Question was create two variables, one as integer and other as string of any value. Okay, two variables, one as integer and other as string of any value, and print them both in separate lines. What did we do? One as integer, we created first variable as integer, other as string of any value. So we created string and assigned any value to it. and then print them both in separate lines. And we tried to print A and B using separate lines. We used ln, print ln. Okay. Okay. Next question is create two different variables. So let's say we created A and B, both integers, and print the sum of two integers using print method. One way is to you create a third variable called int C, and then you use A plus B, just like the arithmetic operations which I mentioned. You use A plus B, and then while printing, you just print C. Okay. Now, if you execute it, okay, semicolon is missing. Now, if you execute it, you will receive the sum of 5 and 4, which is 9, right? Other way is you can remove this part and do directly inside print statement itself. You can do A plus B inside the print statement itself. So both of A and B being integers, they will print the summation of A plus B, which is going to be 9. Okay, I hope it makes sense. Second is create two integers. And okay, this is done. Fifth question is create two integers and print the incremented value using print method. Okay. So either it could be two integers or one integer as well. Let's say two integer itself. Int b equals to, yes, by applying double slash, you can comment out the line. B equals to 4, and then using increment, I can print incremented values of both of them.
Let's have a quick quiz question, guys. And the question is, which data structure is used to implement depth first search algorithm? And your options are stack, queue, linked list, or tree. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers full stack web developer course in collaboration with ICT Academy IIT Guwahati. Through this course, you can learn everything from front-end web development to back-end web development from esteemed IIT Guwahati faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of web development.
Right? Like this. A equals to 5, B equals to 4. And using plus plus sign, I can print incremented value of both A and B. Okay. And if I execute it, it will print 6 and 5. It got incremented by 1. Okay. That's the cool thing to explain. Okay. Now, can someone tell me why did it not increment? I mean, this part I have not covered. Now, how does increment works is it works two ways. Either it works in the way where plus plus A, there are two types of increments, plus plus A and A plus plus. Okay. And if you use it in the print A plus plus, what will it do? It will print A first and then increment it. Okay. And in this plus plus A, what it will do, it will increment the A and then print A. Okay. So this is called pre-increment. Before performing any action on A, the increment will happen. And below one is post increment. After performing action on A, then the increment will happen. Okay. So with these two logics, to achieve our desired result, we need to do plus plus A and plus plus B. Okay. Now if I execute it, it will give me the result of 6 and 5 after incrementation. All right. Last question was find modulus of 5 and 2 and print the same. Modulus of 5 and 2. Let's say I assign A to 5 and B to 2. And then let's find the modulus. Modulus would be A mod 2. Sorry, A mod B. I should get the answer of 1. Okay, can someone tell me why? Because remainder is 1. Modulus is nothing but it gives you the remainder value of what you have done. According to the remainder, it will give you the value. A plus plus, that's what I'm saying. If I print A plus plus, increment will happen after the output has already came, right? If you want to print the incremented output, you have to do plus plus a, not a plus plus. Okay, coming back, let's remove these. We will have second set of questions again very soon, so don't worry about that. Okay, so let's go ahead. Operators is something we have covered. Next thing what we want to cover is comparison operator. What is comparison operator? The comparison operator is you can compare two different variables. Let's say I have, let me remove all this. Let me just close it out and do it this way. Let's say I have x equals to 5 and y equals to 3. And system is trying to print x greater than y. And this will return true if, because 5 is greater than 3. If I return this, it will return me true. Okay. Why? Because 5 is greater than 3. If I do the opposite way, x less than y, it will return me false because x is not actually less than 5, less than 3. Okay. The third kind of operator is double equal to. In these operators, you can actually compare two different variables. Okay. And the comparison operator, unlike any other operator, will always return you Boolean value. Okay, it will always return you either true or false. Now, these are the 6 different operators that comes into picture. First is double equal to. This equates the variable x with variable y. Second operator is not equal to. Okay, x not equal to y. So basically, instead of double equal to, if I put x not equal to y, what do you think will be the return type of this particular statement? If I execute it, will this statement return true or will this statement return false? Absolutely, it will return true because x is genuinely not equal to y. Okay, so that's what you see over here as true. Second is greater than, which is as per the logic, greater than are the ones. Then next is less than. After that, it is greater than equal to, and after that, it is less than equal to. Okay, so these are comparison operators. Next comes is logical operators. So you can apply comparison operators with multiple comparison operators. So logical operators can be applied it in this way. For example, let's say, let me just take it whole over here itself. Okay, let's say x equals to 5 or x is already equal to 5. Now we are trying to do is x greater than 3 and x less than 10. What do you think the value of this expression will be? True? Absolutely. What if I do this? Okay. What will be the value now? False. And now what if I do this? You have three more different operators with which you can join the comparison operators. And these are logical operators. Okay. How you can join is, the first is and. So this is very similar to the set operations that you might have studied in your class 12th, right? And operation. And operation means if both left hand side and right hand side are true. If both of these sides are true, you will return it will return true if the middle connection is through and. Okay, or if either one of them are true and one is false, if one is true and one is false, this will return false. Only if both are true, and operation will return true. If any one of them are false, that will return as false. But if I put the or operator basically says even if one of them are true, it will return true. And if one of them is false, it will still return true unless and until both of them are false. It will only return false in that case. So basically, and operation will return true only when both are true, or operation will return true even if one is true. Okay, that is the case. And then there is a logical not. Not basically means if I applied something it like this is basically a negation. It converts the underlying expression to its counterpart. If this expression is already true and I have applied a negation, it will return me false. And then if this statement is true, if this statement is false and I applied negation, it will return me true. So opposite, basically it makes the value opposite. All right, so let's quickly have a quick assignment. What I want you to do is, it's going to be not like a usual problem. It's a very interesting problem. Create two variables and do the below operations. The below operation would be, first would be compare first with 2 and return a Boolean value. Okay. Second would be check if they are equal to each other. Okay. Third would be check if number 1 is greater than 10 and number 2 is less than 5 and return the result. Okay. Fourth is check if negation, या फिर return the negation of this expression num1 less than 10. Okay. And fifth is return the value of negation of num1 greater than 3 and okay, or num2 greater than 10. Whatever we have studied, please try to implement this. Okay, so we'll start discussing the solutions. And the first question was compare first and second. I mean, you need to take two integers and randomly assign them values. So let's say two integers that have been taken with num1 equals to 2 and num2 equals to 10. Okay. The first question is compare first and with second and return the Boolean value. So basically all you have to do is compare it with num1 greater than num2. I mean, it's okay if you're doing less than or greater than as well. The point is you should be able to compare num1 and num2 and print the result. Okay, that is number one. Second thing, check if they are equal to each other. So you're doing println num1 double equals to num2. If you're doing this, that's also fine. Or if you're doing not equal to, that's also fine. Okay, depending upon that, answer will change, but basically you are comparing if they are equal to each other or not. All right. Let me know any confusion anyone has so far. Third question was check if num1 is greater than 10 and num2 is less than 5 and print the result. Num1 greater than 10 and num2 less than 5. So we have and in between, right? That's what the question says, that you have to be put check if num1 is greater than 10 and num2 less than 5. That's how you see and over here. Second was fourth one was print the negation of this expression num1 less than 10. So you use num1 and then you use the negation to print the negation of that statement. Okay. And the last one was print the value of negation of num1 greater than 3 or num2 less than greater than 10. So num1 greater than 3 and num2 greater than 10 followed by a or condition and a negation. Okay. Now, if I execute this statement, what will I get? I get all the answers. Okay, I need to remove that. Okay. These answers might change for you depending upon what is the expression you have used. Okay. But overall, you should be able to get 5 Boolean values and this one. Fourth, num1 should be 10, right? 1 second. Num1 less than 10. Okay, yes, yes. Great, great. Thank you so much, Travis, for pointing that out. This should be less than 10. Because the question says print the negation of this expression, num1 less than 10, not greater than 10. Okay, one value will change, but yeah, that's the good catch, Shravesh. But it's not the point. You focus on the building the expressions. Okay. All right, guys. So let's move on. So what I was saying is let's do Java strings. So Java strings, we will cover string length, how to calculate string length, how to convert the string into uppercase character or to a lowercase character, and how to find the character in a string. These three things will cover as part of strings. The first one is most simple, is about checking the length of the string. Okay. How to check the length of the string? It is as simple as txt, whatever name you give to the variable. So string variable, you use txt as the variable name of that string, followed by .length, length. Okay. So this is the way you can very well use the expression to check the length of any string. Let's suppose, let me remove this part and let me add another string. String str equals to, let's say, Shubham. Okay. Now I want to check the length of the string which I have initiated as Shubham. Str.length. Now if I print it, it will give me an integer value that will be equal to the length of the string. Okay, I'm not sure why is it taking time to compile. What happened? 1 second, guys. I think there is a problem in IDE. Okay, you need to print it out. So basically this will give you the result, but you have to print this out. Okay, so it says 7 because the length is 7. So this is all about the length of the string. Coming to the second part, which is around converting the string to a lowercase or uppercase. That's a very interesting fact. You create a string, string text equals to hello world, and then you do system.print.out. I mean, that's for printing, but just by appending dot to uppercase or dot to lowercase, you can convert that particular string into lower cases or uppercase. Okay, it is as simple as that. Okay, so don't worry about other stuff. It just converts all the characters in that string to uppercase and all the characters in that string to lowercase. Okay, so it is as simple as that. Now this is the most interesting fact. I'll execute this first and then I'll explain you. Okay, now when it says system.print.out text.index of locate. Okay, what does it say? Index of is a function that looks for a particular character in a string. Okay, or a particular sequence of character in the string. It basically returns that at what position a particular string is present in that particular string. That is what it says when it says index of. That in a particular position, what is the position of that? Let's say I'm trying to search for locate. What it will do is it will start iterating from the first place. And just like any other programming language, iteration starts from 0. Python starts from 1. Python programming language for iteration starts from 1, but for Java, it starts from 0. So basically, if I start from 0, it will be 0, 1, 2, 3, 4, 5, 6, 7. So at 7th index, it located the start character of locate. Okay, it's a sequential search. Yes, it starts from the start and it looks for the character where it can search for this particular character, and hence it returned 7. Right? Any confusion anyone has? It's very simple one, but any confusion anyone? Because this is very important thing to understand. Okay, cool. So we'll do exactly. There are 2 locate in statement. Yes, so it will return the first one. It will return the first time it reaches that. So Ignore the print statement. Just focus on this part. What it is trying to do is text is a string. Till that, I hope it is clear. Okay. Text is a string and we have initiated that string, given it a value as this one. Please locate where locate occurs. And then on that text, we are using this particular function, dot index of. This function is trying to look for this particular piece of characters, which is locate. How does it do? Once you execute it, it returns you an integer value, which is basically the index. Okay. And hence it starts from this place. Starts from the beginning. Every single character, Vaibhav, yes, every single character will be counted, guys. Even the space will be counted. Every single character gets counted. Okay. So while calculating index, space, right, whatever is inside this double quotes, every single thing will be counted. Okay. So basically, P is 0, then L becomes 1, E becomes 2, 3, 4, 5, 6, and 7th. So 7th place is the place where locate starts. And hence you see 7 getting returned. It looks for a particular start, looks for the starting index of whatever you have kept over here. If I remove locate from here, and now I execute it, answer will be different. Answer is 14. Let's calculate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It reached to the start index, right? After counting the single quotes as well. So that's how it works. It became 7 because we removed the previous locate, right? So these many characters constitutes of 7. So it's 7th index, it starts. Where starts from 7th index. Java starts from 0. The index of Java starts from 0. Okay. Now question time. Calculate. First question is calculate and print length of your full name. Okay. Second question is print your first name in lower characters and last name in upper characters. Okay. Don't directly take the input as lower characters and upper characters. Take the input as a camel case, like first letter capital and then all small. And then using the function which I told you, use lower characters and for the last name and upper character for the last name. Okay. Print in separate lines. Your first name in lowercase and last name in uppercase. Okay. And the third one is check if what can I tell you that check if A is present in your name. Okay. Print the index at which it is present. Okay. Now I'll just give you one more thing. If you put something like, let's say I am putting my name over here and try to look for the index which is not even present in the text, right? So what will it return? Let's see that. What will it return? It will return -1. So basically, if it is returning -1, that means it's not present. Okay. So for the last question, if letter A is not present in your name, it's perfectly fine. -1 will be returned. Okay. But I think most of you A will be present. But yeah, even if it is not present, that's okay. You can print -1. And if it is present, you should be able to print the first occurrence of that letter. Okay. First one was calculate and print length of your full name. Okay. So for the first question, which is calculate and print length of your first name, what you can do is you can use your full name dot length. That's it. This will return you the length of your full name. Okay, that is one. Second is system.print.println. This will, in this case, it's the second question. Print in separate lines your first name in lowercase character and last name in uppercase. Okay, so in these two, what you can do is you are getting lowercase for the first name. For the first name, you're taking lowercase. And for the last name, you're making it uppercase, and then you're printing it the both. Okay. If condition, I'm removing it for now because people might get confused. And the last one is what you can do is check if A is present in your name, print the index at which it is present. So you can again use full name and do dot index of A. This will print an integer. Okay, that's it. These are the three questions. First question is just printing the length. Second question is figuring out the lowercase and the uppercase of first name and last name. And third question is about finding the index of character A. All right. I hope it makes sense to everyone and I execute it. I will get 2 integers and 2 strings, which is like this.
Just a quick info, guys. Intellipaat offers full stack web developer course in collaboration with E&ICT Academy, IIT Guwahati. Through this course, you can learn everything from front-end web development to back-end web development from esteemed IIT Guwahati faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of web development.
String concatenations. Now, string concatenation is nothing but joining two different strings. Okay. Imagine, let's open this. What we have over right now is two string, John Doe. Let's say it's the first name and the last name. And let's say we want to print both of John and Doe in the same line. Now, one thing we did yesterday was we used two print statements and we removed ln so that it prints in the same line, right? But what if you want to use only one print statement and print both John and Doe? For that, you'll have to concatenate string. You'll have to add the strings. And that's how you add a string. You do simple plus operator, works by adding the string. The middle part that you see is used to add a space between first string and the second string. Okay, that's all concatenation is. It just uses the addition operator to join first string with the second string. Okay. Now, the second way of concatenating it is this way. Let's say you have two strings and you want to concatenate. Instead of using directly the plus index and followed by a space in between, what you can do is you can use a concat function itself. Now, this concat function, what does it do? It joins, it acts as a method of a string. So first name over here is a method and dot concat is a method applied on that string, and the parameter passed in that method is another string. Once you do that, automatically both the strings are concatenated, and also there is a space introduced between both the strings. So you need not go through this particular path of adding a space explicitly. Okay, that is it was a very small topic about concatenation. So this is something you should keep in your mind. Okay. Next thing is you cannot add integers with strings. Okay. For example, let's take the same example where we were trying to add using plus operator. Okay. Let's say first name is John and it's both it's a string and this is also a string. Now let's say I create a new variable called integer a equals to 59, let's say. Okay. Now I try to add a string with an integer. Since a is an integer, I'm trying to add first name with an integer. Let's see what happens. Okay, system.out.println first name plus a. Let's see what happens. Okay, so it added both of them, even though we have an integer over here. Typecasting, it typecasted into string. Okay. Okay, so here is the logic. String is something that precedes in terms of priority. Let's say if I try to add a float and an integer, answer might come as an integer because integer precedes in the priority. In the same way, string precedes in the priority. So if you're trying to have a plus operator in terms of adding a string to an integer will automatically be converted into a string and it will be concatenated, right? But now this string, that 59 string that you see as part of the result, will no longer be an integer. It will be a string itself. Okay, it's a part of a string, and it is now if I break it and get the last two last two segments of this particular string, it will come as a string. Okay, so that is the way you can handle string additions as well as adding string with an integer. Okay, so special character is something we can skip that for now. All right, and one very important concept we missed to discuss, which was taking user input. Now, so far, whatever problems we had done, so far, whatever we discussed was more about creating a variable and adding a demi variable on top of it. Okay. Now, if you want to take input from a user, right? Let's say you do not want to put a dummy data into a variable. You want to take an actual input from the user. How will you do it? For that, there is a very simple method to do it. Okay, for the sake of not getting confused, let me remove certain parts. Okay, it's already executing. Let me just do. Okay, why is it not working, guys? I can't edit it. Okay, no problem. Let me do one thing. Okay, somehow it's acting a little slow. Okay, so if you see over here, we did not use a random value of the variable by putting it into the code. What we did was we took an input from a user. Or let me just explain the code first of all. What are we trying to do over here is we are trying to print a username. Okay, last line basically prints a username, but we are not defining username in the code. What we are doing is we are first importing a package that can help us to accept input from a user. And that package is java.util.scanner. You need to remember this. Java.util.scanner is a package that can help you to import the scanner class. After scanner class is created, you need to create an object of the scanner class. Okay, now this object word might be confusing to you. Okay, because we have not covered the OOPS concepts. Okay, but for now, I would just like you to understand it for now, that this is the process. Once you import a package, you can't just directly use the package. You have to actually create a replica. You can just imagine object as a replica of what is already present in scanner. So scanner contains all the code that can help you to take input from the user. And by creating an object, you are creating a replica of that scanner package. How to do it? You can do scanner my object. This name could be anything. New scanner system.in. Once you do that, you can leverage my object obj to accept any kind of input. So string username is something we have defined a variable called string, which is username. Okay, and using that username, we are trying to get the input from a user. All right, or just understand in a way that this whole code is intended towards just making you understand the way you did the system.print.out, system.out.print. Why do print stuff, right? You did this to print stuff. Just opposite way you need to do to accept stuff from the user, right? Taking input is something you need to do just opposite. So that's where you need to import this class, and then using the creation of object, what you can do is you can accept the user input through my object.next line. Whatever we have covered, will be using dummy variables to create it. We'll use the input for the later segment. Okay, so let's continue with the current topic. Okay, so next topic we have is maths, the math library that we have in Java. Now, maths library has n number of functions, but I'll just cover what is usually required. Okay, and it's a very simple, you don't have to put much effort into that. So mostly there are 4 different math methods that are required. Okay. First one is, all right. So maths module has mostly 4 main methods. Okay. You would not be required to go beyond those 4 methods. First method is, let me remove this system dot out, or let's say, let me create integer a equals to, okay. So the first method is the max method. For calling the math function, you don't have to import any package because it is already included in all the classes of Java. So math, you call the library math and you invoke a method called .max and you pass 2 parameters into it, right? Between which you want to judge the maximum. And then you assign that max value to integer a and then you print that integer. Now, if I run it, the answer I will get will be 10, because between 5 and 10, we have max as 10. Now, what if I pass only one value? What will happen in that case? I do not pass 2 values. Okay, now is it fine? The code size, guys. Now, when I pass one value, it's saying not suitable method found for max because it needs at least 2 values. Now, let's say we pass 3 values. What will happen now? Any guesses? So again, it says no suitable method found for max because you cannot put more than 2 elements in the math function. It should be only and only 2 functions. And also it says math method had 4 types. Either you can say send 2 integers, 2 long data types, or 2 floats, or 2 double. But the number should be always 2. All right. So making sure that this is always 2, that has to be done. Now, other function that needs to be executed is min. Okay, that's the second function that you should make use of. Minimum is as same as maximum. It will, so let's say you have to compare max between 3 numbers, as I mentioned, right? 5, 10, and 12. What would you do? You will use a nested max. Does it make sense now? Hari? Yeah. Now, if I do it, the max function will be executed twice. One for the inside and one for the outside. Now you will get the answer as 12. Okay. So that's the limitation of max function. That's why it's not as famous as other methods that we have, but that's what it is. And for min, it's as same as 5, 10. And then you do it. And then you get method is, let's say for math and min, maths is a module. Math is a module. So module has already been built and it's there in the Java library, Java package. Using math inside modules, we have multiple methods. And that's what we are using min as a method. Okay. So max and min are 2 different topics. Next, we have square root. So it's as simple as whatever you do, .sqrt, it gives you a square root. So let's say I want to see a square root of 25. I should get an answer of 5. Okay. Now, if you try to send someone which is, what happened? SQRT 25. What did I do wrong? Did I miss the braces? What does it say? Okay, so it's a loosely conversion from double to int. So to fix that, let me take this part as well. And then let me directly print it because that was an integer data type, hence it was giving error. Okay, because usually square root returns you in a double and you need to typecast it to int. So you need to extra typecasting. Okay, so these are the main 3 functions of math. And then last one is absolute value, which basically gives you the absolute value instead of, giving you, if you pass a negative value. Absolute value is basically removing the negative element from it. So that's what it is. Usually we do not use math function, but in case you are required to use it, you should be aware of that. Hence, we covered that part. Now, coming to the heart of this session, which is going to be the crux of next 1 hour discussion, the loops part. Okay, loops part and the conditional statements. Cool. So if statement, this particular next 15 minutes, we'll talk about 4 different segments, which is if statement, else statement, else if statement, and switch statement. Okay. Now, before I talk about anything, regarding if statement, the only thing I want to tell you is using a real world example. Okay. Let's say you're stepping outside your house and I tell you, take umbrella. Okay. That's a simple statement. I'm asking you to take umbrella and then I expect you to execute it. I mean, I expect you to take action according to my statement. But what if I tell you, if it is raining outside, take umbrella, right? Now what will you do? You will not directly follow my decision, follow my words and take the umbrella. What you would do is, you would check if it is raining outside. If it is actually raining outside, it's a condition, then you will take umbrella, right? That's exactly how we make our code work for if statements, right? You see over here the syntax, it basically contains a if condition followed by a if word followed by a condition. Now this condition will should always return a boolean. If this condition is not returning a boolean, it doesn't make sense. I mean, you will get an error. So this condition should always made and written in a way that this returns a boolean value, and depending upon boolean is true or false, it will execute the second block of code. Okay. For example, very quick example, if 20 is greater than 18, print 20 is greater than 18, right? And now what if I say, this is the if statement. So every time you get a positive answer from this if statement, you execute the next statement. Now, what if I make this statement to be false? What if I make it equal to, if 20 is equal to 18, print the statement. Now what will happen? Nothing will get printed, right? Because we are only saying that if this statement is true, then only execute the statement. If it is raining outside, then take the umbrella. Okay. Now let me change again the statement while you are stepping out of the house. Let me change the statement a bit. What if I tell you, take if it is raining outside, take umbrella, else take my parcel with you, or anything. If it is raining outside, take umbrella, else take this parcel with you. Okay, so now you will not directly take the umbrella, or you would directly take the parcel which I am giving you. What you would try to understand, first the if statement clause, is it raining outside? If it is raining outside, you will take the umbrella. If it is not raining outside, you will take the parcel which I'm asking you to. Right? So what happened here? I gave you a second option if the first condition is not true. And exactly doing that, let's say I have created an integer called time, right? And the time is equal to 20. Else statement is not at all mandatory. It is only required if you want to execute a statement if the condition is false. Okay. So integer time equals to 20. I have initiated an integer called time and equated it to 20. And then I'm putting a condition over here that if time is less than 18, then print this statement, good day. Or else time, if it is not less than 18, if the statement is false, it will print good evening. Okay. So over here, what it should print? Definitely 20 is not less than 18. So it will print good evening. That's how you see over here. Okay. So that is about if else statement. Now let's come to another clause. Let's say same condition. I'm saying you, if it is raining outside, take umbrella. Else if it is sunny outside, take sunglasses. Else take my parcel. Now what I have done? I have applied two conditions. First condition is if it is raining outside, take umbrella. Else if it is sunny outside, take sunglasses. Or else if none of the above conditions are true, take my parcel with you. Right? So it's a nested conditions. It's a list of conditions. How will we do that? Again, going by the time example that we had, integer time equals to 22. We created a time, equated a value with 22. Now, what we are doing over here is Three conditions. First, if time is less than 10, print good morning. Will this be printed? No, because time is not less than 22, because time is 22, right? 22 is not less than 10. And the second is if else time is less than 18. Again, time is 22, so it's not less than 18. Hence, this statement will also not get printed. And finally, if none of these conditions are true, we'll print good evening again. So that's how if, and else works. Now coming to a switch statement. We talked about if else statements. Coming to switch statement. Now, switch statement, let me just go back to that example again, which I was talking about the raining part. Let's say when you are stepping out, I say, in case it is raining, take umbrella. In case it is sunny, take sunglasses. In case it is cold outside, take my jacket. In case it is a snowfall happening outside, take snow caps and snow gloves with you. In case it's windy outside, make sure you put on your helmet while you're driving, anything of that sort. Or in case it is stormy outside, don't go out. Now, what did I do over here? I put a lot of conditions while you were going out. I gave you n number of cases. If it is sunny outside, if it is raining outside, if it is winter outside, if the storm is there, if it is windy, right? Now, if you start writing if else statement, you might be able to achieve the goal, right? But it will be a lot of same repetition of if words, if else case and all that stuff. Instead, why not I do something like create a condition that can give me the weather of outside, like condition weather. What is the weather outside? And depending upon that answer, I create the case. Now it will be more clear if I tell you with the help of an example. Now let's say there are 7 days in a week, right? 1, 2, 3, 4, 5, 6, 7. One starts from Monday, Tuesday, Thursday, Friday, and Friday, right? Let's say I am trying to print the day 4. What would be day 4? Day 4 would be Thursday, Monday, Tuesday, Wednesday, Thursday. Day 4 is Thursday, right? I'm trying to print Thursday, but I know I know day is equals to 4, and I'm trying to print which day 4 is. Now, one way is to have multiple if statements, that if day equals to 1, print Monday. Else if day equals to 2, print Tuesday. Else if day equals to 3, print Wednesday. It can go on and on. Or the other case could be using a switch statement. What will switch statement do? Switch statement takes a parameter. And in this case, it's not a Boolean expression. The switch statement doesn't take care of Boolean expression. It takes care of a value. Parameter of switch statement is always a value. And that value is equated with cases. So you create case, and automatically switch statement will equate the value of the parameter with the case. So these are not case numbers. Don't get confused with these as case numbers. These are values. Okay, these are values. And with this value, day will be compared. So day 4, value of day is 4, and this will be compared, and Thursday will be printed. Now, if you see, there are break statements in between. Okay, that's very common in case of loops. And switch statement is the best way to talk about breaks. Break is basically saying that once you come over here and execute this particular statement, once you see the break, come out of the loop. No need to recheck or do anything. Come out of this loop and go over here. It's as simple as that. So whenever you see break, make sure you can understand that code will automatically go to the next line after the next parenthesis it has. So once it sees break over here, it sees the parenthesis over here, and it goes here. That's how you can understand breaks. Okay, so next example, if I give you, so that it makes you clear that it's not a case and also a default value. Let's use the same example, suppose. Okay, let me change day to 72. Right, there is no day called 72. Let's see what does it do. For that, if I execute it now, nothing will get printed because none of the cases are matching with the day value. So in those cases, what we use is we use a statement called default. Okay, let me copy over here only. Default will say looking forward to next weekend, or anything it can say. Basically, it says that it has not received any value that is matching with the cases. So in that case, it will just return looking forward to the weekend. If I put here as ABC, it will, and you can also put here as ABC, right? So it's basically equating not just the case numbers, it's basically equating the value of the day with the case identity. So let's do this, and let's do it via an example. Okay, generally, if you do not have a break statement, let's say the case is 4, and then I try to execute it. Okay, let's see what happens. Okay, that's again a good question. Duplicate case. I think I used case 4 again. Okay, it's case 4 over here. You see what happened? It print Thursday, right? Because it reached till this point, but then we didn't had any break statement after it. So it went to case 5 and it printed Friday, and then it broke, right? You got it? So basically, if I remove this break as well, even Saturday will be printed. Okay, that's the importance of case, and hence break statement is very important in case of switch statements. All right, so time for questions, guys. Let me just, I have already prepared questions. I'll copy that. I have marked them as easy, medium, hard as well. Let me do one thing first. So guys, first question is write a Java program to check whether a given number is even or odd using if-else statement. Second question is write a Java program to take user input. Over here, you can just ignore it. Don't take the user input of a character. Just use a variable to generate a character. Write a Java program that has a character variable and determine whether it is vowel or constant using if-else statements. Third one is write a Java program to take user input of 3 integers. Again, over here, you can just mention it as write a Java program that has 3 integer variables and take random variables and print the largest and smallest of them using if-else statements. And the fourth program is write a Java program to find the second largest number in an, okay, array is not taught. Let me remove this. And the last one is write a Java program that takes user input of a string and counts the number of vowel, consonants, and special character using if-else statement. Special character is something you can remove for now. And let's say you use only this. All right, guys. So now we'll discuss the solutions of each and every problem. So we'll start with the first problem. Okay. The first problem is write a program, Java program, to check whether a given number is even or odd using if-else statement. Okay, let's just try to understand here what is being done. So very first thing is you initiated a variable and you the variable name is A, and you initiated with any random integer. Over here it's 4. Okay, that's all. And then problem was check if that number is even or odd. Now the best way to do it, you remember we discussed one of the arithmetic operation, which is modulus. What does modulus do? Once we do a modulus of a number with other number, it basically returns the remainder, what you will receive once first number is divided by the second number. And what is the property of even number? The property is once it is divided by number 2, it would return you remainder 0. And same thing has been leveraged inside this particular statement. And if you remember, we discussed inside if condition, inside if statement, the condition should always return you a Boolean value. And this A modulus 2 double equals to will make sure it's a logical operator, and it will return a Boolean value depending upon the expression. So basically this expression is saying if A is divided by 2 and the remainder is 0, return true, else false. When the remainder is 0, that means the number is even. And when the remainder is not 0, it means the number is odd. So let's go to the second question. First question is clear to everyone? Everyone, first question is clear. What if the value given is 0? What is the value given is 0? Are you talking about this one? Value given is 0. Again, what will you receive when you divide 0 by 2? What remainder will you receive? If you divide 0 by 2, the remainder will be 0 again, right? So it will still give you even, and 0 is actually an even number as well. Okay. Now, what does the question say? Write a Java program that has character variable and determine whether it is a vowel or a consonant using if-else statement. Okay.
Let's have a quick quiz question, guys. And the question is, which sorting algorithm has the worst case time complexity of O(n) square? And your options are merge sort, quick sort, insertion sort, or heap sort. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers full stack web developer course in collaboration with E&ICT Academy IIT Guwahati. Through this course, you can learn everything from front-end web development to back-end web development from esteemed IIT Guwahati faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of web development.
Character Amit has initiated as character E. A is the variable name. Don't get confused, guys. A is not a character here. A is a variable name. And value of A is character E. Now it is as simple as you create a if statement and append all the vowels with a or condition. A, E, I, O, U. And then what do? You print. If any one of them is true, you print that it is a vowel. Else you print it as consonant. I hope no questions. Now, what if I tell you this solution is partially correct? This will only return you 50. This will only solve 50% of the test cases only. Shall I prove it? Shall I give you a solution case where this solution is supposed to give a correct answer, but it won't? What if I do this capital E, right? And then I execute it. It will say it's a consonant, but capital E is a vowel. How will you take care of this? But you need to use lowercase. Once you start comparing, irrespective of what character is, use A dot lowercase. A equals to A dot lowercase, 2 lowercase, sorry. I mean, whatever. Basically, you have to convert it into a lowercase and then check for it. Okay, so that will give you a correct solution. So make sure to do that, because usually in coding contest for the companies, they make sure that they do such kind of, differently test cases that can create a problem for you. Next question is, write a program in Java. Put the solution for the next question, guys. Third question, write a Java program that has 3 integer variables and print the largest sum and using if-else statement. Okay, so let me paste it here. Three integers, straightforward, x, y, z, 17, 12, 15. And then you create bunch of if statements and else if statement as well. What are you doing in the first if? X greater than or equal to y, and x is greater than or equal to z. Basically, you're comparing x to be greater than y or x greater than z. If that happens, x is greater. Right? Greater as in, greatest, as you can solve it as. Else if, same, y is greater than or equal to x, and y is greater than or equal to z. So basically, y is greater than both x and z, then y is greater, else z is greater. It's straightforward. No problem and no concerns in that. Okay, so let's see. First 3, quite clear. Question said, you need to initiate, let me repeat the question, write a Java program that has 2 numbers and an operator as variable, plus, minus, multiplication, division, and perform the corresponding operation using switch statement. The program should handle division by 0 and display an error message in such cases. So very clearly, you have initiated 2 variables. One is 9 and one is 55, x and y. And then you have initiated a character called OP and initiated it as plus. You have also initiated a result as 0, because in the end you need to return a result, right? You have to perform the corresponding operation and print the result. Correct? Let's see what is happening over here. Switch statement, passed OP. OP is operations. 4 operations, hence 4 cases. Operation is plus, so case will come over here. Result will become equal to x plus y and it will break. Right? And now, if y equals to 0, okay. All right. Let me first run this, then I'll explain this. Okay. So how it came over here, the plus part, because the OP was plus, and then result was assigned x plus y. What is x? X is 9, y is 55. And now it breaks and goes to this particular statement. Y equals to 0, which is not true. So it will go to the else part and it will print the result. Now can you just everyone guess a quick catch on this problem, which is not totally required? Okay, what is one thing which is you feel is not required here? It is an extra thing which might create a different user experience. Y equals to 0. So every time now what I do is, instead of 55, I put 0 over here and I still do a plus operation. Now I run it. I'm trying to do a addition, but now what am I getting is, let me show you what you will get. I am getting invalid denominator for operation, right? This is only required for division. So this thing should go inside this. If y equals to 0, print this statement and then return, put the break statement, and you'll have to put the braces over here as well, which I'm just ignoring for now. But that is the case, and if should go over here, and it should not be the else statement over here. Okay? All you can do is, you can just put a check over here, or you'll have to put a flag over here that it breaks. And if you know the result is still 0, you can just mention 0 as well, or you can mention something else, or you may write something in default. Yeah. But the whole crux, I think, for the people who were able to solve it, I think how you handle the case is up to you, multiple ways to handle it. But the crux part is, were you able to implement the 4-step cases using switch statement or not? It did not come because, okay, let me print it now. Let me just remove, let me just run this. Previously, that was it was under if else statement, hence it did not come. But let me print that and show to you. It will print 9 because now x is 9, y equals to 0, and there is no result is 9 you will get over here. There is no if else statement. It did not come before because there was a if else statement taking care of y equals to 0. Next topic, I guess, right? All right, so we'll go to the loops part. Okay, now so far okay, so quickly we'll come to the while loop. First of all, in general, if I talk about loops, right? So previously, when I was talking about if else statements, what criteria I gave, or what example I gave, that if it is raining outside, take umbrella, else take my parcel and go away. And then multiple if else is, if it's raining, take umbrella, if it is sunny, take sunglasses, else take my parcel, right? So those were one statement. The job has to be done once. Taking umbrella has to be done one. It's a single time doing an action. But loops are something where same action is repeated over and over time. Okay, let's say I tell you, keep stirring the water till the time you see all the salt getting mixed, right? So stirring the water even right now over here is an action. And I have said, keep doing it till the time you see all the salt which I have put in the water is mixed and you can't see any more salt, right? So that is the condition. And that is the loops part, where same action is repeated again and again till the time a particular condition is met. That is loops. Now loops are two types. First one is while loop and second one is for loop. Okay, so we have first one as while loop and second one as for loop. First, we will be discussing about while loop. Okay. Now let's see this particular scenario. Initiating a variable, I think most of you are comfortable in doing this. Integer I equals to 0. Now what it says, while integer I is less than 5, while I, the value of I is less than 5, print I and then increment I by 1, I plus plus. Now when I execute it, it will give me everything from 0 to 4, because once I becomes 0, this is true. This gets printed as 0 and then I is incremented by 1. So I become once, I became 1, 1 is still less than 5. So again, this statement is printed till the time I becomes 4, 4 is still less than 5 and 4 gets printed, I becomes 5. Now when I is 5, this statement becomes false because 5 is not less than 5, right? So this statement does not get printed and while loop exits. Correct? You guys tell me, what if I want to print 5 over here? What is one small change I can do? I can do multiple changes, but let's say I want to print from 0 to 5. Okay. If I do less than equal to 5, fifth condition will get executed and then I will see 0 to 5. And other way around is I can use 6 till the time I is less than 6. Okay. Plus plus I will not help over here unless and until you put 6 over here, because even though increment is happening before, I is taking care of what the final value of I is. Okay, so this was while loop. Let's say I want to print even numbers only till 50. I want to print even numbers till 50. What can I do? I'll put I equals to 0, I less than equal to 51, or let's say I less than equal to 50. And instead of I plus 1, I can what I would do is I equals to I plus 2. So every time this is executed from I equals to 0, it will go to I2, right? So it will give me even numbers from 0 to 50. That's what I got over here. Tell me, what can I do to get multiples of 7 from 0 to 100? What can I do? Question is, okay, let me write the question. Print all the multiples of 7 from 0 to 100 using while loop. This is the question. What you can do is less than equal to 100, while I is less than equal to 100, and instead of incrementing by 2, increment by 7 every time. That's all. It will give you all the multiples of 7 starting from 0 to all the way, okay, starting from 0 to all the way till 100. Okay, 100 is obviously not the multiple, so 98 is the last multiple. So this is how you can get the multiple. There are n number of ways to do it. Either you can do it this way, or you can take modulus and loop till all. So x is I is less than equal to 100, and you can do a if condition. If x mod 7, like this, x mod 7 equals to 0, system.print out x. I mean, I just copied from someone's solution on the chat. Okay. But in this case, what will happen? The loop will check for all the values. Every value from 1 to 100 will be checked by the code to divide it by 7. So not ideally, optimal. What you can do is just plus 7 so that not all numbers are checked. Every time I is incrementing. In this case, only I think the number of prints, how many there? 6, 6, 9, 12, 15. Only 15 times the while loop will run in this case. But if you try to do a mod approach, 100 times loop will run, because you're trying to look for all the numbers from 1 to 100 and try to do modulus with 7. Okay. All right. So this was all about while loop. Coming to for loop. Now, again, a real world example, because that way I feel people understand it right. For loops are the loops where same thing are repeated for exact number of times. In case of while loop, it doesn't, is not very clear that for how many times it will run. While loop can be made infinite as well. Let's say I pass over here as true. Okay, this while loop will never fail. This will keep executing forever. You will get time limit exceeded. Your CPU will say, I can't execute it because it's an infinite loop. Right? Let's try to run and see what happens. It will keep printing I. It will keep printing 0, or it won't even print. It will keep buffering. Right? You saw. It kept buffering. It print infinite numbers of 0 and it will keep printing. Right? So while loops can be made infinite. But second, for loops run for a defined number of steps. For example, I tell you that keep chopping the onions till the time you have chopped 10 onions. Now, this cannot be infinite. You are chopping, you are cutting the onions, slice onions, right? One by one. And I've told you, do that till the time you have chopped 10 onions. So as soon as you chop the 10th onion, you will stop because that was the instruction given to you, right? So if I show you in terms of code, how it will look like, it will look like something like this. Let's do the same thing. What you are trying to do over here is we are trying to print integers from 1 to 5. This is the syntax. Do not forget the syntax. There are 3 parameters for loop takes. Unlike while loop takes 1 Boolean parameter, but for loop takes 3 parameters. First parameter is assignment. It makes sure that you are assigning something. You are using a variable and you're assigning and initiating that variable to something. Okay. Initializing happens in the first parameter. Second parameter is the condition. Till what time, just like while loop, right? The middle part will always be a Boolean expression, which will make sure that this is a expression that can turn false or can stay true for a while. And then last one is updation. The same integer should keep on updating. Now, if I want to print numbers from 0 to 5 or 0 to 4, right? What I can do is I can use this for loop where I'm initializing I as 0 and making sure I is less than 5 and then doing I plus plus. If I execute it, I will get numbers from 0 to 4. An exact same thing what we did for getting 5 in place. Either you can do this, so it will print 5 as well, or it will do, you can change 5 to 6 and keep the condition as it is. Now quickly use for loop to print all the multiples of 7 from 0 to 100. Same thing what you did in while loop, do it for loop. Multiples of 7 from 0 to 100. So what you need to do, I equals to 0, I less than or equal to 100 won't matter because 100 is not a multiple of 7. And in case of increment, you do I equals to I plus 7. I hope people who are posting in the chat have actually implemented it and have ran it, right? Just by writing it, it would not help much. So if you do it like this, you will get all the multiples which are from 0 to 98 or 0 to 100. Okay. Now, one thing. Do you all know what is a Fibonacci sequence? Fibonacci sequence basically is first 2 numbers are constant, 0 and 1, and next all the numbers are the sum of previous 2 numbers. And the first 2 constant numbers are 0 and 1. Right? Next number will basically become 1 because 0 plus 1 is 1. Next number will become 2 because sum of the previous 2. Right? Next number will become 3, then 5, then 8, then 13. Clear, everyone? This will go on. This is Fibonacci sequence. Nothing to do with Java or programming. This is a sequence. For this kind of sequence, the term has been given, and we call it Fibonacci sequence. And this is the term. Any number is the sum of previous 2 numbers, and First two numbers are 0 and 1. Now, gradually, the level will increase, guys. Okay, so it might be slightly uncomfortable for you. Maybe you start taking little more time to solve the questions, which is okay. Okay, we'll make sure that you get substantial amount of time to understand things. So the first question is, write a Java program, or let me just quickly paste it over here. Yeah, first question is, write a Java program that has a integer variable and print all the even numbers between 1 and that integer inclusive using while loop. So basically, put a random integer from 1 to 100, put a random integer, right? And then print all the even numbers between that integer and 1 in any order. Descending order, ascending order, doesn't matter. Second question. You need to check if a number or not, a number is prime number or not using while loop. Again, you that has an integer variable and check whether it is a prime number or not using a while loop. Get any number into it, get any number into a variable, and using while loop, check if what is a prime number, guys. I hope you're aware about prime number. Prime number is a number which is not divisible by any number by itself, right? That's a prime number. Any number which is not divisible by any number, like 17. 17 is not divisible by any number. Divisible by itself or 1. Correct? That's a prime number. That's the second question you have to do. Okay. Third question is, write a Java program that takes an integer input and prints the Fibonacci sequence that has an integer variable and print the Fibonacci sequence up to that integer using a while loop. So let's say I put the number 8. Okay. So you need to print Fibonacci sequence from 0 to 8. Or let's say I put the number as 21. Or 20 will be there, right? 21. So you have to print the whole sequence till 21. Okay, so the problem was, write a Java program that has an integer variable and print all the even numbers between 1 and that integer using while loop. Okay, so basically all the even numbers you have to print between 1 and that particular integer. So number num01 has been taken as an integer and assigned a value of 40 over here, and second integer has been initiated from I equals to 0. While loop has been created over here, and what has been done? Okay, I plus plus has been created. I has been incremented because you need to start from 1, so it makes sense. Either you could have done I plus plus over here, or it could have been done at the end and I could have been started with 1, but this also works. Okay, I equals to 0 and then you did I plus plus, so I became 1, and then remainder, calculating remainder by taking modulus of 2 with that I. If remainder is 0, print I, and else statement is not required. So it will keep looping in till the time I becomes less than or equal to 40. Now, if I execute this code, I will get all the even numbers from 1 to 40. So starting from 1, you get all the even numbers till 40. Okay, if you put AND condition over here, and you put modulus I equals to 0, something like this, this will loop out as soon as it finds a odd number, right? So you can't do that. You'll have to loop only this one. Yeah, it will come out of the loop, because as soon as while loop doesn't satisfy the condition, it will come out. So only first even number you will be able to print, or not even that, because 1 will not satisfy the condition. Okay, any confusion, anyone? All right, so moving on to next problem. Please put your solutions in the chat. Okay, Weber was waiting for my statement. I think within less than a second I got the answer. All right, let me take that problem, that solution itself from Webhub. Okay, scanner part I will remove because people have not yet gotten that part. So I'll just assign something over here. Okay, quite a complex code. I'll try to simplify it, but let's go to the question first. The question is, write a Java program that has an integer variable and check whether it is prime number or not using while loop. So all you have to do is check if a number is prime or not. Okay, you got a random integer over here. Let me remove this part. System.print that out. You initiated a integer called prime and assigned it to 17. Okay, I'll have to just understand the code first. We'll come to this part once we use it. And then for 0 and 1, okay, you can just mention that it's not a prime, right? If it is 0, if the number is 0, if the prime number is 0 or 1, you can just mention it's not a prime, because after that you'll have to figure out if the number is prime or not. Okay, so for 0 and 1, you can have extra case assigned that these two are not prime. Then comes the else part, which will have the heart of the logic of checking a prime number. Okay, and how are we checking prime number over here is, we initiated inc, which is another variable inc, as 2 to start dividing that number by this variable. So what is a prime number? Prime number, let's say 17. 17 is called a prime number because it is not divisible by any number starting from 2 to 16. Right? That is the condition. It should not be divisible by any number that starts from 2 to 16. So what are we doing over here is, while the inc, the number inc variable is less than the prime number itself, we are checking if it is actually divisible by any number in between. Okay, any time if this condition gets satisfied, the same time statement will be printed that this is not a prime, and flag will be updated to 1, and then this will break. Else, if this doesn't happen, variable will keep on increasing. So 2 will become, okay. So this is the only logic. That's all you have to, that's all you have to look for. What am I doing over here is, integer num equals to 17 and integer I equals to 2. Okay, boolean, we initiated a variable called boolean, which can control that if the number is prime or not. This boolean will try to use this boolean to print final output if a number is prime or not. So by default, we have initiated this boolean value as true. Okay, and next what we are trying to do is, we are trying to use while loop to run from integer I, which is I equals to 2, to num divided by 2. So basically, here is the logic. We don't need to check from all the numbers from 2 to 16 if the number is divisible. Even if we check, because after, let's say 17 divided by 2, how much it is? 8. Let's assume 8. If a number is not, if 17 is not divisible by any number till 8, it will not be divisible by any number after 8. Right? Because that's a logic. If you're trying to check if a number is divisible by something, you can just check the prime by half of the number. We are checking if that number modulus I, if the number module I is equal to 0, that means the number is completely divisible. Make is prime equals to false. That means it's no longer a prime number, and break the loop. So once the loop breaks, it will come out of the while loop. Right? I hope there is no confusion. That's all you have to check over here. So this boolean is important in terms, you can also over here itself you can print that it's not a prime number. Okay, but if you want to print that it is a prime number, that the boolean just puts a clean code. That's the reason we are using boolean. Without boolean also you can do that. Instead of doing if else over here, what you can do is, you can do system.print is a prime number, it's not a prime number directly at this place. That also can be done, but using this if else with a control variable creates more sense. This logic will basically check if any number is divisible by the given number from 2 to half of the number. Any confusion so far from any of you? Okay, and depending upon the boolean value, you can print appropriate statement using the is prime boolean method, boolean variable. Can you please repeat the logic written in while and if? Okay, so you initiated a number, a random number, 17, let's say, is a random number. And then you need to initiate two different variables. First is the integer I, which starts from 2, because you need to check if a number should be divisible by any number between 2 to number itself, 2 to the number before that, right? So what we are trying to do is, what is a prime number? You are aware, Mayank? What's a prime number? It should not be divisible by any number except one in itself, right? So we are trying to make sure that it is not divisible by any number between 2 to the number minus 1, right? So basically for 17, we are trying to make sure that it is not divisible by any number between 2 to 16, inclusive 2 to 16. And at the same time, you can check for all the numbers. You can check for all the numbers and try to have modulus of 2 modulus 17, 3 modulus 17, 4 modulus 17. You can do till 16 modulus 17. That's also is the case. So I can do this as well. Basically checking if I is less than number, this loop will keep running, and then number modulus I is less than number basically will create a loop from 2, 3, 4, 5, 6, 7, 8 till 16. And then if number modulus I will basically every time 17 will be divided by 2, 3, 4, 5 and checked if remainder is coming as 0. Anytime if remainder comes as 0, that means that number is divisible by I number. And it will make our is prime Boolean value as false. Okay. What are we doing over here? First two numbers are always 0 and 1. That is clear. Because that's the Fibonacci series I discussed. First two numbers are confirmed 0 and 1. Integer number, random integer you can take. So let's say I took 21. You can take any number. First two numbers you need to print because that will remain constant. Anyway, the whole Fibonacci series is constant, but you can print the first two. And then you initiated the third variable C and made it sum of A and B. And this could be our third sequence. Right? Clear so far? Third number will be A plus B because it's a third number. A and B will be the first two numbers. Now we come to the while loop and we start printing till the time we reach the number which we have set as a benchmark, till which we have to solve a particular problem. So while C is less than or equal to the number, first print C, and then A will become B, B will become C, and C will become A plus B. I want everyone to make sure that you understand these three lines. So basically, Fibonacci series is what? 0, 1, 1, 2, 3, 5, 8, and then 13, right? What is happening? First two numbers are getting summed up. We assigned A over here, and then we assigned B over here, and then we assigned C over here. And then we printed the C. While loop starts from here. So to make the while loop executable, C was A plus B. And every time we are printing C. Next time, if we want to print C, we need to make sure that this B becomes A, C becomes B, and then we'll be able to print C by using A plus B. That's what is happening over here. We are incrementing A to B, B to C, and C is becoming A plus B, and then after the loop, it's printing C again.
Just a quick info, guys. Intellipaat offers full stack web developer course in collaboration with ICT Academy, IIT Guwahati. Through this course, you can learn everything from front-end web development to back-end web development from esteemed IIT Guwahati faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of web development.
There is a number equals to 101, or it could be 1, 2, 3, 4, 5, or it could be anything. And you need to verify if that number is palindrome or not, right? Let's say 101. First of all, everybody knows what is a palindrome. Palindrome is basically, it's same, number is same irrespective of you read it from left to right or right to left. That's a palindrome. Okay. 1, 2, 3, 4 is not a palindrome. 2, 3, 7, 8 is not a palindrome. Whereas 44 is a palindrome. 1, 2, 2, 1 is a palindrome. 6, 5, 5, 6 is a palindrome. Right? 1, 2, 3, 4, 3, 4, 2, 1. Right? 3, 2, 1. This is a palindrome. Because number is same irrespective of you read from right to left or left to right. So to execute that, the simple approach that we can take is we reverse the number and then equate it. So number is 1, 2, 3, 4. We reverse it. What will the reverse of this number? 4, 3, 2, 1. And then we equate. Then we put a if condition and says if number is equal to reverse number. If this comes out to be true, that means it was a palindrome. Else, this is a pseudo code, guys. Okay, it's not actual code, obviously. Else, not a palindrome. Right? Simple. So basically, the whole palindrome question boils down to one logic of reversing the number, because this line is a very simple line. You just equate two numbers. If they are equal, send palindrome. If you are not equal, send not a palindrome. Right? So basically, the crux of the question becomes, how will you reverse the number? Correct. So that's the logic. Let me just copy the existing code that I have. We have got a number called 1, 2, 3, 4. This is taken by the user or hard coded. Anything will work. Correct. Now, what are we doing over here? Let me just remove the comments, because with comment it becomes slightly bigger. Okay. Now we initiated a second variable. Second variable is reversed number. And reversed number is nothing but we have initialized it as 0, and eventually we'll fill this reverse number with a value, and then we'll finally equate. Original number, if it is equal to reverse number, we'll send it is a palindrome. Else we'll send back that it's not a palindrome. Okay. So the whole logic lies between this while loop. We are reversing the number in this while loop, and later on comparing original number with the reverse number. Okay. And how we are doing that? The very first thing what we are doing that is, if number is not equal to 0. Number here basically means the original number. Let me change the variable name as well, so that it doesn't become confusing. Okay, this is basically a number. You can just take it as a number. All right. So same thing is happening over here. What we are trying to do is, we are basically trying to reverse a number in this particular place. Okay, number is 1, 2, 3, 4. We have initiated a variable called reversed rev number. A reverse number is equal to 0. And then this while loop is what we are trying to use to reverse a number. Now, and try to understand what is happening over here. While loop we have initiated till the number is not equal to 0. So till the time this number doesn't become 0, we'll keep this while loop going. Okay, till the time this number is not equal to 0. So what we are trying to do here is, while the number is not equal to 0, we'll keep running this loop. Now let's put in the comments what will happen at each step. First thing, integer digit. Number modulus 10. What will be the value of digit at the first round of while loop? What will be the value of this particular 123.4? No, that would not be the case. I'm not dividing it by 10. It's modulus. What does modulus mean? Yeah, 4. It will be 4. Can you tell me the compiler you are using? I'm using this online IDE Megha, and over there you can just select Java. You don't have to worry about which compiler is going on in the background. Anyways, so 4 will be used, right? So first time 4 came over here. And then next time what we are doing over here is, reversed number is equal to reverse number multiplied by 10 plus digit. What was the value of reverse number? 0, right? So what will be the value of this expression now? What will be the value of this expression now? 4. Exactly. So now my reverse number is 4 in the first iteration. And finally, what I'm doing is, number equals to number divided by 10. This is a short form. So basically it says number equals to number divided by 10. What will be the value of number now? 123. Exactly. Why not 123.4? What will be the value of number over here, guys? Will it be 123? Type is int. That's why it's the integer division. So the number will also be an integer. So it will become 123. Now the while loop will see again. If the number is equal to 0, no. Then again the while loop will run. And this time again digit will be equated with number modulus 10. Now what will be the value of digit? 3. Exactly. And then this reverse number equals to reverse number multiplied by 10 plus digit. Digit is 3. The reverse number value was 4. Now what will be the value of reverse number? 43. I hope everybody is getting not, because I see only few people responding. So guys, reverse number already had a value of 4, right? And now in this statement, we saw a value of 3. Digit has a value of 3. So this expression will become 43. 4 multiplied by 10 plus digit. So it will be 43. And then number divided by 10, this will become 12. So eventually what will happen? Reverse number will be able to reverse your number, and eventually this will come as 2 and 1, and this will become 0 finally. Okay, and the last number shifted will be 1. So this doesn't matter much, but you will find a reversed number 4 3 2 1. Okay, this is a simple logic of reversing a number. You keep taking remainder from the original number by dividing it by 10. You take the first unit place and then put it in the first place. So when you are starting with first iteration, I'll just put first. Okay, value of number, this value is 1 2 3 4. Okay, over here also first iteration, value of digit. What will be the value of digit in the first time when the while loop is run? What does modulus do? It gives you a remainder, right? When you divide 123.120.1234 divided by 10, what do you get? You get a remainder. Remainder will be 4. So first iteration digit value will be 4. Now what will be the value of reverse number in the first iteration? See the code and tell me. It won't be 0. Check again. Yeah, it will be 4. Why? Because reverse number is 0 in the first iteration, but digit has a value 4. So it will be 4. Okay. What will be the value of number in the first iteration? Value of number after in the first iteration, once the first iteration is done, what will be the value of number will become? It won't be 4, it won't be 3, it won't be 0. You are basically dividing 1 2 3 4. You're dividing it by 10. Once you divide it by 10, you will get 123, basically 123.4, but since it is an integer, you will get 123, right? Okay, so that's the first iteration. Let's come to second iteration. What is the value of number in the second iteration? Same. No, how came it will be 3, guys? Number, you got 123 in the last line, right? Now once while loop is checked, it will be 123. Yeah. Okay. Now what will be the value of digit over here in the second iteration? 3. Exactly. Awesome. Okay. What will be the value of reverse number in the second iteration? Reverse number, how come it will be 3? It won't be 3. Previously it was already had 4 as an answer. Reverse number was already 4. Now 4 will be multiplied by 10. It will be 40 plus digit. Digit is 3. So now it will be 43. Okay. And now in the second iteration, what will the value of this particular place? What will the value of number over here now? Okay. This line is as simple as, in the first iteration, we gave the value of 4 to the reverse number. So in the second iteration, when this line gets executed, okay, reverse number will be equal to reverse number into 10. So previously the value of reverse number was 4. It got multiplied to 10. So it becomes 40 now. And from the previous line, we got the value of digit 3. So we added 40 plus 3. So it became 43. Okay, so number became 12 in the second iteration. What will be the third iteration value of number at this line? Value of number in the third iteration. It will be 12, right? Because we left value equals to 12 in the last line. So it is 12. Third iteration over here, the value of digit, what will it be? It will be only 2 because we are taking modulus of number and number equals to 12. Okay. And then third iteration, What will the value of reverse number? Previously, reverse number was 43. So 43 will be multiplied by 10. It will become 430 plus digit. Digit is true, 2. So third number will become 432, right? And third iteration, what will it become? So plus 2, 430 plus 2, 432. So number finally, it was 12. And now again, we are doing number equals to number divided by 10. What will it be now? 1. Finally, in the fourth iteration, the value of number equals to 1. Absolutely. And then digit equals to, it will also be 1 because 1 modulus 10. If you divide 1, 1 is divided by 10, the remainder will be 1. So it will be 1. And now I should not be required to explain. This fourth iteration, this will become 4, 4, 3, 2, 1. Because reverse number value was 432 multiplied by 10, it became 4320. And then we added digit equals to 1. So it became 4321. And finally, over here, in the fourth iteration, the number will become 0. Absolutely. So when the fifth iteration comes and the number is 0, this will not hold true. So this will exit. And the reverse number became 4321. Right? 4321 is exact reverse of the number which we had given. Right? So that's how we can define and we can reverse a number. And finally, we can compare if the original number is equals to the reverse number, we return it's a palindrome, else it is not. Okay, so this is the problem of nested for loop, where you need to print a pattern something like this. It's kind of an inverted right angle triangle. All right. So what you do over here is you start with I equals to 5 and go till I equals to 0. Okay, or I greater than or equal to 1. Basically, you start with I equals to 5 till I greater than or equal to 1. And then you do a second for loop where J starts with 1 and it goes to, all the way to J less than equal to I. Anyone who has not understood it, I mean, this is kind of self-explanatory, but anyone who has not understood this particular problem, how did it execute? Got it? So basically, when I equals to 5, right? When I equals to 5, J runs from 1 to 5. Why 2 variables? That's what, because there are 2 for loops. There are 2 nested for loops. And because of that, we have 2 kind of a statement. Okay, I equals to 5. It runs from J equals to 1 to I, because we want to control 2 things we need to control. We need to control the row numbers and we need to control the number of stars in each row. Hence, we have 2 variables. Okay. Does it make sense? Write a Java program that calculates the sum of the digits of a given number using a while loop. Okay. So basically, it's asking to write a Java program that calculates sum of the digits of a given number using a while loop. Okay. The program should continue adding the digits until the sum becomes a single digit number. Now, what do you understand by this? Let's suppose number is again 1, 2, 3, 4. What will be the sum of all the digits of this particular number? 10. Okay. But the question says you should continue to add until the sum becomes a single digit number. So basically, after that as well, you need to add these 2 numbers and become 1. So once you pass 1, 2, 3, 4, the program should return 1. What the program should return if I add 899? What the program should return? Tell me. 8? Yes. You have to do 8 plus, okay, 8 plus 9 plus 9. The whole thing. Be specific, Juliet. I'm not sure what to explain if you say whole thing. So basically, the question is, you have to add the sum of the digits of a number and then keep adding it till the number becomes a single digit. Okay. So 8 plus 9 plus 9 should be 8 plus 9 plus 9 would be how much? 26. And then you have to add 2 plus 6 as well till the time it becomes a single digit number. So becomes 8. Okay. So that is the concept. All right. So the program, if I show you, first thing you have to do is, because you need to return a number, right? Let's say you have, in this case, our number equals to 1, 2, 3, 4. Okay. Now, till the time number is greater than 9, it can never be a single digit number if a number is greater than 9. Naina, I think sessions are already recorded, so don't have to worry about that. Yeah. So number is 1, 2, 3, 4, while number is greater than or equal to 9, because any number which is greater than 9 will never be a single digit number, right? So what we are doing over here is till the time number is greater than 9, we are calculating this thing, okay, which is integer sum equals to 0. First, we are initiating some variable to be equal to 0. And while the number is not equal to 0, till the time number is not equal to 0, we are executing this particular statement. Now, what this statement is doing, if you see closely, it's similar to what we were doing for the reverse of the number. We are taking the last digit and we are putting the sum. Basically, you can understand it like this. Sum plus number modulus 10. So we are taking the last digit of the number and adding it to sum. And we are changing number equals to number divided by 10. Okay. Same thing, what we explained for the reverse of number thing. Same thing is happening over here. Adding the last digit to the sum, remove the last digit. That's what we are doing till the time number is not equal to 0. Now, once number becomes 0, this will become 0 when the sum is equal to how much? 26, right? Because one by one we are adding it to sum. And now 26 will be assigned to number, because once it is 26, number will become 0. I hope you're getting, guys. At any point, if you're not getting, just let me know. Okay. Sum will become 26 at the time when 1, 2, 3, 4 will become 0, because every time we are doing the division. And in later part, we are assigning number equals to sum. So number is becoming 26 now. Now it will again, this while loop will be checked. Is 26 greater than 9? Yes, 26 is greater than 9. Okay. So what will happen? Again, this loop will go on and 26 will be again converted into 0 and sum will be brought it up as 8.
Let's have a quick quiz question, guys. And the question is, which data structure is suitable for implementing a dictionary with fast search, insert, and delete operations? And your options are stack, queue, hash table, or tree. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers full stack web developer course in collaboration with E&ICT Academy, IIT Guwahati. Through this course, you can learn everything from front-end web development to back-end web development from esteemed IIT Guwahati faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of web development.
And number will be assigned to number 8. Now 8 is greater than 9? No. Then loop will come out and number 8 will be returned. In the first iteration, sum will be 26 annual, right? First you will be calculating 1 plus 2 plus 3 plus 4. First you'll be doing this, right? I thought for summation. Over here, if you're saying length of the number should be equal to 1 only or less than 2, yeah, that will also work. Okay, sorry, I took the wrong example, guys. Okay, it won't be 26. I understand. I think I took this example 899. It should be 899 over here. Yeah. I think multiple examples we took, so we got confused. Yeah, so 899 and it will become 26. Let's come to the third question. Write a Java program that calculates the factor. Ping the solutions of third question, guys. Okay, great. A lot of solutions I received. So the question is, write a Java program that calculates the factorial of a given number using a while loop and if-else statements. However, the program should handle cases where input number is negative and display an appropriate error message. Okay, so factorial is going to be a very simple method. You need to put out the factorial of a number, right? Where is the chat? Yeah. So what are we doing over here is, first of all, number 0 or less than 0. Negative numbers do not have a factorial, right? So if a number is less than 0, throw an exception. Ignore this, guys. Ignore this one. I think you can just use print, print statement, println or something like that. Okay, system.print.out. I mean, system.out.println. Okay, factorial is not defined. And if number is equals to 1, I mean the integer number that you have received for which you need to find the factorial is greater than 1, you need to follow this approach. Factorial equals to factorial multiplied by number, and then number minus minus. Next question is, write a Java program to calculate sum of all numbers from 1 to 100 using a while loop. Yeah, put the solutions. It's a very simple code, and that's what you see on the screen. All you have to do is do a while loop and initiate a number from 1, initiate second integer with a name as sum and equate it to 0, and then run a while loop. Okay, while loop, what it needs to do, number should be less than or equal to 100, because we need to do a sum from 1 to 100, right? And then sum is equal to sum plus number. Every time you're incrementing sum and adding number into it, and then you're incrementing the number as well, right? And then finally what you're doing is system.print.out, the sum of the numbers from 1 to 100 is this particular sum. Okay, that's all what is required to be done. Any confusion, anyone? And the last is, write a Java program that calculates sum of the digits of a given number using for loop and if else statements. So what you're doing over here is, in last question, if you remember, we had to add the digits, we have to add the digits till the time the sum becomes a single digit. In this case, there is no such blocker, right? So what we have over here is, we have, let's say, a number, and let's say again this is number 889. This is the number we use, right? Or 988, something like that, 899, right? This will become 26, so you can return 26 itself. That's basically half of the implementation required as compared to the previous one. So what are we doing over here is, we are doing initiating nothing till the time number is not equal to 0, and we are keep decrementing number by 10. You can do this by while loop as well, like most of the people has done using while loop, which is perfectly fine. And you can do this using for loop as well. Okay. Inside this, you're initiating digit, which is the last digit of the number, and you're putting it in the sum, and then you're returning the sum. You can just use it like this for easy understanding. Okay, that's all the problem is. That is it. Okay, it's kind of a difficult problem because I want you to stretch your minds a bit. That's the reason I'll be giving you this problem. Try to solve it. Even if you are not able to, no problem. We'll discuss that again. Okay. So this time, last time it was a right angle triangle. This time you have to print a diamond. Okay. When I say diamond, it's something like this. Yeah. So this is the challenge. Okay. And if you're able to solve this, you can very easily, understand that you have cracked the most of the proper if else and while loop concept. Okay. So very similar to what we had done. This time also we need to control the rows and the columns separately. Okay. And this time, if you see, we have two parts of it, the upper half of the diamond and the lower half of the diamond. So we'll have to have a code flow that can divide both the parts. Okay. Now let me give you the solution. Very first thing is, you can put the size of the diamond that you want to print. Okay. Because depending upon the size, you will have to print that. Let me just zoom it out a bit. I hope it is still visible. Okay. Size will determine the size of the diamond. Let's say the size I have mentioned is 5. Okay. To deliver the shape according to first half and the lower half. First half, what are we trying to do? Again, any problem which involves, a shape or something, you need to have two variables to control it. Okay. That's the reason one can control the rows, other can control the column. Upper half is going to be this one. What we are going to do right now for the first upper half is going to be this one, and the second half is going to be this one. Okay. Now let's start. upper half of the diamond. We are starting with integer I equals to 1 and going till 5. So from 1 to 5, we are going I 1 to 5. So basically row 1, 2, 3, 4, 5. We are going to take care of these 5 rows in the first half. Inside that, what we are doing, we are printing space first, followed by the star. Now make sure, how will you print this particular places, right? How will you put spaces? You have to print space as well. And that has to be taken care of. Now see the logic that we are using. What logic we are using? Very first time, to print the space, we are moving j from 1 to size minus I. What is size? Size is 5 minus I. For the first case, I is 1. So number of spaces will be 4. 1. Okay, over here you won't be able to understand, but basically these are 4 number of spaces. As I becomes bigger, j starts moving from 1 to size minus I. So first time j will move from I to 4. Second time j will move from 1 to 3. Third time it will move from 1 to 2. And then it will move from only 1. Right? So basically, first time it will print 4 spaces, 3 spaces, 2 spaces, and 1 space. So this is for the first half of the problem. Within that, we have just discussed about the space. Okay. Next, we are going to discuss about the star printing. Now, for the star printing, what you need to do is basically for all I, same, this for loop will be true for both the within for loops. Both the inside 2 for loops, the above for loop will hold true. Right? So for I equals to 1, we are moving from k equals to 1 till k equals to k less than equals to twice of I minus 1. Now this is something mathematical equation comes into the picture. How many stars we have printed in the first row? 1 star. Second row, 3 star. Fourth row, 5 star. Next, 7 star. How you can equate row number with the number of stars? That's what we have done over here. Number of stars equals to twice of the row. Okay, let me put it over here. Number of stars equals to 2 into row number minus 1. Now keep putting the row number 1, 2 multiplied by 1, 2 minus 1. So 1 star. Row number 2, 2 multiplied by 2, 4 minus 1, 3 star. Row number 3, 3 multiplied by 2, 6 minus 1, 5 star. Right? So that's how you can calculate the number of stars in each row. That's what we have used in this for loop. And this is something it will come to you with practice, right? It will come to you eventually with practice. Now it's clear with the logic, sir. Okay, great. Okay, so that's how you need to develop a logic. This is a diamond case. Any other shape might come. So every time you'll have to equate the row number with the number of things you want to print. So that's how you'll be able to print the upper half of the diamond. Okay. Now the lower half is very, very similar. Lower half is just that you have to start reverse. Over here, we started with I equals to 1 and we went till size. Basically 5. In this case, you have to start with size minus 1. And go till I is greater than or equal to 1. And keep subtracting I minus minus. Right? Because we are doing lower half. So we have to start with 4. 4, 3, 2, 1. Like that. Above it was 1, 2, 3, 4, 5. Now for lower, we start with 4. Size minus 1. 4, 3, 2, 1. Okay. And then we need to print the space first. Again, space starts with 1, space goes to 1, 2, 3, then it starts with 1, it goes to 2, it goes to 3, and it goes to 4 spaces. So that's how the equation we have designed over here. It goes from j equals to from 1, size for the lower, no, size is 5. Size basically defines, okay, how should I tell you? Size basically defines the length of the diamond in terms of, for lower it's 4 because the total size of the diamond is 5. Okay, size you can assume is it as, how can I explain this? 1 second. Or okay, this is not the right example. Size over here, don't take it as an example. Let me just print a size 5 example. 1 second, just give me one side. Print. I'll explain this with a diagram. Okay, so size here, you can use the same diagram. Only thing is, the size here defines the height. Okay, no, the maximum star in the row, that is not the size actually, Amit. What you can assume is, this was the height. I mean, it depends on the question. Okay, within the question, it will be given as an example. What I created the example thinking of is, the height of the diamond is 5, right? Basically, from the base of the diamond to the top of the diamond, that is 5. So that defines the size. From the base till top, how many rows are there? So we have 1, we have 2, 3, 4, 5. So that's how I imagined the question to be and how I designed it. You can also get a question where, as Amit said, it can say that size is the maximum number of stars in a row. So in that case, these particular thing will become upper half, but don't worry about that. So size is the height of the diamond. Now, when size equals to 5, the upper half diamond size, what we are discussing over here, becomes 5 because this is 5. And automatically, since we want to print the lower half as well, what does the size of the lower half becomes? -1, because the base is common and you have printed the base in the upper half. So the lower half will become -1. All right. So for the lower half, we need to start by printing 1 space followed by 2 space, 3 space, 4 space. So for that, what logic we have used? We have started j with I. J with 1. And we have moved j till size minus I, size -1. And then we're doing j plus plus. So for the first time, since I is already size -1, so j will become 1. Because in place of I, if you put size -1, j will become 1. So j will move from 1 to 1. That means only 1 space will be printed. Second time, I will be decremented, right? So I hope this logic makes sense, right? Every time you are incrementing j, hence you are able to print more spaces.
Just a quick info, guys. Intellipaat offers full stack web developer course in collaboration with ICT Academy, IIT Guwahati. Through this course, you can learn everything from front-end web development to back-end web development from esteemed IIT Guwahati faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of web development.
Now, arrays are a very important topic because irrespective of whichever data structure you come across, irrespective of whichever data structure you deal with, arrays is going to be a handy piece that you need to master and you need to use at every step. Okay, so the very first thing is arrays. There are certain things which is not mentioned over here, but I still like you to tell you. Arrays are the collection of multiple values. Okay, just like we had variables. Let me just do one thing. Okay, just like we had variables like int, or let's say string only, which will take, let's say string my str. Okay, just like variable used to have only one values. Okay, we have arrays that can take multiple values in the same variable name. So here, if you see my string, my str containing Shubham as the only one value, but cars is again a variable, but the data type of cars is not string, is array with data type as strings. Here, the data type is a string. Okay, but over here, the data type of the variable cars is a array. Okay, you can call it, people to call it as an ND array, basically means n dimensional array. Over here it is a 1D array because we have only one list. There are no list within the list, right? No array within the array, so it's 1D array, right? And what is the difference of declaring an array? What we can do is we can initiate the array with 2 square braces. That's how you can declare an array. Now this array declaration can happen like this as well. This was for string. For int, what will I do? I'll do this. I'll say nums, and then I'll create this 3 5 7 6 43 00. This is also a array, but now this is the array of integers, and this is the array of strings. Okay, I hope till this point we are clear how to initiate the array. Okay, now the other thing is, if I want to print this variable, my string, what will I do? I'll do system.print.ln my str. If I do this, I get Shubham. What happened, guys? Okay, once I do this, I get Shubham as printed because the value of my str was Shubham, right? But what if I want to print BMW from the array? How will I do it? Let's try to print the whole variable itself, cars. Let's see what happens. Okay, it has printed some gibberish characters, which says java.language.string, and then it has mentioned something which is not something what we desired. Now, to access a particular element, what we need to do is we need to do indexing. Now, indexing is nothing but it tells you and it gives you to access how to do it. I mean, it starts with 0, 1, 2, 3. Now, automatically arrays gives indexes to its values. Okay, and now if we try to access, let's say BMW, if you want to print, if I do car 1, now we will get the required result, which is BMW, because we have cars as the variable and we are using the index of that particular variable and getting the answer. Similarly, for nums, if let's say I want to print if I want to print 43, what is the index of 43? 4, because 0, 1, 2, 3, 4. It's 4. So if I print 4, it will give me 43 because 43 is at the 4th index of nums. All right. Now, there is how to print complete string. Complete string as in? Okay. Now, let's say you want to change something. This was accessing. Now, let's say you in case of BMW, I want to print, let's say, quid, KWID. That's a different car altogether. What we'll have to do? What we'll do? We'll try to override it, right? Let's just try to override it. Let me try to override this using cars 1 equals to, and we assign a string, which is quid. And let's try to print cars 1 again. Okay. Now what we saw that strings are mutable. Now there is a property called mutable and immutable. I'm not sure if you guys are aware of mutable and immutable. Okay. Mutable basically means you can change the value of that particular data type in which it is present. So basically I have values inside array, right? But I can modify it by accessing an element and overriding it or changing it. And then once I print it, cars 1, it gives me quid, right? So that is the immutability factor of arrays. Now somebody asked how to print all the strings. What you can do is you can very easily use a for loop, right? By using a for loop, you can do integer I equals to 0, I less than equal to, over here you have to put size of the array, less than size of the array. I'll come to how to calculate the size, but for now, since we know the size is 4, let's put 4. Okay, I'll tell you, hard coding is not required. You can actually put the size of the array. I'll tell you how to do that. And then do I plus plus. And then you do this string dot print dot out over here, and you pass on I. Right? Now, if I try to execute this, you would see all the values which are present in cars getting printed in the line, right? So that's how you can print all the values in the array. Okay. Okay. Now I was talking about calculating the length part. Now, the very first thing what you can do, and it's the simplest thing, to calculate the length of an array, all you have to do is use the dot length functionality, which is already present in the main class of Java. So all you have to do is system.print.out cars dot length. If I do that, I would get answer as 4. 1 second, I keep forgetting to put semicolon. I'm actually a Python developer, so yeah. So yeah, you see 4 getting printed. Now what we do, instead of hard coding it 4 over here, what we'll do, we'll put cars dot length, and then we'll remove this and then print this out. Okay. Now let's move on to looping through the array, which we have already covered. Different way of doing it, but it doesn't matter much. Instead of for loop, it's just the a modified version of for loop that can help you to shorten things up. So basically in the new version of Java, this is being supported, where what you can do is, just like in Python, I hope you have been taught a basic looping part of Python. In the for loop, instead of defining I, instead of letting I run from 0 to size of the array and then keeping I plus plus doing every time, what you can do is you can initiate a variable I and then use this colon and say cars. With for loop, what will it do? It will keep putting the value of cars one by one into this I, and it will keep printing it. So if I do like this now, it will print the values of cars. Okay. Keep this in mind, guys. The arrays are always, or arrays will always take one data type values only. Unlike Python list, in Python list, you can put anything in the Python list. First element could be string, second could be integer, third could be a dictionary, fourth could be another list, right? But in Java, all the array elements will be of the same data type. Okay, I hope it makes sense. Now let's say, so far we were talking about a single dimension array. Now single dimension basically means you have directly the values inside it, right? It doesn't have anything. Arrays does not contain any other data structure. Arrays contains the values directly. Now there could be certain arrays which are two-dimensional. Basically, you can imagine two-dimensional arrays to be a kind of a square. Let's say, I'll give you an example. This is an example of one-dimensional array. Two-dimensional array could be, two-dimensional arrays could be, this could be an array. So basically, you can imagine it to be a square. it's tough to visualize like this, but basically understand that each column is a element in the array, and each column is itself an array, right? In this case, each column, again, each value is directly a value itself. Each column contains only one value, so it's directly a value. So it's a 1D array. But over here, each column is itself an array, and each column is a value in a particular array. So it becomes a 2D array. For 3D array, you can just imagine that each value has a 2D array. Okay, it might take a slight confusion to visualize this. We'll have both row and column as index. Yes, I'll come to that, Drishika. Yeah, but just understand the 2D array and 1D array and 3D array, it could be n-dimensional array as well. Obviously, after 3D array, you won't be able to visualize it, right? After 3D array, you can't visualize it, but that's it. Box within a box, yes. So if I talk about multi-dimensional arrays, it's a very great example. I'll show you how to initiate that. It's like this. Very first thing is data type. You have to specify that of which data type you are creating the arrays. And then in the 1D array, we were specifying only one square braces, pair of one square bases. But in case of 2-dimensional array, you have to use 2 pairs of square braces. Can we use step values in arrays in Java like Python? Step values. What is step value? I'm sorry, I can't recall what is step values. Do we need to define row and column differently? No. I'll show you how this has to be done, Rohit. Okay, so let's talk about the 2D arrays. 2D arrays is you defined an array and there are 2 elements in the array. First element, second element. Now these 2 elements are not values, are an array itself. So basically this is also an array and this is also an array. First array has 4 elements, second array has 3 elements. Now each of these values can also be an array. In that case, it will become a 3D array, right? That is one thing. Now let's say I want to print a particular value. Whenever you want to print a particular value in a 2D array, what you need to do is you need to assign the row number and the column number. So if I put this as a visual representation, so value 1 is equal to 1, 2, 3, 4 array, and value 2 in a main array is 5, 6, 7. Okay, value 1 is basically a 0th index. 0th row, right? First row, 0th index, and this is first index. You can assume it as row 1, row 2. Okay, 0th index has 4 elements. First index has 3 elements. Now what are we trying to access? We are trying to access first index, and I mean, in terms of rows, first will always represent a row, second will represent a column. So first index in case of row and second index in terms of column. First index in terms of row, and what is the second index in terms of column? This is 0, this is 1, this is 2. So we got 7. Okay, so that is what you see 7 being printed. Okay, now let's say I want to print 2. What should go in the indexes? Tell me. If I want to print 2, please zoom a little. Okay, 0, 1. I need to print 0, 1. Okay, so this is how you can do a you can create an array, a 2-dimensional array, and access the element. Does index always start from 0? Yes. In case of Java, Shiva, it starts from 0. In case of Python, it starts from 1. So it's a language specific thing, but for the most of the languages, it starts with 0. Now a very interesting thing. Now if I want to print all the values in a whatever fashion I want to print, right? How will I print it? In the previous 1D example, what did I do? I used a for loop and I just created a for loop that can go over all the index and print it. But in this case, it is going to be slightly different because two arrays are involved. We'll have to create a nested for loop. Only one for loop will not be enough. Why will it not be enough? I'll tell you why. If I print only one for loop, okay, let's do and see. So for int I equals to 0, I less than my numbers dot length, leng length, okay, and I plus plus. Now let's say we try to print all the values using only one for loop. Let's see what happens. What are we going to do over here? Okay, I'll have to type the whole thing. System dot out dot print ln. Now what should I pass? I will pass my numbers and then I'll pass I. That's how we did in the 1D array, and it solved our purpose, right? Let's try to do that here as well. And I try to print it. Let's see what happens. It gave me gibberish character. These are not, but basically a memory location of where these arrays are stored. Okay, I think someone asked as well, memory locations about thing, right? So for I, we need to give row length. Okay, anyways, so these are memory locations. So we are able to access this particular array memory location, but we are not able to access the elements within it. So to access the elements within it, we'll have to create another for loop that can loop in. So in the first for loop, we'll loop between first element and second element. That's how the first for loop will do. Second for loop will be looping inside each of the rows and take the values. And that's how we'll do. We can't use the same variable inside the second for loop. So we'll be using a different variable, which is j. And j less than. Now tell me what should come over here. So far we were using the array length, my numbers dot length. What should this place should come? Just fill in the blanks and then we'll come to j plus plus. J is less than what? So basically over here, what will be there? It will be my numbers dot length, which is basically I'm saying when I'm iterating with the top array, when I'm iterating, I'm basically getting the length of this array, right? So length of array is I'll get 1 and 2. So the length of the first original root array is 2. But when I'm iterating in this array, I need to get the length of this particular first array. How will I get the length of this array? First, I'll have to access this element. Accessing this element will involve my numbers and I, because I is running from 0 to length. So first this will be accessed and then dot length will give me the length of this particular array. Okay, so what I'm saying is we want to print the values inside the 2D array, only the values, right? For that, we have created the first for loop that will loop in through the root array. Root array has two values. First value is the first array, second value is the second array. But if we directly try to print the first value and second value, it will give us a gibberish character that you see over the screen on the right side. Hence, we want to have a second loop, second for loop that can run within the first element and the second element and give you the values. And how to do that is using a second variable called j, and then j will be accessing the elements of the root array one by one and getting the length of it. And that's how for loop will run. Okay, make sense? Now tell me what should I print over here? My numbers I and j, because we want to print the elements, so ith index and jth column. Okay, now to help you visualize, I'll print something. Once this first iteration is printed, I'll print something over here like first row has, okay, let me print over here as, okay, now let me just try to run it. Okay, now what you see over here, we are able to print things. 1, 2, 3, 4 got printed through this for loop, right? Then this for loop got ended because this was ended, and hence this for loop, it came out and printed this. That first row has been printed. Then it went back again because it is going through all the elements. So it went to the second element. It printed, this for loop printed the second element, 5, 6, 7, and then it printed out second row has been printed. So I did not face any problem. Hence, you can write this way as well. Not just in 2D arrays. You can do it in the 1D array as well. You can write either over here or directly over here. Let's try with both the places. Let's see what will happen then. Because concept has to be clear, should be clear. It gave you errors, right? So basically, it has to be only at one place. Either you add it there or you add it here. Okay, cool. Let it just print it out. Now it will say 0th row has been printed and the first row has been printed, right? So index runs from 0, right? So that's why it is printing 0. But I wanted to give the print statement more like a human. So as a human, you won't count something like 1, 2, 0, 0, 1, 2, right? You will count as 1 and 2. So that's why it was 1. Okay. Before I give you questions, guys, I missed one more important aspect, which I'll cover right now. I'm so sorry for that, which is regarding the behavior of strings like an array. Okay. So let's say if I define a string called str and I assign it to Shubham. Okay. This string, this whole string acts like an array. Everything that is applicable to an array will be applicable to this string as well. Now, when I say everything that's applicable to a string will be applicable to this particular array, what I mean is, let me just show you one quick example. Okay. Let me just write for int I equals to 0.
Let's have a quick quiz question, guys. And the question is, which algorithm is used to find the shortest path in a weighted graph? And your options are breadth first search, depth first search, Dijkstra algorithm, or Bellman-Ford algorithm. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers full stack web developer course in collaboration with ICT Academy IIT Guwahati. Through this course, you can learn everything from front-end web development to back-end web development from esteemed IIT Guwahati faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of web development.
What you see over here is string. I am able to access individual element using a for loop, right? This is not possible with integers. This is not possible with float, decimal, boolean, anyone. But with string, I can use a for loop that can access things individually. Also, string length I can do by str.length length, and that will give me the length of the string. And to access the element, instead of directly accessing by using a square braces, the string library of char act, which is basically means character at this index, I can use it. Now, if I run this basically will loop through all the characters I have in the string and it will give me the result, right? So that is something I wanted to showcase you, the behavior of string just like an array. Okay, now I'll give you a list of problems that is something you would please try to solve that out. Here is the list of problem. Let me just zoom it as well. The certain question you would find as slightly tough, which is something I have given it deliberately because I want you guys to focus bit on the because we need to keep improving the level of problems. So the first problem is find the maximum element in the 1D array, right? Write a Java program that finds the maximum element in the given 1D array and return its value. You can use anything. You can use max function, you can use looping, whatever you feel like. you can use to do this. You don't have to take input from the user, give random 1D array and then do it. Second is calculate transpose of a 2D array. What is a transpose, guys? Okay, let's say 1, 2, 3, 3, 4, 5, 6, 7, 8. What is the transpose of this? Interchanging rows and columns. So the first column is 1, 3, 6. It will become a row. 1, 3, 6 will become a row. Second column is 2, 6, 7. It will become the second row. 2, 4, 7. And then third column, third row is 6, 7, 8. Sorry, third column is 3, 5, 8. It will become a third row. Okay, I hope everybody has got this. Okay, so that's what you have to do in the second problem. You have given a 2D array. You need to find the transpose of that particular 2D array. Third is find the sum of each row of 2D array. Okay, and program should return an array of row sums. So let's say if this is a 2D array, you have to find the sum of each row. What will be the answer of this particular input in the third question? Third question may, if we provide this particular as input, what will be the answer? 6, 12, 21. Fourth question is, check if 1D array is a palindrome. Palindrome is left to right, right to left, same thing. That is palindrome. Fifth question, need to go with string and go with integers, Reshma. No need to go for strings. Go with integers only. For all the arrays, guys, go with only integers. No strings. Then search for an element in 2D array. Return, if it is not found, return -1. If it is found, return its position, column, row, and column index. Yeah, that's right, Dinesh. Reverse the array and then original right. Reversing the array or some other method, it's up to you to figure out, but that's what it is. Yes. And the final problem is searching an element in 2D array. How much time you guys need for this? Let me write this function, paste it over here. Okay, and let me just create a random integer. I'm using a previously written code because I don't want to, waste time or anything. All right. So let's say you have an integer like this, right? A random integer. You can put n number of values over here in case of any order. Okay. Assign max to any one of the integer. Like, let's say first element, you assign that this is the max value. You can also take, if it is an integer, you can also take int min. There is something called int min. Basically, it says the minimum value of the integer can hold, but you don't have to go to that specifics. What you can do is you can assign max as the first element of the integer. Now run a for loop from first element of the array to the last element of the array. Simple. If you encounter any value which is greater than the max, if you encounter any value from first element of the array to the last, and you find any value which is greater than the max element, which was our first element in the array, replace max with that element. And then finally, you can print max. It's not mandatory to write this, but some of you I see have done it like 0. But what if I do like this? What if your integer is this? If you initiated max as 0 and all the arrays in your integer, in your array are negative, max will print 0. Right? So this is the corner case. But in fact, answer should be, what should be the answer? -2. Because -2 is the max number in this one. But it will never get printed. Right? So either you write array 0, right? Or you write int min. Int min basically says the minimum value an integer can take. Because 0 is not a minimum value. You would find numbers lesser than 0 in the array. Right? So have a int min will basically say lowest possible value an integer can take. Yes, it's the first element of the array. The question says that you need to find the maximum element in the array. Okay. Now, what approach I have taken? I assume that my maximum element is the first element. I assume that. Okay. And then you, first you're assuming. And then you ran a for loop and checked if any element is more than my assumption, replace that element with the max. Okay. Let's say this is your 3 by 3 matrix. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. What I did was I calculated, and okay, matrix, if you guys know about difference between a matrix and a 2D array, matrix will have same number of columns, and I mean each of the row will have same number of columns, right? That's matrix basically, right? So if I am assuming column variable and getting the length, if it is 3 for the first element, it will be 3 for the rest of the element as well. Okay, so what I'm getting is, first I'm creating matrix, a random matrix I'm generating, randomly putting numbers, and then I'm getting the matrix length. Okay, and then I'm getting the number of columns. Number of rows I'm getting by matrix length. This will give me how many arrays are present inside the root array. And then columns will give me how many values are present inside the each value, which will be same for all. So this is also equals to 3. And this is also equals to 3. Now what I did, I created a new matrix called transpose. Okay. And then I created new, okay, this is something might be new to you guys. Let's say you want to create an array, but you do not want to initialize it. So far, what we were doing something like this. Even for 1D array, we were doing like int ARR equals to something 1, 2, 3, right? We were directly initializing it. But what if I just want to have a empty array of certain length? Okay, if I want to have an empty array, this is empty array. Let's say I want to have something like this, that it has allocated the spaces, but the values are missing right now. I will put the values later. This is the way you can do it. The first left hand side is same as the first one, but next I'm using new int, and I'm passing the number of columns and rows I want. Okay, now why do I pass columns and rows? Because I want transpose, right? So number of rows in the matrix will become number of column in the transpose, and number of columns in the matrix will become number of rows in the transpose. So basically I created a new array which has 3 columns, 3 rows, but all are empty, and the name is transpose. That matrix name is transpose. Okay. All right. Now what I will do, I will simply start a loop and going through all the elements, right? One by one, the same way we did for printing the numbers, right? Similar way, I'll be going through all the numbers, and I'll start filling the transpose in the opposite way. Basically, transpose is what? The index become the column, and the column becomes the index. So for matrix IJ, I'll be filling it in the JI. That's all it is. What did we do over here? Where is that? Where is, I removed it? Kya? We wrote a sample of that one. Okay, I removed it. Anyways, so basically the rows will become column and column will become row, which basically means JI will get interchanged in case of transpose and matrix. We'll go to the third problem. Start putting the solution for the third problem. This columns, I'm trying to figure out what is the length of each values inside the root array. So first thing is 3 values are present, but this could be something like this as well, right? It could be something like this. It's not necessary that columns will be equal to the rows always, right? So I'm trying to, and this will become 4 now. So I'm trying to figure out that although the root array has 3 values, what is the length of each value which is inside the root array? So these are arrays inside the root array, and what is the length of that array? So what I did is matrix 0 will give me the first element inside it, and I'll get the length of that particular. And since it is a matrix, all the other values will be of same length. Let's say I have a matrix, same matrix I'm using 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Number of rows will be matrix dot length. Number of columns will be the length of first matrix. Okay. Clear so far? Similarly, what I'm doing is I am creating a array called row sums, which is a empty array and has number of values equal to the number of rows, because we want to return the array which is the sum, which is basically the sum of each row. So number of rows will be equal to the number of values we will have in the final array. Now this will be the heart of the solution. I'm just walking through each rows, initiating a sum equals to 0, and then I'm calculating sum for the jth, for each row. Yeah, okay. And then I'm appending that row into the sum. This is very straightforward. You just have to visualize it. I'll make it slightly more doable. So I'm initializing sum equals to 0, but for each row, I'm using j to walk myself through each row, right? And then I'm putting sum, appending the matrix result, whatever I'm getting, into the sum. And then I'm pushing that value into the ith column of row sums what I have created. Okay, got it. So now you see, it's basically an array. Okay, Suraj, I'll explain that line. It's basically an array. I'm just printing that array into, I'm printing that array values into separate lines for the ease of understanding. Okay. All right. So what do we see over here is this output. First row is 1, 2, 3. So answer is 6. Right? The sum is 6. Basically, what is happening? One iteration, I can show it to you. So you started off with the first array. Let me do this part as well. It's more like 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? When I equals to 0, I equals to 0 is this first. The I equals to 0 is the first row. Right? And then we are iterating from j equals to 0 to j plus plus. Basically, it will go from 1, 2, 3. Right? Column, j is the column, right? So it will go from 1, 2, 3. And it will print the sum. Take the sum of 1 plus 2 plus 3. And then it will append to row sums. Row sum is nothing but an empty array which has the number of spaces equal to the number of rows. Right? So that is something you can use to visualize it. New int is nothing but you create a new array with spaces equals to rows. If you visualize it, this will be basically like row sums is equal to, this is what it will create, an empty list, empty array with specified number of empty spaces. That is what it says. Okay. All right. You got an array. Fine. You created 2 pointers, start and end. Okay. Start is 0, basically start index. End index is array length minus 1. This will give you the last index. Okay. So start and end, these 2 indexes are clear to you, right? You create a while loop. While start is less than end. Basically, this is your start index. This is your end index. If array start is not equal to array end, return false then and there. Basically, it's saying at any point of time, if start is not equal to end, just return false from there. Or maybe if you are printing, you just, yeah, over here you can say break. You can say break, and you can here print itself that it's not a palindrome. Print that not palindrome. Okay. and then you break. Else start plus plus, end minus minus. If these both are equal, you do start plus plus. Now start will move to this place and end will move to this place. Right? Again, these both will be verified. This loop will keep running till the time start is less than end. If these two matches, again 2 and 2 matching, start plus plus, end minus minus. Now what will happen? Both start and end will come over here in the third position. I mean, in the place of 3. Now this will not hold true. This will come back of the loop. And if it has came back out of the loop without breaking or without printing anything, it will return true. Basically, this was a functional approach. So return. Okay, I took a functional approach, but if you're taking a Boolean approach, this is something flag approach will work, which people have done. So basically, you create a Boolean or anything. Let's take an int only. Int flag. By default, keep it as 1. 1 becomes 1 basically means true. If this happens, you put it as 0, and then you do break, and then what you can do over here is if flag double equals to 0. I mean, this is very simple, so I'm just putting it in print not palindrome, and then else print palindrome. Okay, so this will also run for only half of the time, similar to what Tami said. Okay, his solution also runs to the half. So you don't have to compare every time. You don't have to compare one with this first with last, second with second last, and then reverse it. You just have to use 2-pointer approach. I mean, this is one of the solution which can keep comparing using this while loop. And as soon as anything mismatches, it will break and convert flag as 0. And later on, using that flag, you can put non-palindrome. Okay, so let's say I have a matrix like this, same matrix which we have been using, and we need to find 5. Same thing we are doing. We are basically making sure this thing you can do it over here as well. But just to make the code look clean, what I have done is calculated a row length and column length beforehand itself every time. And then I'm using rows and columns with the help of those variables. Not doing anything at all. What I'm doing over here is I'm just using a if condition. Walking through each and every element of that matrix and using the if condition. If any value meet my target, I return. People who have not used function approach, you can do it in a way which is just printing out. Print out I and j, calling them as row and column index. Okay, and you can just break over here. Okay, and also if there is no functional approach, you'll have to put flag approach, flag equals to 0 and stuff. And over here, you can just apply if flag is equal to 1, print -1, -1. Okay, I have kept it in a very short form. I mean, because I feel that now you should be able to understand these kind of commented code, right? So basically, I'm doing nothing. I'm just walking and passing through the matrix. I'm comparing. If anything gets compared with the target, I print out I and j because that is the position of that particular element. Okay, right now it asks me to run the program for output. So let's say we'll have to write it here. System dot print dot. Okay, let's see if this works. I have just written it very quickly. So let me try to run it. How to run it? What is the issue? This is for this. line number 31. Okay. 1, 1 we are getting because 5 is at a position where it is 1, 1. Now let's say I change the target. I change the target to 9. Okay, let's see what we get now. We should get 2, 2 because 9 is at the position which is at 2, 2. If I change it to 6, it will give me some different answer. I mean, system.print.out will expect if you want to write I, j, that's a different formatting altogether. You'll have to follow something like this. You might have learned in Python. This is the formatting. You'll have to do something like this. Let's say we remove flag as well. Whatever you have not understood, let me remove that. Okay, and I'll come and I'll show you when it is required and why it is required. Okay, let me remove these all. And this question is clear to you. Basically, we want to check if a particular number is present in the matrix or not. Right? So we have created a dummy matrix like 1, 2, 3, 4, 5, 6, 7, 8, 9, where we have 3 rows and 3 columns and like this. And we have defined our own target that what we want to search is 6. And we want to check if the 6 is present in this column and not. This is hard coded. This is not the part of the solution. This is something already there. Coming to the solution, first thing what I do, which is optional, you can do it on the for loop as well. But first thing what I did is I calculated the number of rows and number of columns in my matrix. Okay, using matrix.length and matrix 0.length. Now, I just like I taught about printing, how do you print all the elements of the matrix? We need to use nested for loop. We are using nested for loop over here. Okay, just to go over all the values. I starting from 0 to rows and j starting from 0 to columns. Basically, I will be iterating like this and j will be iterating like this. Okay, this part is clear. Nested for loop. Yes. Now, every time I'm encountering a value, I'm equating it with my target. Key checking if the matrix ij is equivalent to target or not. Every time I'm doing that, I'm evaluating this with target. Okay. As soon as this gets equated correctly, basically I have found my target. There is a value which is matching my target. If this condition holds true, if this condition doesn't hold true, I'll keep iterating using my for loop. But at some point, if this target matches, what should I do? I need to print, right? I need to print the ith and jth column indices. And that is what I'm doing over here. Search an element in the 2D array. Write a Java program that searches for a given element in the 2D array and returns its position, row and column index. I need to return to the user. Okay, this is the column and the row in which your element is present, your target is present. If element is not found, return -1. Okay, that is the question. That is why as soon as I get something equated with target, as soon as I find someone equivalent with my target, I immediately print out I and j. Now, yeah, now let's say I did not find, never ever this if statement got executed. Let's say I put over here 63. This is not present in the matrix, right? And I never found this particular part. This particular if statement never got executed, this line, because this statement always came as false because target is not present in the matrix at all. I need to print -1 now because I did not find it. Right now, there should be some variable, there should be someone who can tell me ki, this statement did not get executed. There should be someone to tell me. That's why I'll be able to print -1. If I directly write like this, I mean, I know you're not from coding background, so it might take a while to understand that. But if I directly write this, what will happen? I will be printing the target integer as well if I found the target, but at the end, it will also print the -1. But I do not want that. I want to print this statement only when I did not find the target. I need to print this statement of -1 only when I did not find my target, right? So there should be a piece of code over here that could tell me that this code did not get executed. So to do that, what we do over here is we create an integer called flag and we assign it to 0. And inside this if statements, I make that flag as 1. And now over here, I check if the if condition, if flag is still equal to 0. That means if flag is still equal to 0, then basically I am saying that this if statement never got executed. That means I never found my target. Else flag would have been converted to 1. Right? By default, flag was 0. So basically, if flag is 0, if flag is still 0, I am basically printing out -1. So this statement will never get executed because if condition will always give me false for every values. Hence, we want to make sure that the flag remains 0, and hence once flag remains 0, we are printing out system.print.-1. First problem is find the second largest element in the 1D array. Okay, and second one is calculate the sum of diagonals of 2D matrix. Diagonals matrix, you can assume a square matrix. Let me just QUARE. Okay, assume a square matrix and print the diagonals, sum of diagonals. So separate sum. And just give me one more problem. Yeah, and now next create a array. Find the element that appears most in the 1D array, and the 1D array is this one. Okay, this is the 1D array. Okay, this is the 1D array. So you have to find the element that appears the most in the 1D array. And then second problem is calculate the sum of diagonals of 2D matrix. First question is calculate the sum of all the elements in the 1D array. And the second question is calculate the average of all the elements in a 2D array. Yeah, third question is calculate the length of the array without using the length function. Don't use the length function.
Just a quick info, guys. Intellipaat offers full stack web developer course in collaboration with E&ICT Academy, IIT Guwahati. Through this course, you can learn everything from front-end web development to back-end web development from esteemed IIT Guwahati faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of web development.
All right. So array list, if I talk about, it's very similar to what we have already discussed, which is arrays. But the only thing is array lists are resizable. In case of array, how did we perform the action? If you remember, we defined the size of the array. It will be of 5 or it will be of 10 size or n number of size we used to define while initiating it. Okay, or we used to put a required amount of space specialized for the array, right? That actually created a lot of limitations in case of industry use case of arrays, because in the industry for academic purpose array makes sense, but for in the industries the requirement keeps changing, the things keeps changing, and you might have to alter the data structure, especially truncate it or elongate it depending upon what is the requirement. Okay, hence array list is a kind of a second version of array which is resizable. For array list, you need to import the array list package from util library. Okay, so if I just show you how to do that. All right, so working code will be covering that part, but right now I'll just show you through the example. So if you see over here, we need to import array list from java.util. That's the Java is the library, util is the package, and inside util package we have array list, which is the module. Okay, and to initiate a array list, this is the statement you need to create. Now I would just like to create it using this. I hope code is visible. Ignore the below aspects, just focus on the first part. All right, this is something we covered, that array list is something you can import using java.utils package. Okay, once you have imported that, you can use array list to create a array list object. Object, since we had already discussed, object is nothing but a replica of that particular module or that particular library, you can call it as, which you can use for your purpose. So what are we doing over here is we define array list using array list keyword. Inside that, we need to define the data type that we want the array list to contain. Strings is the data type which we are using for this purpose. It can be int as well. Once you do int, you'll have to change it over here as well. But for now, we are using strings. And we are creating new array list with the same string data format and creating a new object. Okay, so basically we are creating cars which is of array list type using a new array list object using from the module. What if we use directly like util star? In that case, you will have to do util dot array list. In this case as well, util dot array list, which is not the ideal method. So better to use, array list by directly importing array list as well. So the reason star still works, guys, if someone is not aware, if you put util dot star, the import statement will onboard all the packages that are present inside util. Okay, so this may still work as well, but util dot array list you might have to create. All right, so let's move on. The very first and basic thing is, how do you add elements in the array? For that, there is a simple add function that you can use on the variable that you have used to define the array list. Okay, what you can do is you can just do cars, which is the variable name in our case, dot add. You can add Volvo, BMW, Ford, Mazda, anything. I mean, you can keep doing it without a limitation in the size. So if this is the string, dimension, dimension will be restrictive. Yes, I mean, if you change the dimension, that goes to a different data structure altogether. The intent is having a data structure that is expandable or truncatable. Okay, the basic requirement has to be made sure that it's actually dimension wise we should be clear, and after dimension is clear, we should be able to restrict or truncate or expand it. Is it mandatory to write string? I did not get this. Yes, it is mandatory to write string because, okay, let's say over here we were trying to add Volvo, BMW, Ford, or Mazda, right? Let's say we want to have an array list that contains age of all the students that we have in the call. Okay, and age is an integer, correct? In that case, this array list would not contain string. It will contain integers. Hence, over here you will you will need to have int as a data type, array list that contains int. Or let's say, in this call, we just create a poll. How many of you are, let's say, in college or not in college, or let's say married or unmarried, anything of that sort. That will be a Boolean value, yes or no, true or false. So in that case, we will have bool over here. So this keeps on changing. I got it. So in case you do like this, java dot star, when you import everything from Java and then you're trying to have the array list, you need to have util dot array list. But in case you are doing java dot util dot star, you don't need to have util dot array list. Is there any default data type? No, you will have to write a data type. There is no default data. It'll throw an error. All right, so moving on, we now know how to add items. Now, one thing you can see over here is I can keep adding item as per my wish. I can keep going on and keep adding items till the time I feel that I have added all the items. So there is no restriction in terms of how many characters, how many names I can add. Okay, so this way. So please repeat fourth line. Okay, we have been repeating it, Suraj, multiple times. We are not doing anything except creating an array list called cars. Cars is a variable name. This is the data type of cars. Cars is an array list of strings. And over here, we are trying to create a new array list that is basically we're trying to create a new object of array list strings. That's how you create an object, right? Okay. All right. So if I run this code, you can see I will get Renault as well as the fifth item without altering anything in the code. So basically it's expandable. It's expandable to the memory allocation size of your system that you're using. So basically you can call it as an infinite. Okay. All right. So we covered the item of adding in the list. Now let's say I want to get some item. Get as in taking an item. So the best part of array list is time complexity, or the effort that is required to get an item is order of 1. Basically what it means is you can access any element in a unit time, and how you can do it is using .get functionality. So just put the variable name, use .get, and put the code, and put the inside parenthesis, put the index number. Let's say I want to have the third index number printed. Okay. What I can do is I can use this particular cars.get, and I can just print it out using cars.get.my index number. And now if I run it, what will I get? I should get Mazda, because that's the 4th element in my list, and that has index number 3. Right? I hope that's clear for everyone. It's a two very simple methods, adding and getting. You add something and then you try to fetch something out of the array list. Next is changing the item. So array lists are mutable. What are mutable? Mutable data structures are the one which allows the system to alter the data within it. Changeable, exactly. And how can you change it? You can change it by using variable name .set. Now if I do it, cars.set, and then it takes two parameters, only 2 parameters. First parameter is the index number, that which index you're trying to change. Let's say I'm trying to change Mazda itself, okay, to something called COVID. But data type should be same in set, right? Yes, absolutely. You can't just put over here as an integer or float or Boolean value. It has to be in sync with what is defined in the first place. Okay. And when I do cars.set, what I get is, okay, I set it out and I need to print it as well, right? 1 second, guys. So first it printed Mazda, and after I did the set, it should print COVID for me. Right? So that shows the mutability quality of array list. Okay. So what have we discussed so far? The very first thing we have discussed is initializing an array list. Second is adding elements in the array list. Third thing is setting a value or altering the value in the array list. Okay, got it? Now again, removing an item. It's again as simple as .remove functionality. What we can do over here is we can do cars.remove, and let's remove the third element index only, since we're talking about third index multiple times. Let's remove third index, and then let's try to print the third index. Let's see what happens. How did Renault got printed? Can anyone tell me? Because we deleted third index, it could have told me that third index no longer exists. How did Renault got printed? Because the array automatically shrinked. It doesn't create any empty spaces in between. Okay, so when we deleted the 4th item, which is Mazda, which we had converted into COVID, and we deleted it, so Renault took the place of the 4th item or the third index. Hence, we got the item as Renault printed once we try to access the third element. All right. Okay. What will happen if we do cars.clear now? Let's say you're fed up with everything and you just want to clear everything up. Let's try to clear this up, and let's try to print the whole cars again. Right, cars variable. Let's see what happens now. Okay, if you see, you saw an empty array list getting printed. Right? So basically, .clear clears out each and every element that is present in the cars. Okay. All right, moving on. Next is cars.size. I mean, these all you will have to remember. I mean, it might be tough to, understand in the first place, but you need to remember all these aspects. to make sure that you are able to solve questions. Any guesses what would car.size will give? I mean, obviously, it's a very simple guess. It will return you the size of or the number of elements present in that particular array list. Okay. So it says 4. Why does it say 4? Because before that only we deleted the third index one. We removed Mazda. Hence only 4 are left. Hence, once we do this dot size, we see 4 getting printed. Size is same as length. I mean, you can call it as anything. It basically says the number of elements in that array list. Yes. So you can length of the array will also be same only. Yes, that you can say size, and size is same as length. Yes. Okay. All right. Moving on. Now there is something called looping through the arrays. Okay. Let's try this one. We created the same array that we are discussing so far. Now, what we are trying to do is, instead of printing all at once, I mean, there is one way to print all at once is just print the whole car variable itself. Okay, I can just print it like this. And if I execute it, you would see whole values getting printed, right? But what if I want to print it like this and not like that? Not like an array in a single line, but like a individual elements in different line. So in array list, just like arrays, we can do loops. We can perform loops, and loops are nothing but initiating an integer starting from 0th index to all the way to the last index, right? Incrementing that variable by 1 every time and printing out the element using get method. Try to relate it with what we did over here. We did the cars.get to print an element, to get an element, right? Same thing you can do, but with the help of loops. There are certain times when you are very clear about what are the number of items you want to store. In that case, array is definitely a right option because of memory allocation, and there are things like consistency or adjacent memory allocation. So array is a fair choice in cases where you are very clear about what has to be inserted. But in case of uncertainty, array list is preferred. That's the only reason we are choosing array list, because it doesn't take size. I mean, it's expandable, truncatable, it's auto shrinkable, auto expandable. Okay. Does for colon loop work with array list too? I did not understand your question, Akshay. All right. So this was for loop on that part. Okay. Coming to the part where we can use for each as well. All right. So let's go ahead with certain questions. If data type is string, we can remove the ELE specifying the value, but if it is integer, it's taken as positive value, position value. How can we remove int value specifying the value itself? Okay, if data type is string, we can remove the element specifying the value. So this removal is the index number. What is the confusion here? Irrespective of it is a array list or array list of strings or array list of integers, you can remove it with the help of the index. Nowhere we are putting value to remove something. So let's put here as 10. Let's put here as 12, 13, 14, and 15. And let's try to put it as integer over here and integer over here. Okay, this is also an example of guys, this is an example of integer array list which contains integers. Okay, and now we are trying to system.print.or get, and then third element, let's try to put 100 over here. Okay, then get clear. Okay, let's try to run this. Okay, because this might assume as string. No, we can't do that. Can we initialize string in the starting and can convert integer into integer in the same program by 9? No, we can't do that. Initialization has to be specific in terms of dimension and the data type. Okay, so over here we see we are able to do this, and we are in the remove 3, we are able to remove the element, third element, which is 0, 1, 2, 3, 14. We are removing over here. Huh? Let's try to remove directly 100, because third position, third index, we are setting it as 100. Right? I hope you guys are getting it. Let's try to remove 100 and let's see what happens. Okay, so it says array index out of bounds. Index out of bound exception gets thrown only if you're trying to access an element which is outside of the boundary of the array list. So to answer your question, Tammy, we are able, yes, that remove statement will be able to remove it using the value because it's a string, but using when we have integer array list, it's not possible. Okay, we are replacing 14 by 100 and then we are not printing everything. 1 second. So let me do that. Instead of get 3, let me directly put cars. Now you'll see it. We were not printing the complete thing. Now can you see it? Yeah. Okay. Cool then. Okay. We'll begin with a basic question, guys. So I have some questions ready, which I wanted to share with you all. Okay, cool. So we'll start off with the first question, and you can start putting your solutions on the create a array list of integers, add elements 1 to 10, and print contents of the array list. Okay, cool. So let me put up my solution and then we'll discuss. Straightforward. You need 2 for loops, one for adding the elements, other one for printing the elements. You can directly print the whole array list as well, but I prefer to, print it line by line in the order. So first line, you're just initiating array list with integer. Someone asked me the question around if you need to specify the data type in right hand side as well, but it is not required. Okay, once you have specified for the variable that you're creating, that is enough. You don't need to specify it again. Okay, so numbers we have created, and we ran the integer I from 1 to 10, and then we added the numbers. Okay, and that actually inserted number 1 to 10 in the array list called numbers. And then using this for loop, we printed it using get method. Yeah, question was write a Java code to find sum of all elements in the array list of integers. So first you can just create a random array list and then create a sum. Right? So what we can do is add elements to the array list. You can add anything. I will just use some of your code only to add it. All right, so we added 3, didn't include the for loop here in this code. Okay. All right, so we added 3 random integers, 1, 2, 3. It could be anything. It could be 100 or 10 or 222 or 34. Anything that could be there. And then we calculate the sum. How do we do that? We initiate a variable called sum equals to 0, and then we create a for loop. Don't worry about this for loop. This is a modified for loop for the people who are experienced in coding. They might be able to understand. But you can write a simple for loop using I equals to 0, and similar to what we have done it. I is less than numbers dot size and I plus plus. And over here, what you can do is sum equals to sum plus numbers dot get I. Okay, and then you'll get the sum. So what it will do? Sum previously is 0. Now integer I starts from 0 to the last integer, the size. So basically it iterates through all the 3 elements, and it appends or adds the previous value of sum into the current value of numbers. Any confusion, anyone on this one? Sir, please run these program. Okay, let me run this then. How do you put the multi-liner comment, guys? You do this. No, Put this and this.
Let's have a quick quiz question, guys. And the question is, which data structure is used to implement a priority queue? And your options are stack, queue, heap, or linked list. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers full stack web developer course in collaboration with E&ICT Academy IIT Guwahati. Through this course, you can learn everything from front-end web development to back-end web development from esteemed IIT Guwahati faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of web development.
Okay, I'll have to import the library as well. Okay, I hope it works. If it doesn't, we'll try to fix it. But let's see. Okay. So you got the sum as 266, which is basically the sum of these three numbers. So we see the question is, write a Java code to remove all the occurrence of a specific element in the array list of strings. Okay, so there is something I'll be introducing you a term as well, using which you can do it in a better and a faster way. I just want to show you one more method to perform the same action. Okay, so first what are we doing over here is we are adding the elements to the array list. Let's say I added apple, banana, apple, cherry, apple. And then I want to remove all occurrence of apple. This is one way of doing it. Obviously, what you can do as well is, like most of the people have done it, you can again create an initiate a for loop with int equals to 0. And then I does contain work like, okay, I'll come to that. I less than words dot size. And then I plus plus. And over here, you can keep comparing, right? If, what do you say, words dot get I equals to apple, then words dot remove apple, right? This is the one way and it's a perfect way. No problem in that. It's just that I want to slowly introduce you guys towards building something which is much more coherent, much more understandable, and much more in towards the industry standards. Okay, so over here, what you see is in the while loop, what we are seeing is every time it checks if the word contains apple till the time word is containing an apple. This loop will keep getting executed. Okay, and whenever it touches a case where it's actually apple, you can just use words.remove.apple. I hope this is understandable, but in case in array list, you don't have remove all functionality. That is one. Second thing is, if you talk about this particular statement, words.contain apple pie. So I think the question was, this will give you a true result because apple is present, right? So even if a subset is present, it will return true, correct? But within that, we are trying to remove only the instance of apple. Okay, let's try to run this program. Yeah, so let's try to do that. I am printing words over here. Let's see if it works. If it doesn't, we'll try to fix it. Where is the symbol? Okay, so I need to put over here as colon. Okay, okay, cool. So fourth question we are going to skip because it's going to take us some reference of what do you call, collections. So we'll move to the last problem. Without even if condition, we can do this as well. Okay, that is something I actually missed while putting the code. Apologies for that. So basically, you are iterating through the words, right? And you're trying to just remove word if it contains apple. Okay, so without if condition also, it will do it. All right. So very simple. Double is something we are creating because we want to have a array list of doubles. And then we are adding numbers just as a bunch of numbers inside the numbers array list to find the maximum element. Okay. The ideal approach is to initiate max with the minimum possible value. Okay. And that is something you can do by using double dot min value. Now, min value is relevant not just in double, but also in float, also in integer, and also in any other data type as well, except string, obviously. But all the continuous data types, min value is present. So over here, by defining min value equals to max, what you're doing is you are making sure that max is set to the minimum possible value of the double, so that any number that comes, it can, this statement can execute efficiently. For loop, you can just create your own for loop the way you have been doing it. That doesn't create much of a difference. Okay, the way we have been doing it, so that's, I don't need to write it again. And if num is greater than max, over here num will be nothing but numbers I. If numbers I is greater than the maximum value is set to minimum value, right? So this can make sense. Now, some of you, what I've seen is at times, some of you defines max value as 0, right? But that is not going to work, because what if all the values are negative in your array list? Correct? Max value will give us 0, which is not even present in the array list. So that's not a right way to just create the max value as 0 or any other number. Try to have minimum value. Some of you have initiated max value with the first element of the array. Right now it might work because you are manually creating the array list and putting the numbers into it. But your logic should be valid even in cases of there are no numbers in the array. The array list is empty. Right? In that case, if you're trying to access the first element and assign value as max, that might fail because that array list is empty itself. Clear? Okay. All right. And similarly for minimum, you do double dot max value, so that any value that you compare will be definitely less than this value. Hence, you will be able to get the minimum value for this one. All right. All right. Coming to one thing, which was create a 2D array list. Okay. And I think I mentioned that you can do it, but there is a slight difference in the way you need to initiate it. And that is something I'm going to discuss with you now. Let me just put a bunch of code which I have written to showcase that part. Okay. Now we are going to initiate a 2D array list. Okay. Now see the difference how we are doing it. So this is the way we are creating a 2D array list. Okay. Let's break it down one by one. First thing is this line. This keyword is clear. We are just writing a variable name called 2D array list. And then right hand side, it's clear that we are using a module or a library of array list and initiating an object of array list. Okay. Now comes to the main part, which is this one. This defines what exactly is our variable all about. Over here, what you see is array list contains an array list, right? But instead of having strings and integer, you see an object. And that's the way you create a mixed data type 2D array list. Okay, using an object. How do we create 3D? 3D would be similar way, where you just copy this thing up. and then paste it inside the object this way. Okay, obviously you'll have to change the object which I'll go through, but initiation will be like this. Now, once you have done that, you have to manually put up the rows. Okay, you'll have to manually put up the rows and create the rows. Rows are nothing but the individual value of that 2D list. 2D list you can imagine as an example of, you know, this thing what we talked about, right? 1 2 array, what is this? 1 2 3 4. Okay, so over here what we have is, can't we add a row once yeah, so we are, what we are doing over here is, the first is the integer and second is a string. Okay, okay, and that's where over here what we are doing is, we are creating row 1, which is an array list of object using new array list, and then we are putting the values of that first row, and after that we are adding that row in the 2D array list. This 2D array list is not common, but this is not this is something you won't find commonly being used. Okay, so you don't have to stress about it. It's just that I wanted you to be aware about how do you create it. Okay, so this is about creating the row and creating first 2 rows, followed by accessing the elements. Now to access the element, you just have to append the get function twice, right? So integer element, if you're trying to access the integer part, you need to have integer data type, else string data type. Also, you need to typecast it because it's an object. It will return you as an object, and once you typecast it, you'll be able to get the original data type. Okay, and this is the way you're trying to you can access it. If you're trying to access the integer part of the 2D list, you have to typecast it with integer because it will return you as an object. Same goes with string. Okay, two get parameters, two get methods you'll have to append because it's a 2D part. The first one will be the row element, and the second will be the column element. Just imagine 2D one as a table, right? So row and the column is something what we have discussed. Okay, first way is, this is something I showed you, right? And it worked, correct? That we iterated from first element to the last element in the words. And if we found apple, we removed it, right? This works. I think there is no confusion on this one by anyone. Okay. One statement was, what if we remove the if statement, right? And it iterates from first element to the last. And in case, I mean, for every case, it tries to remove the apple. This will work as well. The reason being, it will iterate through 5 times. 3 out of 5 times, it will find words.apple over there and it will remove it. Okay. The question was, what if there are no apples in the code? Will this throw an error? Someone asked that. It will not throw an error because it just tries to remove the apple. It would not throw an error. Let me run this code as well. So it contains banana and cherry only, and we are trying to remove apple, and it did not throw an error. Okay, so this code will also work, that looping through and then removing apple. Now another response was, what if we remove the for loop itself and we just do remove words.remove apple? Okay, let me uncomment this first. Let's try to run this code. What did we get? Banana, apple, cherry, apple. It only removed the first occurrence. Banana, apple, cherry, apple. These are as it is. It only removed the first occurrence. Hence, it's important to have the for loop in place. Okay, so that it runs exact number of times as you have the elements in the array. Till this part, is it clear to everyone? solution won't work for continuous apple. Okay. So what we see over here is it's trying to remove apple and we still got 2 apples left. Yeah, that's a nice case. Can you reason it out, Tammy? I'll give you the speaking access. So here is the solution. You create the array list. You drop elements in the array list. Anyways, using for loop, you put the 1, 2, 3, 4 continuous things, or use in random, putting random integers like Kavya and few people have done it, right? And then you need to count 2 things: number of elements and their sum. How will you calculate the sum and the count? Using for loop approach. I hope by now you should be able to understand this approach. What we are doing is int num numbers. Basically, what does it do? Num takes the value of all the numbers one by one in the for loop. So let's say we have numbers equals to, for example, we have numbers equals to 1, 2, 3, 4, 4, anything like that. So num will keep on taking value of 1, 2, 3, 4 like that, right? So that's what this basically makes sense. I hope by now you should be able to understand that. And if it's a even integer, this is something we have already covered. If modulus of 2 is equal to 0, that basically means if you divide the number by 2, remainder comes out to be 0. That means it is even. You count it and also you include it in the sum. And using double, you get the average. So this is just a slight modification of finding the largest number. Over here, what we are doing is we are creating the array list, adding the elements in the array, and then instead of one variable, we are creating 2 variables. Okay, instead of creating one variable, we are creating 2 variables. The 2 variables are largest and second largest. Okay, and then same thing we are doing for loop where we are using num as a variable to iterate through all the numbers that we have in the array list. If num is greater than the largest, which will be always true for the first time, because largest is the minimum value of an integer. Okay, so if number is greater than the largest, second largest becomes largest, and largest becomes the number. Take your time to see the code and digest it. Only till this point. Clear to everyone? Else, if number is greater than the second largest, it can also happen that number lies between the largest and second largest, and number is less than the largest. Then second largest becomes number. Let me explain you guys with the help of an example. Why use and 2 times? Let's see. Let's assume we have these numbers. Okay. Or let's not put it in the sorted order. Let's put it in the unsorted order. Okay. So in this case, what are we supposed to return? We are supposed to return 7. And then second largest, we are supposed to return as 6. So basically, to the solution, we should be able to return 6. Correct? Okay. Now, largest and second largest are integer, minimum value of the integer. So this will be always way negative, the minus minimum integer value it can hold. And now we are iterating for loop from num to numbers. So basically, one by one, num will start taking the value of all these numbers. First time when if statement arises, num is greater than the largest. Num is 6. 6 is bigger than minimum value of the integer. So second largest will become largest. Let's keep changing over here is second. We'll keep updating over what is the value currently these guys holds. Just array. Okay, first time mein, these both were minimum value, but once the while loop has gone in, second largest is equal to largest. So value of second largest will be equal to largest, which is this, and largest will be num, which will be 6. Right? Clear? And next time, else statement it will go num greater than second largest is not true. Right? Num right now is 6 we have, and it is not greater than second largest. Okay, hold on, guys. If statement has executed, so else will not execute, right? Okay. Next time, when num goes to 4, 4 will be compared with the largest. 4 greater than 6, which is false. So it will go to else part. Now, 4 greater than second largest is integer minimum value, which is true, and 4 less than largest, which is also true. Then second largest will take the value of the number. This will become 4. Okay. Similarly, it will go on and it will give you the value of largest and second largest, right? We just saw these two cases, right? 6 and 4. Between these two, 6 is largest and 4 is second largest, and it was able to, the statements were able to collectively segregate them into largest and second largest, right? So that's how it works. Next time also, when 8 comes, largest will take the value of 8, second largest will take the value of 6. Okay, and so on.
Just a quick info, guys. Intellipaat offers full stack web developer course in collaboration with E&ICT Academy IIT Guwahati. Through this course, you can learn everything from front-end web development to back-end web development from esteemed IIT Guwahati faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of web development.
So let's continue. So the first topic that we're going to see is stacks. So first of all, let's just forget about computer science. We'll talk about a normal stack. Okay. So it's an English word, and what it actually means is, so stack is basically putting one thing on top of the other, right? So when we create a stack, it's simply let's create a stack of blocks. Okay. So these are our blocks. And if we put one on top of the other, this is called a stack, right? So let's say that these are books. Okay, this is book number 1, book number 2, book number 3, and book number 4. And this is the table that we are putting the books on. All right. So let's say we add a book number 5 to this particular stack. So where will it go? It will go on the top. Right? So whenever we add a new element, it will go on the top. That the latest element will go on the top of the stack, because the structure that we are following. That whenever we add a new element to it, it will go on the top. Very good. So this forms the basic of a stack. Whenever there is a new element, it goes on the top. So now we want to take a book out. Let's say we want to take out book number 2. Right? Let's say we want to take this book out. So how will we do it? Which will be the first book that you can pick? You can't straight away pick this one, right? Because the stack, all the books on top will fall down. So you can't just take away this one. So first element that will come out will be book number 5. So let's say we keep it on the side. Then we take out book number 1. And then now finally we can take out book number 2. Is this clear? If we have this stack, book number 5 is on the top, then we have book number 1, 2, 3, 4. If you want to take out book number 2, firstly we'll have to take out book number 5, then book number 1, and then book number 2. So our structure is such that we are keeping the books on top of one on top of the other, right? So if we have this particular structure and we want to take out book number 2, right? We're trying to take this book out, book number 2. So if we take out book number 2 straight away, book number 1 and book number 5 will fall down. So first book that we take out is book number 5, right? Then we take out book number 1, and now we can finally take out book number 2. Okay, so the new element that we have will go on the top, and if we want to take out any element, we have to start from the top. Okay, so this is the structure of a stack. We haven't done anything in computer science yet. This is a normal stack of books that we create at home. All right. So now one very interesting concept here is the last element that goes into the stack, or the last book that you have kept, will be on the top. And this will also be the first element that comes out of the stack. So the last element that goes in will be the first element that comes out. So if we write it like this, LIFO. So what does it mean? It means last in, first out. Last in, first out. So the last element that went in was the first element that came out. That a stack is a LIFO structure. It follows the LIFO approach. LIFO, last in, first out. So the thing that we have seen till now is a stack, and we have seen that the last element that goes in is the first element that comes out. So let us now see how we can code such a thing in computer science. Okay. So in computer science, we have, let's say, a memory, right? So these are some of the elements that are already in the stack. So there are basically 3 functionalities that we'll use. Let's say these are the elements, 5, 4, 3. Let's say we have some random elements here, 12, 13, and whatever. So if you want to look at the top number, whatever is at the top of the stack, we just want to know what is at the top. This is called peek functionality. Peek. What does it tell you? Top element. It doesn't remove the element, it just tells you the top element. So let's say this is our stack and we have a pointer at the top. We have a number, we have a pointer that has the address of the top of the of the stack. This is all the information that we have. So through this pointer, we can see the number that is stored here. It tells you the value of the top element. That's it. It doesn't remove it. It doesn't do anything, doesn't change anything. It only tells you what is at the top. The next functionality that we can have is pop. So as the name suggests, it removes the top element. Okay, it removes the top element from the stack. So if we call pop, what it does is it will remove this particular element, and our pointer A will now point to 12, because now 12 will become the top of the stack. So the third functionality that we have is the push functionality. All right. So third thing that we have is push. What it does is it adds an element to the top. Adds a new element. Okay. So here, if we push 15, what will happen is, if we have this stack now, so if we push 15, 15 will come at the top of the stack, and our top of the stack pointer, that is A, will now move to 15. Push, peek, pop. Type a yes or no so that I know. Is push clear to all of you? Okay, it's clear to Moshedal, Mona Lisa, good, and Surya Pratap. Excellent. And Emmanuel as well. Very good. So we have these 3 functionalities in a stack. So this is what this is the theory for stack. So we have a lot of functionalities where we use stacks. So where do we use stacks? Let's see. Okay. So in your computer, you must be opening a lot of different things at the same time. right? Let's say you open the PLC media player or window media player, right? You also open, let's say, Google Chrome, or maybe Edge or Internet Explorer, whatever you're using. You can also open, let's say, a game. You are playing a game, a video game, and you also open a calculator, right? So what happens is you have a single, let's say you have a single processor inside your computer. So the computer now has to juggle all these different applications. So the computer or the a single processor only processes one of the application at a time. It doesn't process all the applications together, but it does so fast that you feel like all of them are working together. So basically, it gives, let's say, 1 millisecond to the first application, then to the second, then to the third, then to the fourth one, and you don't realize because it is so fast that you can't perceive it. Right? It cannot be perceived with the human eye. The pause that is there, you can't see it because the clock cycle of a computer is so fast that it is doing the switching so fast, thousands of times within 1 second. So you are just not able to see it, but computer is only processing one application at a time. So for this functionality, many computers employ a stack. So whenever you open something, it creates a new element in this stack. Okay. Let's say this is our stack. So the first thing computer processes is the VLC player, let's say. Okay, it processes this and then removes it from the stack and adds it to a second stack. Okay, this is stack 1, this is stack 2. This gets removed from this one and gets added to second one. Then the top of the stack moves to Chrome. It executes Chrome and moves it to the other stack. Then it executes your game and moves it to the other stack. Then it executes the calculator and moves it to the other stack. Okay. Then it does the same for the second stack. Now it executes the calculator, moves it to the first stack. Then it executes game, moves it to the first stack, and so on for Chrome and VLC as well. So this is how it cycles through all the different processes that are open. Okay, so this is one use case for stacks. So now we'll see how we can code it in Java. So any programming language has a number of APIs or inbuilt libraries inside it. Okay, to make our lives easier. So we'll use one such library to code this particular stack. Let us see how we can do that. Okay. Yes, very good. Okay, so now we will try to code this. So I'm telling you we will use a library for this. Let us see how we can use that. Okay. So the first thing you need to do before you use a inbuilt library is import it into your own program. So you have to write a few lines so that you can import them. So stacks are inside the util package itself. Okay. So if you have imported java.util.star, that means you have imported everything that is inside the util package. If you want to import only the stack, you can write it like import java.util.stack. S capital. Okay. So you can use this line to import stacks into your program. And now you can use stacks. Let us see how we can do that. With this line, we have imported everything that is inside the util library. So we don't need to add the second line. Okay. So you straight away write stack. Be very careful and look at the syntax very carefully. Okay. So this is the type of stack that you want. What stack do you want? It can be an integer stack, string stack. You can create any stack that you want. Let's create a stack of all the animals. Okay. So new stack. So this is how we create our stack. So stack has been created. Right now it is empty. Okay, so now the first thing that we need to do is populate this particular stack. So we'll put elements into it. Let's try to put some elements. So this is the name of the stack. Then we use the keyword push. So we saw three functionalities: push, pop, and peek. So we'll try to use all of them one by one. So let us try to add dog into our stack. So we have added dog. Let us now try to add horse into it. Okay. Now we will add, let's say, cat. So we have three animals in our, So we have three animals in our stack. Is it clear to everyone? We have a dog, we have a horse, and we have a cat. Let us now print it. Okay. So it's very simple to print out your stack. So let's say you just write stack plus the name of the stack, animals. So this is how you print your stack. Let us try to run it and see what happens. So here you can see at the bottom, we have a stack with three animals in it: the dog, the horse, and the cat. Okay, so this is our stack. Now one very interesting question I'm going to ask you. Okay, you will have to tell the output of this particular thing. So we take a string, let's call it top element. Let's make it equal to element. Let's make it equal to the top element of the stack. System dot out dot print ln top element. Okay, so we are taking the peak into top element, the peak value into top element, and we are printing it out. Okay, so you can see the answer is cat. I'll just do one thing so that it's a bit more neat. Just rerun this. Okay, so you can see this is our stack, and at the top we have the cat. Very good, everyone. So you guys were correct, and I know that you guys are able to understand it really fast. So that is very good. So all the students have really good grasping power, and that is all we need, right? We don't have to cover a lot of ground, but whatever we cover, we have to be very sure that we understand every part of it. So now we can also search an element inside the stack. Let's try to search an element. Let's delete the peek function. Now we'll try to search a particular element. So int position equal to animals dot search. So for this, we'll use the search function. So which animal should we search for? Let's say we search for horse. Okay. Now we simply print it out. Okay, so we are printing the position. Let's just write a message so that it is more clear. Okay, so we are printing the position of the horse. So what would be the answer? Any guesses? Everyone? Any guesses? Okay, let's try to run this. Everyone is saying 1. So we'll just try to run this. So position of horse is 2. This is not an array, it is a stack. Here indices start from 1 only, not from 0. Okay. So at index 1, we have cat. Or let's try to find out the index of cat. Cat now. Let's run this. Okay, we have to type cat here as well so that it makes sense. Okay, so position of cat is 1. So cat is on the top, then we have the horse, and at the end we have the dog. right? This is what we saw in the diagram as well. We put one animal on top of the other. Okay. We have another function to check if the stack is empty or not. Okay, these are all the functions that you will frequently use while you are coding. Okay, so make sure you understand each of them. It is not very difficult. If there is any issue, do let me know. Let's move forward. So sometimes we need to check if the stack is empty or not. So let's take a boolean. Let's name it result. So basically the empty function will return a boolean, either true or false. That will tell us if the stack is empty or not. So let's print it. Is the stack empty? So this is our question. If the stack is empty or not. Now we'll print the result. So let us try to run this once. So here you can see that it is false. Why? Because we have these three elements inside our stack. So it is not empty. So this empty function will tell us that it is not empty. So it will return false. Okay. Let's move forward. Okay, so this was for stack. Now we'll move on to a new concept called queues. So let us try to understand what a queue is now. Queue. Okay, so let's see how a queue works. Okay, so it's a standard queue. Let's see what it means in English. So student 1, let's say, is the first one to stand inside our queue. Okay, to stand in the line. After this, we have student 2. So where will student 2 stand? The student will stand after student 1. So the students 2 will stand here. Then comes student 3. This student will stand after student 2. Then we have, let's say, student 4. Okay. So they are waiting for the bus to come. Let's say the bus has arrived. So who will be the first one to enter the bus? Student 1, 2, 3, or 4. If this is how they are standing in a line, so all of you basically think that S1 will get on the bus first. And that is correct. So S1 will get inside the bus. Then S2 will also get inside the bus. Then S3 and S4 and so on. Right? So in this, what is happening? The first student who was standing in the line was the first one to come out of the line and get inside the bus. So this is first in, first out. The first person to come will be the first person to go out. In stack, it was opposite. First person to come in will be the last person to go out. So last person to come in will be the first person to go out in stacks. So that was a LIFO approach. Like we just saw, I'll just show you again. So with stacks, we have the LIFO, but with queues, we have the FIFO. So FIFO means first in and first out as well. So let's take another example. So let's say there's an ice cream stall or a ticket stall, right? Tickets. And it is closed right now. It's not functional. Okay, so there's a huge line outside. Person 1 is the first one to come. Then person 2 comes, person 3 comes, and there's a very long line after that. Okay. Now suddenly the person responsible for the ticket counter comes back and the ticket counter is now open. So who will be the first person to be able to buy the ticket? P1 will be the first person to be able to buy this ticket because he's standing in the front of the queue. So if you remember, he was also the first person to come into the line. So first person to come in is also the first person to go out. So first of all, we'll cover the one functionality that is left in a stack. That was pop. All right. So animals dot pop. Then again, let's call it three times. Okay, let's call it thrice. So now what will be the output of this particular code? Let's try to run this. So you can see it has now become true. Why? We entered three animals into the stack and we have removed all of them one by one. So now it is now empty, right? Let's play around with these concepts a little bit so that we can get a better understanding of these. So let's pop an element. Let's push another element in. Animals dot push. So we'll go ahead with the tiger. We'll put tiger in. One more animal. Anyone? Just one more animal. We'll put another animal in. Okay, fox. Cool. So we have put the fox and the tiger inside our stack. Here let us try to output. System dot out dot print. Let's print animals dot peak. Okay, so now you will have to guess the output of these functions, like of this particular code. Okay, so we are printing only thrice. So there will be three outputs that I can tell you for sure. All right, so peak only gives one element that is at the top. All right, so let's try to run this and see if we have completely understood or not. So it's fox, tiger, and horse. Okay, I forgot to put a ln here. Let's try to print it again. So it's a fox, tiger, and horse. Let us try to understand how this happened. Okay, so that is important. Only the answers are not important. So initially we had the dog inside our stack. Then we put the horse on top of the dog. Then we put the cat on top of the horse. Okay. Then we removed one element. So the top element was cat. So cat got removed. Then we put tiger and fox. So now our stack would look something like, at the top we'll have fox. Then we'll have the tiger. Then we'll have the horse. And at the end we'll have the dog. Now we print the animal at the top, so fox gets printed. Then we pop the element. So we remove one more element. So here our fox gets removed. At the top we'll have tiger, then we'll have the horse, and then we'll have the dog. Then we'll again print the animal at the top. So tiger will get printed this time. Okay. So again we pop one element or remove the top element. So our stack would look something like this. The horse and the dog. Again we are printing the top, so horse gets printed. So it's fox, tiger, and horse. So we are all on the same page. We all now know what a stack is doing. Now we will try to understand what a queue can do. Okay. Then we'll play with the stack and the queue a little bit. We'll create a stack and we'll create a queue, and we'll see what we can do with both of them. Okay. So that we are very clear with the concepts. Create a queue, we need two things, a linked list and a queue. So for that, we'll need to import java.util.linked linked list, and we'll need to import java.util.queue. Queue. All right. So we'll understand the linked list right after queue. So don't worry about it right now. But because we have imported this particular line that says import java.util.star, that means we have imported everything that is inside the util package. So we do not have to import these two lines, right? Because we have already imported everything that we had like inside the util package. So we don't have to separately import linked list and queue. So we'll delete these lines, right? So now we'll create the queue. So the syntax is very close to stacks itself. You just write queue. You type what type of queue do you want. Let's say we need an integer queue. Let's name our queue queue. New linked list. This is how we declare our queue. Okay. So don't worry about the keyword linked list right now. We'll understand linked list in great depth right after we have completed stacks and queues. So this has created our queue. Let us try to add a few elements into it. Right. So for this we have the function add. What does add do? It adds an element to the queue. Okay. So let's queue dot add. Let's say 1. Queue dot add 2. Queue dot add 3. Queue dot add 4. Okay. Let us now print the entire queue. Queue. So we have 1, 2, 3, and 4 in it. So instead of push, we have add. Instead of pop, we have remove. Let us try to remove an element. Let's remove it here. So the answer is 2, 3, 4. So I'll again go to the whiteboard and I'll explain it, and then I'll explain what has happened. Firstly, we added 3 elements to our queue. So the first element was 1, then it was 2, then it was 3. Then we removed one element. So which element will get removed? That is what you have to keep in mind. This is not a stack. So the top element won't be removed. The first element will be removed. So 1 will be removed. Then we added 4. So the elements left in the queue would be 2, 3, and 4. And hence this is our answer. So one question that has been asked is, what if we remove an element before adding 2? So 1 will be added, then 1 will be removed, then 2, 3, and 4 will be added. So 2, 3, 4 will be the answer. Nothing very difficult here. We have 2, 3, 4. Very good, everyone. So we have add, we have seen remove. So now we'll study just one more function of the queue. One more function call that we usually do. Let's study 2 more, okay? Queue dot peak. All right. Let's try to run this. So the top element is 2. Why? We added 1, then we removed 1. Then we added 2, 3, and 4. So what is at the top? If it were a stack, 4 would have been on the top. But it is a queue, so 2 is on the top. Okay. So with peak function, we can easily see what is on the top of our queue. And if we are using a stack, then we can, with the same function, see what will be on the top of the stack as well. There's just one more function that we need to study. Then we'll try to play around with the queue and the stack. Okay. So we are removing twice here. size of the queue, queue dot size. Okay. So what would be the answer here? Let us try to run this. So the size is 2. Very good. So now we are clear with the queue and we are clear with the stack. So after this queue, I'll try to create a stack. Let's make it of type string only. This also, let's make it of type string. All right. Okay, so here we are. So we have a queue and we have a stack. Let's add some elements into the queue. Okay, so these are strings now. Okay, sorry. Let's try to print it, run it. Okay, so the answer is dog and elephant. Okay, so first of all, in the code, what we were doing was we were adding a cat to the stack. So we have a stack, okay, and we have a queue. So we were adding a cat, dog, and elephant. So it went like cat, dog, and elephant. Right? In the stack, the elements will go one on top of the other. Right? Like this. Okay, so we are firstly adding elements into the stack. No, sorry, we are firstly adding elements into the queue, not the stack. So this stack remains empty. So it's cat, dog, and elephant. So inside the queue, first animal is cat, dog, and elephant. So we have these three animals lined up like this. Now we are pushing into the stack the very first element of the queue, and then we delete that element. So into the stack, we push the first element of the queue. So the animal at the front of the queue, that is the cat, will move to the stack. Okay, so it will go to the stack. So cat would come here. Then we are removing the element from we are removing the top element from the queue. So this gets removed. After this, we are again doing the same thing, moving the topmost element of the queue to the stack. So on top of cat, we get the dog. Then we are removing this element from the queue. Now at the end, we are printing the top of the stack and the queue. In what order are we doing it? We firstly print the top of the stack, then of the queue. So top of the stack is the dog, and top of the queue is the element. Yeah, because coding is simple. Logic building is the main problem. Most of the students, what they'll do is when they try to learn coding or start coding, they'll straight away jump to the coding screens, the coding competitions. They won't build up their algorithms or the basics, right? And that is where they'll lose out on uh, basic theories that will help them code. So let us now take two stacks only. Okay. So let's delete this queue for now. We'll take two stacks. Both of them will be of integer type. Another stack of type integer. This is S1. This is S2. Okay. The output for this. Tell me the output for this. We are not using stack 2 for now. So firstly, we are putting 0, then 1, then 2, then 3, then 4. We are stopping at 4. Okay. So what would be at the top? The last element that has been added, and that is 4. We'll run it. We'll use a while loop now. While s1 dot. So s1 dot empty not equal to. So let's just do it like this. While not s1 dot empty, let's push the elements into s2. s2 dot push it. It is getting a lot more tricky as we move forward. So you have to be very careful that you understand the concepts. Right? Only after that you answer the questions. All right, let's try to run this. Okay. So what we did now was we created two stacks. One we named S1, the other we named S2. In S1 we added numbers from 0 to 4. So firstly 0 was added, 1 was added, 2 was added, 3 was added, and 4 was added. Then we started emptying S1 and added these elements into S2. So what we did was we transferred the top element to S2 and we removed the top element. So 4 came here. We kept doing it again and again. 3 got deleted, 3 came here. Then 2 got deleted, moved here. So 2 came here. Then 1 got deleted and moved. So 1 came on this side. Finally, 0 was also removed and deleted. So this is stack 2. Then we displayed the top element in stack 2. So this was our output. So the trick to become a good coder is not knowing a lot of concepts vaguely, but a few concepts with extreme clarity. So very good. We have done this much. Now I'll do something else. So let's put another while loop here, not s2 dot empty. Okay. So s1 dot push, s2 dot peak, s2 dot pop. All right. So the concept that I was introducing here was very simple. We have two stacks. One stack, we are emptying one stack and putting it into the other stack. So we don't make a copy. We make an inverted stack here. If it is 1, 2, 3, 4, we make a 4, 3, 2, 1. So what we did here was we inverted the stack twice. Right. So 1, 2, 3, 4, 4, 3, 2, 1, and then again 1, 2, 3, 4. So we got the original stack back. So the top would again be 0. Right. Very good. So now let us play with the stack and the queue. So stacks, I think, are completely clear to all of you. Now we'll go for the queues. Right. So we have a stack and a queue now. Let us put some numbers into the queue. Okay, name of the queue is Q1, not Q. We'll put I here. All right, let's try to run this. So the answer is 0. So we'll use a while loop now. Or we'll just use another for loop, no issues. I equal to 0, y less than 5, I plus plus. So from this queue, we'll add the elements to the stack. So in S1, we push Q1 dot peak, Q1 dot pop. Sorry, it's a queue. So we're removing, push and removing, and then y s y. For now, let's keep it to this much. So 4 is the answer. So in this code, what we did was, I'll just quickly recheck. So we added elements 0, 1, 2, 3, 4 into the queue. Then we one by one added those elements to the stack, and we then printed the top of the stack. Okay. So it's nothing very difficult. We had a queue and we had a stack. So in the queue, we added 0, 1, 2, 3, and 4. Then we moved them to stack one by one. So when 0 went to the stack and got deleted from the queue, it got to the bottom. Then 1 went over there, then it's 1. Same thing happened with 2, 3, and 4, right? 2 went there, 3 went there, 4 went there, and they all got deleted from the queue. Then we printed the top of the stack, that is 4. And you all understood the concept very clearly. So 4 was the answer that you all have given. So we'll change the code just a little bit and see how that changes our output. So we'll do a while s1 dot empty, we put not here, while this is not empty, we'll just print s1 dot peak. So here we'll get a error. Why? Because this is an infinite loop. So you missed out this thing. Only Akshay caught it. We are not removing the elements of the stack, so stack will never be empty. It will keep printing the same number over and over again. So at the top of the stack, we have 4. It will keep printing 4. So you can see that it is just printing 4. I just have to stop it. So s1 dot, let's pop this time. Right. Now what would be the answer? Manual 43210, Moshadul 43210, Mona Lisa also 43210. Let's print it. Let's run this code. So it's 43210. So we'll move forward and see and play a little bit more with these things. Let's make another queue. Integer type only. Q2. Okay. All right. So we have our queue ready here. So firstly we add to the queue, then we put to the stack. Now we put into the queue. Let's go in the queue too. Pops. Okay. Okay, so let us run this. So the answer is what happen if we copy one queue to another queue. Okay, so let's remove the stacks. We don't need the stacks anymore. Q2 dot add Q1 dot peak, removing, and okay, be very careful. We have done a similar code with the stack where we created one stack, copied it into the other stack. So there the stack got inverted. What will happen here? So let's see what happens. Firstly, let's print out the answer. Okay. So it's clear what the answer is. So it's 0, 1, 2, 3, 4. So here we have two queues, Q1 and Q2. Okay. So we added some numbers in Q1. So firstly we put 0, then 1, then 2, then 3, then 4. Then we removed elements one by one from Q1 and added them to Q2. So firstly we take 0, we add to Q2. Then we take 1, we add to Q2. 2 moves, 3 moves, and 4 moves. So you can see that Q1 and Q2 are identical. They are not inverted. It is the same. Okay, so these are our answers. So in case of stack, when we copied elements from one stack to another, the elements got inverted. In case of queues, when the elements are copied from one queue to another, the queue remains the same. So we have till now understood clearly two interactions. When one queue is copied to another queue, when one stack is copied to another stack. Let us see what happens when they interact with each other. Okay. So let's say we have a queue and we have a, let's delete the code first. Let's create a stack here. All right. So let us add some elements in this. Okay, so we have added some elements into the queue. We have added some elements into the stack. Now we're adding some elements from the queue to the stack. At the end, we are adding some elements from the stack to the queue. Okay, so this is a very tricky question. If you guys get this one correct, it will mean that all the concepts of stacks and queues are completely clear to you all. So here what we'll do at the end is we'll simply print the stack, then we'll print the queue. If you simply print the stack, it will be printed in the opposite. Like if the stack is 3 to 1, it will print like this. It will be printed 1 to 3. So let's print the stack the way we were doing. Okay, so here we are printing the stack and here we are printing the queue. So this is our code. So the answer is for the stack, it is 98765. Okay, 98765. For the queue, it is 23410. So first of all, what we did was we created the queue and the stack. In the queue, we added numbers from 0 to 4. So let's create the queue. So we have a queue and we have a stack. So in the queue, we added numbers in the range 0 to 4. So it goes 0, 1, 2, 3, and 4. In the stack, we added numbers from 5 to 9. So stack goes like 5, 6, 7, 8, 9. Okay, after that, what we did was we went from 0 to 1 in a loop and we pushed two numbers from the queue to the stack. Okay, from the queue to the stack, two numbers. Right, from the queue to the stack. So 0 went to the queue, 0 went to the stack and 1 went to the stack. So first 0 went here, then 1 went here. Okay. After this, we again ran a loop we ran a loop twice and added two numbers from the stack to the queue. Two numbers from the stack to the queue. So 1 actually goes back to the queue. So in the queue, it will get added to the end and will get removed from the stack. Then 0 goes to the queue and gets added to the end. And that is it. This is all we did. Then we printed the stack. So stack will be 9, 8, 7, 6, 5. Then we printed the queue. Queue would be 2, 3, 4, 1, 0. So we'll just add a space here so that it's more clear. So Mushaddal's answer is also here. 43210 is the queue and 86420 is the stack. Okay. All right. So let us try to print this now. Okay, Mona Lisa's answer is also here. 0864 243 Okay, let's print this. So 86420 and 43210. The stack is 86420 and the queue is 43210. It won't take much long, don't worry. We'll try to quickly wrap it up, right? But we'll have to actually go a little deeper into this concept because it's a bit more tricky and a bit more important than the concepts we have covered till now. So what, first of all, let's try to understand what a linked list is. Okay. So linked list is very similar to what its name suggests. I'll just share my screen and try to explain to you what a linked list is. So a linked list is a list that is linked together. Okay. So basically, we have these small blocks. These blocks basically contain two things. Firstly, the value that we have to store, that we want to store, let's say it contains a 5. The second part contains address of the next block. Basically, this block contains address of this block. In the next block as well, we have something similar, the value and the address to the next block. Again, we have something similar, and the last link has a null pointer at the very end. Null simply means pointing to nothing. Okay, so it won't make a lot of sense right at the beginning. As we try to code, it will make a little more sense. Okay, so what was happening in an array? We were allocating the memory that we need all at once, right? Statically, all at once. This means statically. So let's say at the beginning of the code, we don't know how big of an array do we want. We can't make it very small, because what if we make an array of size 10, but we want an array of size 15? So we take a large array. Let's say we take an array of size 100. Okay. But the values that we want to store are only, let's say, 20. So how much space is wasted? 80 blocks are unfilled. This is for an array. Is this understandable? What I've just explained about the arrays is this much understandable, that we have to declare the size of the array right at the beginning. So in case we don't know what the size should be, we have to declare a very large array, and that can result in space wastage. So if we declare an array of size, let's take a very small example of size, let's say 5, 1, 2, 3, 4, and 5. And we store only two values, 1 and 2. So these spaces that are left, so this is our array. Now we'll move on to linked list. So the first thing that you should understand about any new data structure is, why do we want that? So this is exactly the reason. This wastage is the reason why we want the linked list. In linked list, we allocate memory one by one. Here we were going for all at once approach for the array. For the linked list, we are going for one by one approach, or the dynamic memory allocation. So we start with a single element. Okay, we start with a single element and we store our value there. Whenever we need more space, like we have to store another number, we'll create one more element and we'll link these two together and put the second number there. Let's say we need we need more space, we need to store one more element. That's cool, we can do that as well. Okay, and we'll make this point to this one. The last one will point to, again, null. Okay, null just means nothing, pointing to nothing. Okay, nothing. So in this, we don't have to allocate all the memory right in the beginning. We are allocating it one by one. So we are not wasting any memory. We needed space for 3 values and we created space for 3 values only. So this is dynamic memory allocation. Just write the word here. It's called memory allocation. Okay, memory allocation. Arrays. may cause wastage. Linked list, no wastage. Very good. So this much is clear to us that array can cause wastage, but in linked list we are causing no wastage. We are allocating the memory when we need the memory. In arrays, we are allocating the memory right in the beginning. Very good. In linked list, we have to traverse it linearly. One more concept, one very important concept. Linear, traversal. Okay. We have linear traversal in the linked list. Now we'll try to understand this part. While we have random access in arrays. Now we'll try to very carefully understand what I've said, because only these 2 points are important. Wastage, no wastage, we have understood. Now linear access and random access. First we'll go for the array. So this is how arrays are stored, right? In the memory. Here we have a number. Let's say its address is 0. Here we have another number, its address is 1. Here we have another number, its address is 2. 20 is at 3. Okay. Now let us say we want to access this particular element. We want to access 15. How can we do it? We have stored the starting address of the array. So 0 is the starting address. We want to access something at index 2. We'll add that to 0. At address 2, we will find our element. We don't really have to access 5, then go to 10, then go to 15. We can straight away do this calculation and go to 2. This much is clear to all of you? Random access, is it clear? Right? If we want to go to the 1000th element, for 2 element it may seem very useless. If you want to go to the 1000th element, we don't have to traverse 0 to 1, 1 to 2, 2 to 3, moving forward, and then go to thousands. We can simply do 0 plus 1 0 0 0 get to 1 0 0 0. 1000th element. Okay, at this address we can straight away go and access the element, whatever value is there. Okay, now it should be very clear what is random access. It is saving our time. If we want to access the 1000th element, we are not traversing like one by one, 0 to 1, 1 to 2, 2 to 3, 3 to 4. We're not going like that. We are straight away moving to the 1000th element. Now we'll go for linked list. Okay, so as we saw in the linked list, now I'll create a linked list. So this has random access. Arrays have random access. Now we'll go for the linked list. Let me draw one linked list. Okay. So the first element is at address 0. Second element is at address 10. Third element is at address 21. First element will give you the address of the second element. Okay. So we can come here. Second element will give you the address of the third element. So we can come here. Now if we want to access the third element, okay, so can we do this? 0 plus 2, this is the 0th element, first element and second element. Okay, we want to access the second element. Can we do this? Is this the address of the second element? Yes or no? So we can't simply calculate the address of the element now. We have to go one by one. Okay, first we get here, we get address 10. So we jump to address 10. Then we get this 21 address, then we jump to address 21. And this is how we get to our second element. Imagine there are 1,000 elements. Now we have to go linearly. Firstly to address 0, then to the next address, then to the next address, and we have to do this 1,000 times. Is it time taking? Yes or no? More time taking? Yes. So even for the CPU or the computer, it is more time taking. So I'll just quickly summarize what we have done about arrays and linked list. Okay, very important. Try to understand this. Arrays. Okay. May waste space, but there is an advantage also. Otherwise, we would never use arrays, right? If there is something that has all the disadvantages only, we will not use that concept. But arrays is being used, so there should be a advantage also. Advantage is random access. Okay, so this is a disadvantage, this is an advantage. Now linked list. One, no space wastage. Okay, why is there a space wastage? Static memory allocation. Right in the beginning, we have to say how much space we need. Why no space wastage? Dynamic memory allocation. Right. Second point is now there is an advantage, but there is also a disadvantage. Disadvantage is linear access. So we are talking about ROM and RAM. Yeah, so you can say that. Correct. In a way, we are. But ROM and RAM are hardware concepts, right? In those, we do use linear access and random access. We are only talking about the software concepts for now. Okay, they are being implemented in hardware as well, but right now we're talking about the software aspect of it. Okay, so linear access. So no space wastage is advantage. Linear access is disadvantage. So now we know why we have to create a linked list, right? Or why we have to create an array. Okay, so this is the most important thing, because even linked list, we are just going to import one library and our linked list will be created. No issues in that. Now, one question I have. Okay, we'll see some very interesting questions here on the board itself. Okay, so we won't involve code for now. Firstly, we'll do the theory. Okay, just theoretically, if this is our linked list, this is how it looks. I've already explained what this structure is. This is null. How do we find the midpoint of a linked list? While declaring an array, we give the size as well, right? So for this array, we give size 4. So there won't be a midpoint because size is 4. Let's say size is 5. Okay. Let's say this is the array. While creating the array, we give the size 5. So we automatically know that the midpoint would be 5 upon 2. This is equal to 2, right? floor function. So 5 upon 2 basically is equal to 2.5. So the greatest integer before 2.5, greatest integer less than or equal to 2.5, that is 2. So this is the floor function. Greatest integer before or equal to the particular number inside the floor function. Okay, so this is 2. So this is the midpoint. How do we calculate the address of the midpoint? Starting address plus 2, 2. We have found the midpoint. So is it clear that finding the midpoint of an array is very easy? Move to the next element, count equals 3. Move to the next element, count equals 4. Move to the next element, count equals 5. Next element is null, so we don't count it. Now we know that there are 5 elements. Is this much clear to everyone that we can count the 5 elements like this? How many elements are there in the linked list? We can count it by traversing. Is this much clear? Yes or no? Yes? Very good. So we have counted how many elements are there. Now we can use the floor function. 5 upon 2 floor, that is 2. Now again start from here and move 2 spaces forward. Because this is 2, we move 2 spaces forward. We move forward once, we start from here, we move forward once, we get here, we move forward again, we get here. This is the mid element. Very easy approach. Count number of elements, divide that by 2, start from the beginning again, move that many spaces. Yes, we have found the middle element. Now, what if I tell you that there is a very interesting way of doing it? Very interesting. So we have a race track. Okay. This is our race track. This is the ending line. This is the starting line. So this is basically the start and this is basically the end. Now there are two people standing here, person 1 and person 2. Okay, so we can't iterate from both ends, Saurabh. One thing very important, Saurabh is saying that we can iterate from both ends. If we are here, we can't go back. There is no pointer to the previous element. We only have a pointer to the next element. We can't go back in a linked list. Okay. So coming back to what I was saying, this is the start point, this is the end point. There is person 1, there is person 2. Person 1 is running at, let's say, 20 kilometers per hour. Now I know this is not a realistic speed, but let's say this person is running at 20 kilometers per hour. And person 2 may be running at 10 kilometers per hour. So one very interesting question I'm going to ask you, when person 1 reaches the end, where will person 2 be? Where will person 2 reach? When person 1 reaches the end, where will person 2 be? Half, right? Half of the track. Person 2 will be exactly at midpoint.
Let's have a quick quiz question, guys. And the question is, which data structure allows efficient retrieval, insertion, and deletion of elements in logarithmic time? And your options are linked list, array, binary tree, or balanced binary search tree. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers full stack web developer course in collaboration with E&ICT Academy IIT Guwahati. Through this course, you can learn everything from front-end web development to back-end web development from esteemed IIT Guwahati faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of web development.
Okay, so we'll use something like we'll use this exact concept. Okay, so what we'll do is I'll again make a small linked list and I'll explain what we have just done. right? So this will be like, I find it very interesting. We have used a completely real world problem solving technique and put it into code. This is our linked list. We'll put two iterators. Two iterators. One iterator will move two steps forward, and one iterator will move one step forward. This is called fast, and this person is called slow. Fast will move two steps forward, one and two. Slow will move one step forward. Fast will again move two steps forward. Slow will move one step forward. Now fast cannot go any further because this is null. So wherever slow is, that is our answer. Okay, fast, I just mean that fast pointer is going two steps forward and slow pointer is going one step forward. So we're just calling this guy fast. Is this jump by two? Yeah, so one by one it is going two steps forward while slow is going one step forward only at one time. Okay. Okay, so if fast moves one space and then gets the address from here and moves another space. Slow gets the address from here and moves one space only. So addresses will have to be contiguously followed. You can't take a two jump. I mean, fast can't directly reach here. It will move one space forward, get the new address, then move the second space. Is it clear now, Saurabh? Okay, very good. So this is how you find the midpoint in a linked list. Clear? Now, another very interesting concept I would like to introduce in the linked list. This much is clear, right? Everyone type yes or no if this much of linked list and array is clear. Because this is the basic of linked list. This has to be clear before we move forward. Okay. Okay. Again. So let's say we have a linked list. And because we have made some error, this has resulted in a loop. I'll just show you how. Okay. This guy is pointing here, 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 and this guy is pointing here. Let's take imaginary values 1, 2, 3, 4, 5. Let's take addresses 0, 10, 20, 16, 18. This guy is pointing to 10, this is pointing to 20, this guy is pointing to 16, this guy is pointing to 18, and this guy again is pointing to 20. Now we have the pointer here. Now we have to find out, okay, listen very carefully what we have to find out. We have to find out whether or not there is a loop in the linked list. If we try to iterate to the end, what will happen? Our pointer will go here, 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 move back to this place, move forward, move back to this place, move forward, and we will never find the null pointer, right? So now we have to find out if there is a loop or not. How do we find it? We do not know the size of the linked list. So we can't say that we go 10 spaces forward. If we do not find a null, then there is a loop. The linked list might be of 15 size, right? There may be 15 elements. Let's say we have a park, okay, that has a loop. We have a circular path. Yeah, this is how the racing tracks are, right? They're circular normally. So we have this circular path. This is the starting point. And then we have a straight path. Okay, and this is the starting point. So there are two people standing at the beginning, person 1, person 2, person 1, person 2. Now person 2 is moving at 20 kilometers per hour again. Person 1 is moving at 10 kilometers per hour. Same is going on here. Person 2 is moving at 20 and person 1 is moving at 10 kilometers per hour. So if it is a straight line, will they ever meet each other? If let's say it is a very long straight line, will they ever meet each other? No, right? No? No. If it is a circular park, will they meet each other? Yes? Yes? Okay. So we'll use this concept now. Okay. We'll use this very small, simple concept. We'll take two pointers. We'll name this fast. Sorry. We'll name this fast. We'll name this slow. Fast will move 2 steps. Slow will move 1 step. So fast goes here and here. Slow goes here. Fast goes here and here. Slow goes here. Fast will go here and here. And slow will come here. They will both meet here. This is the point where slow and fast will meet. If they ever meet, we have a cycle. If they do not meet and fast reaches null pointer, then there is no cycle. If fast reaches null pointer, no cycle. If fast reaches slow pointer, there is a cycle. If I write this statement, like for fast pointer, we have two options. Null, it reaches null or the end, no cycle. Second, it reaches the slow pointer, then there is a cycle. Is this thing clear to everyone? Does this make sense to you guys? Yes? Yes? So was this interesting? Again, we have used a real life concept and put it into our code. Interesting, right? Yes? Very good. Very good. So we have understood how to find a cycle in a linked list. Okay? With the help of racing tracks. Good.
Let's say we have an array and the array is not sorted. It has random numbers in it. Okay. And we have to search for an element, let's say 5. So we just take a pointer to the first number in the array. We check if it is equal to 5 or not. Okay. So it's not equal to 5. We move forward. Then we check if 2 is equal to 5 or not. It is not equal to 5. We move forward. So we have found 5. These are the indices of the array. So we have to return 2 because 5 is on index 2. So this is our answer. So now let's see a larger array and just look at the concept once again. Let's say we have 23, 46, 2, -8, 10. Okay. And let's say I want to find if 12 is there or not. Okay. So what I'll do is I'll put a pointer to the first element. This is not equal to 12. I'll move the pointer forward. It is not equal to 12. I'll keep moving forward until I find 12 or I reach the end of the array. 2 is not equal to 12. 8 is not equal to 12. 10 is not equal to 12 and we have reached the end of the array. If we haven't found the answer, we just return -1. Okay. -1 signifies that we haven't found the number that was being searched for. Okay. There's 0, 1, 2 index, 3 index, and 4 index. So we return a -1 here. This is the most basic type of searching. If the array is not sorted, it will work. Okay. So there are two things that after discussing the next algorithm, we'll discuss two things, two parameters. Okay. So the next type of searching is called the binary search. Let us have a look at that. And then we'll compare these two algorithms in terms of time complexity and in terms of in how many cases we can run this particular algorithm. The next thing is binary search. Okay. So let's see what a binary search is. So when we have to find a particular, let's say, word in the dictionary. Now I know most of you wouldn't have used a dictionary recently because we simply Google the meaning of the words if we want to. But if imagine you're using a dictionary, how do you find a particular word? So dictionary is arranged in an ascending order, right? So if we have, let's say, three words in the dictionary: cat, like dog, cat, and let's say rat. Okay, these are the three words that we have in our dictionary. Okay, so in what order would they be placed? They will be placed alphabetically. So firstly, we'll compare the first letters. So C is the smallest letter. So cat goes first. T is the second smallest letter. R is the largest. So this is how the dictionary would be arranged, right? So if the dictionary is of 1,000 pages, so what we can do is we can open a random page in between, let's say page number 500. We have to find, let's say, dog. Okay. So on page 500, let's say we have words starting with P. So we have to go backward or we have to go forward. On page 500, we have words with which start with P letter. We have to go forward or backward? Backwards. Very good. So you'll see that our dog would be in the range 0 to 500 now. So earlier we had the range 0 to 1000. Then we checked page number 500 and found letter P as the starting letter. So our range suddenly became 0 to 500. We have eliminated 500 pages through one search. 500 pages have been eliminated. That is 501 to 1000. That we have eliminated 500 pages and now our search space has been reduced to half of what it was. Next, let's say we go to page number 250 and find that we have words starting with F. So is dog in 0 to 250 or 250 to 500? Backward, or like we have divided this into two parts: 0 to 250 and 250 to 500. Where do we find dog? We have words starting with letter F, we go backwards. So again, we have reduced our search area to half, right? We have eliminated 250 pages this time. Now we go to page 125. Okay. So here, let's say we have words starting with letter C, right? We have words starting with letter C. So where do we search now? What is our remaining search space? So we have these page numbers with us because 0 to 125 will contain letters A, B, and C, right? So we don't want that. So again, our search space is broken down into half, right? If we continue like this, if we keep on going like this, do you think we'll find dog? Keep eliminating half the range every time. And we know for sure that dog would exist in the dictionary. We'll be able to find it, right? So this type of search is called binary search. Okay, so let's take an example that we were taking earlier and try to see if binary search can be applied there or not. So let's take this as example 1, 2, 5, 3 and -2. Okay. So we'll take the example 1, 2, 5, 3 and -2. So 0, 1, 2, 3 and 4. Okay. So we need to find 3, let's say. So what is the first index that we look at? So basically, we'll put a pointer here and we'll put a pointer here. So we'll just see why it can't be applied. Okay. So we'll put a pointer at the beginning of the range and the end of the range. Okay. Of the range that we are considering. So then we'll add index beginning and index end. So that is basically 0 plus 4 divided by 2. This gives us 2. So we'll search here. This is equal to 5, right? So this is our midpoint. This is the beginning, this is the end, and this is the midpoint. At the midpoint, we have 5, but the array is not sorted. We don't know where 3 will lie. 3 can lie here, and 3 can lie here as well. So we can't divide the range into 2 if it is an unsorted array. So what we found on a particular page was sufficient to tell us whether to search in the next half or the previous half, right? Very good. So it's clear to all of you. It's clear to Emmanuel as well, right? Cool. Cool. So we'll see an example where this will work. We'll take a sorted array. Okay. So let's try to find minus 5. We will try to find minus 5 here. Let's see if we are able to do that with this particular approach or not. We'll put the beginning pointer here, end pointer at 40. Okay. Then we'll find the midpoint. Midpoint is beginning plus end upon 2. Right? So this is 0, 1, 2, 3, 4, and 5. So this is the midpoint. So midpoint has 0. So we compare the number that is to be searched for, let's call it k, and the number at midpoint. Let's name the array ARR k. If this is less than, if the number at midpoint is less than k, if it is less than k, we make end equal to mid minus 1, right? So now if the number to be searched is less than 0, we will now search only in this particular range. So we'll search in this particular range now, right? So let's move forward. So now we'll again find a new mid. Okay, so mid will change because beginning and ending have changed. We'll use this formula once again, and our mid will become 0 plus 1 by 2, right? So 0 plus 1 by 2 is equal to 0 itself. Right? We are dealing with integers, so this will be equal to 0 itself. Yeah, is it clear? We'll find a new mid and we'll put the mid pointer there. Now again we'll try to search for minus 5. Now if array of m is greater than k, sorry, last time our array was greater, right? So we had a 0 there, and 0 is greater than minus 5. So this was the case. So we make the end equal to m minus 1. Now if our array index m, so the element as index m is less than k. If it is less than k, then what do we do? We make the beginning equal to mid plus 1. So if our element on this particular index m is smaller than the number that we are searching for, we take the beginning and transfer it to m plus 1. We make it equal to m plus 1. Okay. Then we calculate the new mid. So now we'll again use this particular formula, and our new mid will be 1 plus 1 by 2. This will be 2 by 2 or 1. Now the third and final condition that we have to create, array of m equal to k. Just return index M. Right? So we have successfully found out our number that was to be searched. So just a second. Yeah, we'll take an example 5, 10, 15, 20, 25. Okay, so we have these numbers with us. And let's say we have to find this number 10. We are searching for 10. The algorithm that we are using is this is the beginning, this is the end. Basically, beginning is equal to 0, end is equal to length of the array minus 1, right? So there are just 3 rules that we have to follow. Rule number 1, if array of M is less than K, right? So what do we do? If the midpoint, if the value at midpoint is less than K, so the number would be in the next half, second half. So in this case, we'll make beginning equal to M plus 1. So we'll just apply these rules in this example and see, okay? Don't worry. You don't have to memorize anything. It will become very obvious. If array of M is greater than K, if the element at index M is greater than the number to be searched for, then we make end equal to M minus 1. Okay, mid minus 1. Third case, if array of M is equal to K, we return the midpoint. So let's apply these rules, okay? So firstly, we'll calculate a midpoint. We have beginning, mid, and end. Beginning is equal to 0. Let's write the indices. Okay. Beginning equal to 0, end equal to 4. So the value of M would be 2, correct? So we'll search here. So is 15 less than K, or 15 is greater than K, or 15 is equal to K? Less than, greater than, or equal to? Like case 1, 2, or 3. All right, so this is case number 2. Why? Because 15 is greater than 10. So we make end equal to M minus 1. So we take this M, we take this E, and make it equal to M minus 1. So end now becomes 1. Beginning is 0. What is the new mid? We use the floor function. So 0 plus 1 by 2 is not equal to 1, it is equal to 0. Right? So mid becomes 0. Okay. So we take the mid and put it at 0. Now which case is it? 1, 2, or 3? 5 is less than 10, greater than 10, or equal to 10. Third case. Third case, is 5 equal to 10? Yes, it is the first case because 5 is less than 10. So 5 is less than 10, so it is the first case. So what do we do in the first case? We make beginning equal to M plus 1. So we delete this beginning part and make it equal to M plus 1. Right? So beginning becomes 0, end becomes 0. What is the value of mid now? So 1 plus 1 upon 2 is equal to 1. Okay, so it is 1. Now mid also becomes 1. So now which case is it? So it is the third case, and we return the value of M. So we return 1. So is 10 at index 1? So we have found out the index where 10 was. So there are two things that we have to compare, okay? So the first thing we did was called as linear search. Okay, we were linearly going from the left end to the right end, one by one, and checking if the number is equal to the number that has to be searched for. As simple as that, the most basic type of search. Second thing we did was binary search. So the first point that we have to look at is, can be applied on any array. Here, binary search can only be applied to sorted arrays. Second, time complexity is O of n. We are traversing the whole array, so time comes O of n, right? Okay, so this is called a log n time complexity. Why is it a log n time complexity? Log base 2. Basically, we are every time discarding half the numbers. So in how much time we can discard all the numbers? In the first case, we are discarding half. Again, half of what is left, right? So if we say, let's say we have 8 numbers. In the first go, we discard 4 numbers. In the second go, we discard 2 numbers. In the last, we discard 1 number, right? So it is like a power of 2. So if it is 2 to the power 3, we're discarding all the numbers in 3 goes. If it is 2 to the power 10, we're discarding all the numbers in 10 go, right? So if it is 1024, next time we'll have 512 numbers, then we have 256 numbers, then 128 numbers, 64, 32, 16, 8, 4, 2, and 1. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In 10 times, we can discard all the elements in the array. So this is called the binary search. So we have understood the concept of linear search. We have understood the concept of binary search. Now we will try to code it once, okay? So that we are very certain that we have completely understood it. Okay. So the first thing that we'll code is the linear search, okay? Simple. So let's take an array. Okay, we are taking an array. Let's put some random numbers into it. Okay, let's also put some negative numbers into it. Okay, let's search for 7. Okay, so we'll just loop through the array once. Okay, so while looping through the array, we check if ARR of I is equal to the number that we want to search. If it is equal, we'll simply print out that index and we return. So return basically closes the code. So when we have found the index, we'll just print that and return. Okay. If we come out of this for loop, we just print cannot, or we just print -1. Okay. Let's say -1 is code for not being able to find a particular number. So when we haven't found any number, it will print -1. If we have actually found the particular number, we will print that index and close the code, right? So let us run this. So 7 is at index 5. So index 0, 1, 2, 3, 4, 5. Okay, so the question is just find one of the indices where that particular number is. Okay, we are considering arrays with all different numbers right now. So that won't be a problem. So now let us take a number that is not in the array. Let's rerun this code. So we can see it has printed -1 because the 0 is not in the array that we have considered. Okay, so very good. So this is the code for linear search. So the next thing that we'll do is called the binary search. Yeah, we'll see the code for binary search now. Let's try to create a code for that. So we'll delete this code. Now we'll make code for binary search. Okay, so first of all, we'll take an array. Now the array has to be sorted, otherwise we can't take it, right? So 2, 4, 6, 8, 10, 12, 14. Okay, let's take a few negative numbers as well. 6, 4, -2, 0. All right, let's search for 4. So now what we'll do is we'll take 3 integers like we took in the algorithm. One will be called the beginning. It will start from 0. E will start from length minus 1 and mid. Okay. This is what we were doing in the while we were running it on the whiteboard as well, right? We were taking these 3 integers. Now, for how long do we actually run this particular loop? We use a while loop here. Now we run it till beginning is less than end. Okay. While beginning is less than end, we have a range. If beginning is greater than end, we don't have a range, right? If we are talking about a range, beginning needs to be less than end. Only then we'll have a range to consider. If beginning is greater than end, then we don't have a range to consider. Now we'll calculate the midpoint like we were doing. We'll use the same formula here. Begin plus end upon. Okay, so we have calculated the value of m. Now what do we do with this m? We create the 3 test cases that we like, 3 possibilities we considered, right? And else. So the first possibility was array. Sorry, what is the name of our array? ARR, small. Okay. Array of midpoint is less than k. Array of midpoint is greater than k. Right. So when it is less than k, what do we do? When array of m is less than k, what do we do? And equal to m plus 1. If our starting number is -6, ending is 14, midpoint is on 4, and we have to search for -2. Sorry, we have to search for 10. What do? We make the beginning equal to m plus 1. The previous half is discarded, right? So we make the beginning equal to mid plus 1. Now, if array of m is greater than k, what do we do? If the current element that we are looking at is greater than the number that we have to search, so the next part, the latter part, is discarded. So e becomes m minus 1. So now we'll make the e equal to m minus 1. Great. Okay. Now, if it is not less than k, if it is not greater than k, else will mean that it is equal to k. So we'll return the value of m. Okay, so basically this is a void function. So we'll print the value of m and return. If we come out of this loop, that means that we were not able to find that particular number, and we'll print a -1. Okay, so if you think this code will work, type work. If you think there is a mistake, type it won't work. All right, if b is equal to e, what happens is midpoint is also equal to like b or e. Then if it is not equal, then either b becomes e plus 1 or e becomes b minus 1 and the code closes. So like we saw in the example as well, if b actually becomes equal to e, then midpoint is also equal to them. Then if the number is there, then that point is returned. Okay, cool. So let's just run this. So 4 is at index 5. So this is index 0, 1, 2, 3, 4, and 5. Okay, let's search some other number. Let's search for 10. We have 10 here. We have 10 at index 8. Okay. Let's search for a number that is not there. Let's search for -100. So we have got -1. That means -100 is not in the array. Okay, so this is the binary search, right? Let us now see a few use cases where we use binary search. Okay, so let's say we have a sorted array with repeating numbers. Okay, So let's say our array looks something like this. 2, 3, 4, 4, 4, 5, 6, 7, 8. Okay. So how do we find the first occurrence of a particular number? Let's say we have to find the first occurrence of a particular number. If we are giving 4, we want to find this index. 0, 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So we want to return 2 specifically. We don't want to return 3 or 4. We have to return 2. How do we do that? It is very similar to binary search. I mean, just 1 or 2 changes here and there and we'll get there. That we do a normal binary search until we find one of the 4s. Okay. So one, we put the beginning here, we put the end here. What would be the value of mid? Beginning plus end by 2. 0 plus 8 by 2. 4. Right. So at index 4, we have a 4. Now, after we have found any of the 4s, we do a linear search backwards. We go back linearly. Is this equal to 4? Yes. Is this equal to 4? Yes. Is this equal to 4? No. So this was the first 4 in the array. So we return 2. So the problem is the time complexity for this approach is also O of n. Why? Let's say we have an array with all 2s. Right. So in this case, let's say this is the midpoint. After that, we'll have to go for n by 2 elements backwards. Right. So the time complexity is O of n. So it would be better if we do a simple linear search instead. Right. It would be simpler to code. Search here. Is it a 4? No. Go here. Is it a 4? No. This is a 4. So obviously this is the first 4. So return index 2. Right. A normal linear search and this binary plus linear search has the same time complexity, have the same worst case time complexity. All right. So now I'll tell the approach. Okay. So let's take an example. 2, 2, 2, 3, 3, 4, 4, 4, 5, 5, 6. Okay. Now let us search. Let's search for 3. So let's write the indices. 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. So let's give the values of beginning, mid, and end. Beginning is 0, end is 10. So this is our mid. Now mid is basically array of mid is basically greater than k. What do we do in this case? We make e equal to m minus 1. Right? So e now becomes 4. Beginning stays at 0. Mid becomes What is the value of mid now? Updated value 2. Very good. This becomes 2. This is mid. Okay. So now array of mid is basically equal to 2, and that is less than k. In this case, we make b equal to m plus 1. Okay. So b equal to m plus 1. What is the new value of b? So b becomes 3, e becomes 4. What is the value of mid now? 3 plus 4 by 2 is also equal to 3. Okay. So mid becomes 3. So now we check. Now we see that it is equal to our value k. But now we don't return m straight away. What we do is we check if array of m minus 1 is also equal to k, we make e equal to m minus 1. Else we return m. So basically, in this case, we couldn't actually apply this thing. So let's take a very small but other example, right? Where we can actually apply this algorithm. Second, just scroll down. Like 2, 2, 2, 3, 3, 3. 0, 1, 2, 3, 4, and 5. Beginning, end, and we are searching for 2 here, okay? So 0 plus 5 by 2 is actually 2. So this array of k, array of m is equal to k. So we check if array of m minus 1 is equal to k or not. So this is also equal to 2, right? So we make end equal to m minus 1. So end comes here. Now we again calculate m. Now m is equal to 0, right? 0 plus 1 by 2. Now m is again equal to k because m minus 1 does not exist anymore because m is equal to 0. So you can't do a m minus 1. So now we return 0. When m was equal to k, array of m was equal to k, we did not return it simply. We again check the previous index. I'll just take the pencil again. Beginning, end. What is the value of mid? Beginning plus end by 2. 0 plus 5 by 2. Now array. Now this is the case. This is the case, right? Array of m is equal to k. What do we do? If array of m minus 1 is equal to k, then we do e equal to m minus 1. If array of m minus 1 is equal to k, yes, it is equal to k, we do e equal to m minus 1. So e comes here. Now again, what is the new value of m? Beginning plus end by 2, 0 plus 1 by 2, so it is 0. Now array of k is again equal to k, right? Now m minus 1 does not exist. It doesn't exist. There is nothing at index minus 1. So we simply return m. So we return 0 here. All right. So let's try to code this algorithm now. So we have to find the first index in an array with repeating numbers. Let us take the array first. Okay. So let's take an array 2, 2, 2, 4, 4, 4, 6, 6, 6, 6, 8, 8. we'll go for 6. Now we'll take the 3 integers. Beginning, end, beginning equal to 0, end equal to array dot length minus 1 and mid. How long do we run this loop? While beginning is less than ending. Now we calculate our mid, p plus e by 2. Okay, this is how we work. Sorry, this is comma. This is how we were calculating our mid, right? So this is same as binary search. Till now we are doing everything same to binary search. Exactly same. Till now everything is exactly same. Now again we'll create the 3 cases, right? Because that much is also same. We'll just change a few things in the else. Nothing very difficult. Okay. Now array of m is less than k. So b is equal to m plus 1. Okay. Great. Now if array of m is greater than k, e equal to m minus 1. Awesome. Now in else, we have already seen the pseudo code. Now if m is equal to 0, if m is the starting, if m minus 1 doesn't exist, we simply print m. Okay, and return. Otherwise, if array of m minus 1 is also equal to k, else if it is not, m minus 1 is not equal to k, then we simply print m and return. If we have come out of this particular for loop, while loop, where does it end? It ends here. We print minus 1. Now let us try to run this particular code. So the answer is 6. 0, 1, 2, 3, 4, 5, 6. So the first 6 is by chance at index 6. Let's try to search for 4. Okay. So 4 is at index 3. 0 index, 1 index, 2 index, and 3 index. Let's try to search for 7 because 7 is not there. Minus 1, so 7 is not there. The code is running, right? So these are the only 2 types of searching that we have. Okay, there's a linear search, there's a binary search. Linear search can be applied to any array, whether sorted or unsorted, but it takes a little more time, that is O of n. Binary search has a limitation that it can only be applied to sorted arrays, but it is giving you a better time complexity of O of log base to n. All right, and we also saw why we are doing this log base to n, because every time we are removing half the numbers. Okay. So now the next thing that we have to learn is, so basically searching is done. Searching is over. Next thing that we have to learn is called sorting. Okay, so the next thing that we want to look at is sorting. Let's take an array. Okay, let's put numbers into it randomly. So how will you sort it? So the most basic approach that comes to our mind if we are actually sorting these things is we create another space, like an empty space. Okay, we take the smallest number. We check which is the smallest number. We remove that number from here, add it here. We again check what is the smallest number. We take it out of here, put it here. Again, we do the same thing. We keep doing it repeatedly. 6, 8, and 10. Is this how you'll do it? In normal life, this is how we'll do it if we don't have a computer. Take the smallest number, put it here. Second smallest number, put it here, and so on. So the problem is, how much time did it take? So basically, there are n numbers. And to find the smallest number, we have to traverse the whole array. So to find the minimum number, we take O of n time, right? And we have to do this n time because once we traverse the array, we are only able to place one number in the correct position. So n into n will become O of n square. That this is a O of n square approach. Yes. So this is very high time complexity. Another problem, space. We have created another array. So space complexity is also O of n. The size of the array is n. So space complexity is also O of n. So time and space complexities are high in this. Let us study one algorithm. So basically, okay, so I'll explain that with an example. We have a bucket of water. Okay, it is completely filled with water. All right, let's make the water in blue color. We have very pure water. It's completely blue. Okay, let's say there are two bubbles. We make two bubbles. One is a big bubble, other is a small bubble. This is big bubble, this is small bubble. So buoyancy basically means that the upward force generated is directly proportional to the volume of water displaced. Okay, upward thrust is directly proportional to water displaced. B is displacing more water, so there would be more upward thrust for this bubble. Okay, so this will reach the surface before S. B will reach the surface before S. So now I have also taught you buoyancy, right? This is also a physics class now. So this is called as bubble sort. Why is it called a bubble sort? I'll show you. If we have water in a beaker and there are different sizes of bubbles. Let's take 4 bubbles. Size is 4, 3, 2, and 1. So after some time, when bubble number 4 reaches the top, okay, when bubble number 4 reaches the top, so each bubble will create a different thrust because their sizes are different. When bubble number 4 reaches the top, bubble number 3 would be somewhere here, 2 would be somewhere here, and 1 would be somewhere here. If we take this snapshot, if we take a picture of this thing, is it sorted? Did it get automatically sorted? Yes. What we'll do is let's take an array. 2, 3, 4. Sorry, I'm taking a. Let's take an unsorted array. 4, 2, 3, 1, 5, 0. Okay. So now what we'll do is we'll take 2 pointers. Okay. So now if 4 is greater than 2, 4 and 2 will be swapped. If this is pointer A, this is pointer B. If number at pointer A is greater than number at pointer B, swap their values. Otherwise, do nothing. So if A is greater than B, swap the value. So this becomes 2, this becomes 4. So basically, bubble number A was larger than bubble number 2. So it has come to the top. Next, we move A and B by one number. Basically, we move them one place forward. So I'll again take the pencil. A, B. Now again, if A is greater than B, A comes forward, B go like we swap A and B. So we again swap. This becomes 4, this becomes 3. Now we move A and B one step forward. This becomes A, this becomes B. Now 4 is greater than 1, right? 4 is greater than 1. So we'll again swap. This becomes 4, this becomes 1. Now we again move A and B forward. So we don't do anything, we just move A and B forward, we do not swap. So this becomes A, this becomes B. Is 5 greater than 0? Yes. So now these get swapped. So after one iteration, the last number, the largest bubble, is at the correct position. I'll repeat this sentence. After one iteration, the largest bubble comes at the top. The largest bubble has reached the surface. The rest of the array is not yet sorted, but the largest bubble has reached the surface. One bubble we have taken to the top. So after the first iteration, the array has become something like this: 2, 3, 4, sorry, 2, 3, 1, 4, 0, and 5. Now we will again do the same thing, and the second largest bubble will reach the top. I'll just show you. This is A, this is B. Do we swap? We don't swap. A, B. Yes, we swap. 1, 3. A and B, do we swap? No, we don't swap. No swapping. A and B, do we swap? Yes, we will have to swap. So I'll swap these. We'll end this here. Why? Because the last number is already in the correct position. So we'll just end it here. We won't move forward. Okay, we'll simply end it here. So now you can see that the second last bubble is also in the correct position. So we have to do these iterations n times, because every time one bubble gets at the correct place. And the time complexity for one iteration is n. The time complexity for this approach comes out to be O of n squared. So now one type of question that we solve with this is, let's say we have a very large array, 2, 6, 3, 1, -8, 10, 100, whatever. If we have to find the, listen to it very carefully. If we have to find the fifth largest element in this array, fifth largest element, run it only 5 times. So this is the most optimized way of finding the nth largest number. Okay. So if we want to find the fifth largest number, we run this algorithm 5 times, and from the back, we take the 1, 2, 3, 4, fifth element, whatever will be here after 5 iterations, that will be the fifth largest element. So this is what your bubble sort is basically for. Okay. So we have seen two types of searching, and we have seen one type of sorting.
Just a quick info, guys. Intellipaat offers full stack web developer course in collaboration with E&ICT Academy, IIT Guwahati. Through this course, you can learn everything from front-end web development to back-end web development from esteemed IIT Guwahati faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of web development.
So let's start with arrays. And our question is, given an integer array nums, move all the zeros to the end of it while maintaining the relative order of non-zero elements. So guys, this is a very interesting question. So let us see how to solve this question. So suppose we have an input array called nums, and we have this number something as 0, 1, 0, 3 and 12 are the elements. So how the output we are expecting is something like this. So 1, 3 and 12 are coming at the front and all the zeros are shifted at the right end. So let us consider an array such as, suppose we have an array, say array name is nums, okay, and we have this much number of elements 0, 1, 3, 0, 12. Okay, so what kind of output we are expecting here is that all the zeros like this one and this one should be shifted at the right end. So our answer will become something like this. So this is our required output. One other case you can think of something like this. If nums is this kind of an array, so we have elements all over here, such as you can say all the zeros are at the left end only, and we have the elements such as 1, 2 and 3. So our output would become something like this: 1, 2 and 3, 0 and 0. So guys, you would have got a clarity that what is expected in this question. So you have to move the zeros at the end of it while maintaining the relative order of the elements. Okay. You can pause the video right now and think of an approach that how you are going to approach this problem and solve the existing problem. Okay, so this can be your first approach. You can think something like this. So suppose we have this array nums and I put the elements such as 0, 1, 3, 0 and 12. Okay. So what can we do all over here? That we can create a vector. Okay guys, so we can create a vector, okay, name as duplicate. And what we're gonna do is that we're gonna insert the elements 1, 3 and 12 by iterating, over the entire array and leaving the zeros behind. What you can do, we can create a vector and put all the elements in this vector called duplicate, which are non-zero elements. Okay, so this is the first approach. So here the number of elements is n, okay, and suppose in our duplicate we get m elements. Okay, so what we will do, so suppose in our vector duplicate we got this element as 1, 3 and 12. Okay, so if we find out the relative difference between these two, so if we go for finding relative difference between the vector duplicate and this array called nums, so we are going to get what are the difference of elements is missed by duplicate, and we can insert all those elements. So suppose if I say 1, 3 and 12, so suppose we have nums has number of elements nums has is around 1, 2, 3, 4, 5, okay, and our vector duplicate has around 3 elements. Okay, so what is the difference here? So nums minus duplicate equals to 5 minus 3 equals to 2. So means we are missed by 2 zeros. So we can insert 2 zeros in this duplicate vector. So this becomes our answer. So guys, I hope so you could have found out this approach. It's a pretty simpler one, but the problem is in the question asked, the question stated that you have to move the elements at the end of it. Okay, so we are performing our operations using some other array or a vector, which is kind of not required. It is actually not expected. The interviewer could say you, please try a different approach. I don't want you to take any duplicate array. I want you, all the operations or your approach should just involve using one array. So how we can solve this problem by just using one array? You can pause the video guys and then think of a very good approach or any approach which solves the problem. I'm going to take certain approaches and tell you that how we are approaching. The only thing to be understood right now here is guys, how we are trying to solve this problem. What is our approach? We will see at the end of it when we have found out a solution that how is the right way to approach a given problem. So there is a note for you guys in the above approach why I am discarding that, So actually what we did was we took an extra space actually, which was like order of n. So which is kind of not an optimized approach. So whenever you are sitting up for an interview, when your interviewer is going to ask you certain questions, so when he says that this approach is not optimized, so you have to find out a solution how you can optimize your algorithm or the way of your approach to solve the problem. So that was that in the above scenario, our approach or our was not optimized. So let me give you another approach in which we will be trying to solve the problem. So guys, what our approach can be something like this. Consider this as our first, the red marker which is all over here is a first zeroth element. And this orange one is our first non-zero element. Okay, just remember these markers. So what I'm going to do, something like this, I'm going to construct our array and I'm going to swap these first 0 and first non-zero elements. Okay, so our array would become something like this. This is after first operation 0, 0, 3, 12. Now we are going to place our pointers. So our first 0 right now comes here and our first non-zero element is around here. Okay, so after swapping, because remember we have to swap first non-zero. Remember, we have to swap first zeroth and second non-zeroth element. Pretty much fine. Okay. So after this operation, our array would become something like this. Okay. 1, 3, 0. So we have to find out our first zeroth element. The first zeroth element is all over here. Okay. And there is one more 0 which I missed it out. Okay, I'm going to add it up. Okay. So our first 0 element is all over here and after first non-zero element is all around here. So what we are going to do, we're going to swap them. Okay, so our array would become something like this. 1, 3, 12, 0, 0. We have found a solution, but in this we are taking 2 pointers. And guys, I would say this is pretty complex approach. You would be also feeling how we are going to create 2 pointers and this swapping operation. The approach is correct. There is no doubt about it. You could go with this approach and code it up if you are able to. But I would suggest that the coding can be a little bit, complex for beginners. So this approach could be avoided. But if you want to go with this approach, this is also pretty much fine. Okay. So I would suggest that, let's try to find out some other easier way to solve this problem. You can pause a video and you could think about some other approach. So guys, I hope so. You would have thought about something. So here's another approach which is pretty efficient and pretty interesting. Okay, it's a very amazing approach which I would always recommend to use it in these types of questions. So suppose we have an array and I would say I'm saying iterating from I equals to 0 to I equals to n. Okay. So here we have an array called nums and I am putting 2 counters, that is I and j. Okay. I would say that I is somewhere around the first non-zeroth element. Okay. This is I and j I would initialize as the first element. Okay. So we are traveling from I equals to 1 to n basically. Okay. So here is our array called nums and this is the element 0, 1, 0, 3, 12. Okay. We are initializing all over here. I equals to 1. Okay. And j equals to 0. Okay. The first non-zeroth element basically where it is present. Okay. Now what we are going to try to do all over here is that whenever, okay. So whenever we are finding the first non-zeroth element, so we are going to replace the value of the ith index to the jth index and we are going to increment the j. Something like this, guys. So at the first step would be something like this. So here is our first non-zeroth element and here is our, the counter of j. Okay. So we found our first non-zeroth element. So I'm going to replace it by 1. 1, 0, 3, 12. Okay. This was our step number 2. Then again, we increment the counter. So our counter I becomes here and j becomes here. Okay. Since it's encountered a 0th element, so we are going to do nothing and we are going to just increment the I at this stage. Okay. Increment the I. So at the second step, our array would be still the same. 1, 0, 3, 12. Okay. Our ij is still at this position, but our I will be at this position. Okay. Now, since we have encountered a non-zeroth element, so we're going to replace it all over here. 1, 3, 0, 3, 12. And our j position would be shifted to all over here. And I would be at the end of the array. Okay. So basically I has traveled from at this distance to the end of the array. Okay. So what we are going to do is still we are finding the non-zeroth element. So I'm going to replace this with this element. Okay. And increment the j. So our array would become something like this: 1, 3, 12, 3, 12. Since I has completed its iteration, okay, I will be here and j would be incremented. Okay. So we can find out right now that we have almost traversed, or we have moved the elements all around from 1, 3, 12, and j is at this position. Okay. So when we have traveled, when I has traversed the entire array, so what's the value of j's are left means j at index, what the index of j is left. Okay. So here it is like 1, 2, 0, 1, 2, 3, 4. Okay. So j equals to 3 all over here to j equals to 4. We're going to fill these elements a of j and a of j plus 1, okay, with zeros. Basically, since there are two elements only left, so I'm just giving you an example that a of j plus 1, or the leftover elements like this and this, since we have to traverse till here. So we're going to fill these elements with 0. So our array would become something like this. So our answer would go something like this. At our final stage, it will be 1, 3, 12, and 0, 0. This is a pretty optimized approach, and I hope so. Like some of you would have thought about it. Okay. If you have prior solved this question, it's very good. It's kind of revision for you. But this is actually one of our approach which actually I wanted to discuss. So we went on to 3 approaches. Okay. See, we are not arriving at our solution. So whenever we are facing any new question, we are not expected to instantly, write the most optimized code. Your approach should involve hit and trial method. Okay. This is the one thing which you have to learn it. So basically you learn by hit and trial. Okay. So first you're going to do wrong, or you approach some easier way. Then you will think, okay, how to optimize this, or how to add the element, then how to add some flavor to your approaches. And then at the end of the day, after too much of trials, you get to solve the question. So now it's time for us to write the code and see how we are writing the code for the same. So guys, here is a code and you could try to hit on your systems. So it will be something like this. So we have found our code and we are going to try to write the code in a language. Language you could choose like C++, Java, but I'm choosing actually C++. So it is my personal recommendation that for solving data structures, you could go for Java or C++. So this code is written in C++. Okay, so what the first thing we have to do? So we have to move the zeros at the end of it. So let's just create a function. Okay, so our function is void move zeros. And in this, I'm going to pass 2 parameters. Okay, the first one is a vector and second one is the array. Okay, so I'll say vector int and nums. So I'm going to basically initialize the size of the array. Okay, so how we can do it? So there's a very good way. You could just declare a variable and put it nums.size. Okay, so that's a one good approach. So there's int n equals to nums.size. Then I initialize j. Okay, so int j equals to 0. Now let's traverse the array. Okay, so I'll start with the for loop. For int I equals to 0, int I less than n, and I'm incrementing it with I++. Okay, so if nums of I is not equals to 0, so I'm telling it a condition that here, that if the element we have encountered like in the earlier is not equal to 0, it's a non-zeroth element basically. So what I'm going to do right now, I am going to replace it with the element at the index j position. So nums of j equals to nums of I. Basically, I'm assigning the position. So, and then later on, I'm incrementing you can say the position of jth. Okay. or incrementing the jth. That would be right to say. Then I'm closing the loops. Okay. Next thing what we are doing all over here is, then what we are saying that when for till then, suppose j has reached till, say there was 3 and 12 left in the element, and 1 3, there was also 12. So j was at here. So we're going to start from the jth position where jth has entered till then. So for here again for loop, because I want to change the values, to zeros. So for j, so just this you could do, and j less than n. Okay. And I would say j plus plus, and I'm going to say all the position which are left out after I has traversed entire array. So I'm going to put it to 0. The nums of j equals to 0. Hence it solves our problem. Okay. And this is the complete optimized code. Okay. So let's look at the code once again. So for our better understanding, so let us find out the first thing what we did all over here is that first we tried approach. Okay, we got an approach in our mind, and we also figured it out. It is a kind of an optimized approach. Okay, so what we did was that first, in order to solve that approach, we are going to first create our function which is going to solve our problem. So here what I say is our function is the first thing we created. Okay, coding is nothing, guys. The language is just a kind of a language to interpret about your thoughts, what you want to do. Okay, we created an array, we pass out the parameters. Okay, it's very important for you to pass an array. Okay, and this is the size of the array. Here we are calculating, and I've initialized already that here j will be here, here I will be here. So I've initialized j equals to 0 because j should be starting at the first index, which is at the 0th position. Then I am traversing entire array. Okay, so for traversing, what we are doing here, guys, we are applying the for loop. Now here is a conditionals. Okay, because we had a condition in our approach that if we come across the non-zeroth element, basically, which is written all over here, what we're going to do, we're going to assign the value of the jth index, nums of j equals to nums of I. Okay, and we are incrementing it with j plus plus. Okay, got it? And then what we are doing is basically the leftover j's, just put all these values to 0. Pretty simple code, guys. It is not a complex code, but that approach earlier, which I told you about putting 2 pointers and going again and again, so that could have been a little bit complex, but see, this approach is pretty much consistent. So guys, I would have thought like this is a pretty easy approach, and you would have understood how we approached a problem. So we are not learning here how to solve arrays question. So that should not be our agenda. Our agenda for today's session should be like how we are approaching a problem to solve it. Because believe me, when you're going to sit for the FANG companies or any good MNC, they're going to ask you questions and which will be pretty new to you. So, and you cannot learn all those questions, you cannot solve a lot of questions, and it just does not works out. You cannot learn a code. So my only advice to you should be, guys, that first start with pen and paper, try to solve it, and come out up with some approach. Try to find out what flaws it has. Is it taking extra space, or its time complexity has increased? So with that thing in mind, always write an optimized code. So guys, I hope so you would have understood how to move the zeros at the end of it. Now let's move to the next question. So our next question is of sorting. Okay, this is also a pretty interesting question, and we are definitely gonna learn something interesting and something new. So if I read the question, it says, given an infinite stream of integers, find the kth largest element at any point of time. We have a note here that we have a stream instead of a whole array, and we are only allowed to store only kth element. Suppose if someone asks you find the kth largest element, okay, so you would have some output and some input. So let me just explain to you what kind of input will be there and what kind of output we are expecting. Okay, so k is any parameter, you can consider it, k equals to 2, k equals to 3, and at the kth position. Okay, for that problem the k is not going to change, and if someone inputs the value of k, so your output for that stream of integers, the kth largest element, should always be, coming out, you should always produce those output. As for something, I would like to tell you that this is not an array. This is infinite stream of integers. So how you can expect this as a problem? Suppose there is a data stream which is coming to you. Okay, consider a number of data. So each time a data gets added up in your array. So that is kind of an infinite stream of integer. Let us solve the problem and let's see what kind of approach do we have. Okay, so guys, like in this whole problem, what it is trying to say is, suppose these are the operations. Okay, so for every kth largest, when we are asking, there is an add operation going on. So this is our initial array. Okay, and we are adding these elements. Okay, so basically what we are doing is, let me show you. Okay, so suppose this is our array. Okay, and I'm saying that suppose in the input section I'm putting k equals to 3, and we have all our array as 4, 5, 8 and 2. Okay, so I'm asking which is the kth largest, which is the third largest element. Okay, so the third largest in this, as you can see, the highest one is 8, next one is 5, and the third one is the fourth. So we have to return 4. Okay, similarly, if we had added one element called 3, okay, so 4, 5, 8, 2, 3. So which is the third largest again. For every kth largest operation, we are adding one element. Okay, so here one element is added, like suppose here 3 is added. Now we are asking which is the third largest again. So the first largest is 8, second one is 5, and still our third largest comes out to be 4. So I'll be just putting something like this. So the answer, what we are returning, so it's step 2, we return something like this. In the third step, one element again gets added. Okay, let's say it's 5, and our size of the array has increased. Okay, now if I'm asking which is the third largest, okay, so it's 5, then 5, then 8, then 4. Okay, so third largest most precisely in this, if we are not considering the duplicate elements. Okay, if we are even counting the duplicate elements, so there is no uniqueness, so our third largest would come out to be a 5. It could be either one of them. Okay, so that's one thing. Okay, so in this way we are expecting to solve the problem. Okay, so let me just give you an pictorial view. Okay, I hope so you would have got a brief idea about this problem. So let me show you one approach how you can solve this problem. That one is called min heap approach. Okay, let us create a minimum heap and store these elements, and we could pop out the element maintaining the relative order of the heap. So how you're going to maintain the heap? The size of the heap, okay, should always be equals to k. Okay, this one is pretty interesting question. So guys, please be with me. Okay, so now let's come up here and add the first element. Here is 4. Okay, since we are not satisfying the size of k, so we are going to add one more element, that is 5. Okay, 5 gets added here. Then we are adding the third element like 4, 5 and 8. Okay, now at this position we are satisfying our, you can say, somewhat the kth largest scene. Okay, we can find out, since our k is 3 here, so we can say we can find out the third largest because we have the 3 elements all over here. Okay, so what is our third largest element? It's 4. Okay, let's see this. Now let's go on to the next stage. Okay, for every kth largest, okay, we say we add one element. So here one element is added, that's called 2. So let's add it up. Okay, since we are just ending our array. So you can see all over here that the size of the heap is not maintained. Size is not equals to the value of k. Okay, this is a scene here. So what we're gonna do, we are gonna pop the topmost element. Okay, in order to maintain the relative size. So here we get 4, 5, 8. Okay, so our element returned as a kth largest is 4th. Okay, now let's add another element called 3. Okay, so here 3 is added, so our heap size is increased. It is not stable, so we're gonna pop the topmost element. So here this element, we're gonna pop it up. Okay, so after popping it up, our size of the heap becomes consistent. Okay, so we can say the kth largest element here in this case return here is 4th. We are returning the topmost element, and at the same time we are popping up the topmost element in order to maintain the relative size of the heap. Okay, then we add up one more element called 5, 4, 5, 8, 5. Okay, so in this case, what we are going to do, we are going to pop the topmost element in order to maintain the relative size. Okay, so now this gets popped up. Okay, so we can see here in this case, now the value of the kth largest element is changed, and our in this case, the kth largest element is 5. So we are adding the element and our kth largest element is changing. So the value of k is consistent throughout the problem. So here our heap is 558. We add one more element, that's 10. Here 10 gets added up. Okay. Okay. We have added 10. Now the size of the heap is changed and we have popped out the topmost element. Okay. Here's a pop operation. So after popping up, our heap becomes 5, 8, 10. Okay. So what we are going to do, we are going to return the topmost element. So now again at this position, we are adding one more element, okay, that is called 9, okay. So I'll perform an operation, add 9, okay. So our size of the heap is not consistent here. So we are going to pop up the topmost element. So our heap becomes 8, 9, 10. Now it says we have to add 4, okay. So suppose we are adding one more element 4 here, but you should skip this because the answer would be same, okay. 8, 9, 10 because if I create another picture, say here 8. Let's have a quick quiz question, guys. And the question is, which algorithm is used to find the minimum spanning tree in a connected weighted graph? And your options are breadth first search, depth first search, Prim's algorithm, or Kruskal's algorithm. 9 and here is 10. And here you say one more element comes up 4. So, but ultimately in order to maintain the relative size, we will pop up this. So, which is pretty much not expected, okay. So you can skip this up. So this was all the problem, and this was one of the approach how you can solve the problem for infinite stream of integers. Okay, suppose a data stream is coming up consistently, okay, that's a hit populating your array, okay, but every time you are asking the question, to your function that please return me the kth largest, and kth value is not changing throughout. You can fix k equals to 5, k equals to 4, k equals to 3. But once you have fixed it up, your value of k is not changing for that input. Okay. So let us delve into the code and let's see how we can solve this problem. Okay, guys. So this is the code. Okay. So let us inspect this code and let's see how well it fits in our approach. Okay. As said, we are going to create a priority queue named PQ. And there are certain number of parameters I have taken like int, vector int, and g int. Okay. Let's see the entire logic inside this function, what basically I'm doing. So I've set a variable, this is a global variable, so I've set it equals to k, okay. So basically k is equals to the kth largest element, okay. And I'm trying to, traverse inside this array called norms, okay, filling this element. If pq.size is less than k, okay, so there is a one condition which I'm putting up, this is a very important condition, okay. So suppose if the size of our heap, okay, say it was 4 and 5 and our k equals to 3. So if PQ, if the priority key or the size of this heap is less than this, then only we have to push an element called x here. Okay. This code says something like this. Else if there's second condition which says if PQ.size equals to k, okay, and also x is greater than PQ.top. Okay. This is second condition, which means that, so in the last scenario, what we found out that we had this 8, 9, and 10. Okay. This code demonstrates that scenario. It says that the size is equal to 3. Okay. Our heap is maintained, but x should be greater than the topmost element. Otherwise, it's no point of pushing that element. Okay. We will be wasting the time, performing the same add operation, because if we add 4 here, so what's the point on returning the kth largest? Our kth largest is not changing. So when our kth largest is not changing, we have to also give a condition here that if the element added should be greater than the top element, then only I'm going to push. There are true conditions. The first one was this, that the size should be less than, okay. And the second one was that the topmost element should be greater than the element added should be greater than the topmost element, okay. Now let's see the another operation which says that if pq.size is greater than k. Now suppose we are in this scenario, okay. Suppose it was 4, it was 5, it was 10, it was 8. So this is a pop operation basically, okay. So pop operation what's saying that if the size is greater than k, we are not maintaining the heap.
So we are gonna pop the topmost element. Now I'm gonna say that add function is all over here. Okay. So in the add function, what I'm passing a value parameter. Okay. So in this value parameter, what I'm saying that I have to add the element. Okay. Now I'm adding, suppose say our size is maintained all over here, and I have to add an element called 9. Okay. Void add 9. So in order to add 9, I am passing this parameter called val. Okay. And I'm saying that if pq dot size is less than global was equals to k. Now I wanted that variable to pass on to this function also. So I just made it as equal to k, and I'm telling that if the size is less than the global is less than, then I'm pushing the value. Okay, basically. And if pq dot size is greater than global, then I'm performing the pop operation. So basically this was the same code which we have copied and pasted from here, but with different global variables. So same parameter of adding. It is pretty much easier this time to comprehend like how this addition operation is happening, because if you would go once again to that diagram, okay, let me just show you that in this scenario what's add operation, suppose 10 has happened. Okay, so in this we are saying that the size is greater than k. Okay, so we are popping it up. Okay, so two operations are happening at the same time. First, kth largest is being called, and second one you have to add it. So adding a value or an element and popping up at the same time. Okay, so we are adding 10, 10 goes down. Now we are calling which is the greatest largest. Now here is a one condition that the size of this is greater than so pop operation is happening, which is written in the last code. And in this case, in order to add an element, so what we have written all over here in this code is this, that pq dot size should be less than global. So push the value. If the size is less, okay, suppose in the add operation initially, so the size, basically the size of the priority queue, if the heap is also less, then you should add the value or push the value. Pretty much simple, guys. This was a pretty much easier approach and a good problem to understand. So what at the end of the day, what I would suggest you, that sit up with pen and paper. Okay, try to solve at least 5 problems in a day. And when you are trying to find an approach or trying to go for a hit and trial approach, it's pretty easy, it's pretty good. I would say it's very good to make mistakes, but it's not good that if you are not trying. So just seeing the solution won't solve your problem or won't give you a way of analytical thinking to solve a problem. Solve as much problem as you can, but try to solve by yourself. Then you will figure it out what is the optimized way to solve the problem. So these were few of the interview questions, some of the mid-level interview questions which was asked in the interview. I hope so you would have got a fair idea how to solve a data structure interview questions, which was kind of a hands-on one. Okay, so these were the code.
Just a quick info, guys. Intellipaat offers full stack web developer course in collaboration with E&ICT Academy IIT Guwahati. Through this course, you can learn everything from front-end web development to back-end web development from esteemed IIT Guwahati faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of web development.